Hi everybody, welcome to our Java crash course. What we're going to be doing is teaching Java in a series of lessons to take you from little or no knowledge of building Java web applications to building a full stack application at the end of all of these lessons. We're going to be learning how to set up a Java development environment. We're going to use Java 11 and Visual Studio Code, and we're going to go through the Java language basics and programming fundamentals. Now, the great thing about that is not only will you be learning Java, you will also be gaining knowledge that can be applied to other languages, such as JavaScript or Python or other languages, because programming languages are pretty much the same at least the fundamental level, and everything else is just syntax differences. So the syntax is different in Python versus Java. So you'll be able to take your knowledge that you gain here to other languages if that's what you want to do. By the time you're done with this, you'll have the basic building blocks to build Java applications. And so we've got 8 exercises scattered throughout the lessons, and we've got various things that we're going to be learning here. So our stack is going to be a little bit of HTML and JavaScript. We need that to kind of test out our backend layers. And then we're going to be focused on the Java language, and we're going to use a little bit of Spring Boot as our application server. And that's for the final exercise. This one, web server address book, is what we're going to build there. And a couple of things on the lessons. So the layout is basically, they're all on YouTube, all YouTube videos. And we're just basically going through these instructions, which are also pasted on YouTube in the on the description for the videos. But you can go through it here and play the video and watch along as you go through the instructions. Now we're going to learn a few things about Java. Like I said, we're going to set up the development environment. We're going to do the classic hello world. We're going to learn about anatomy of a Java class here. We're going to call functions and learn how to do that, running the Java application. We're going to go through the different variable types that are built into the language, and we're going to do a couple exercises with variables, and then we're also going to learn about math operators and precedence and the math class, and we're going to do another exercise with math and formulas, and then assignment operators, logic operators, branch logic, if-else statements and switches, loops and while loops, and we're going to build a calendar with loops, so that's an interesting exercise. And then we're going to get into the object-oriented principles with Java. So we're going to go over objects, member access, and object-oriented concepts. And then we have our 2 exercises down here at the bottom. So that's the layout of this Java crash course. We're going to be doing other courses, HTML, CSS, and JavaScript, so that way we can teach full stack development through a series of courses. These will all be posted on YouTube and on this website here. Please like and subscribe to the channel and like the videos so we can keep this going. All right, thanks a lot, and see you in the lessons. Okay, let's install Java 11. Now the first step in setting up our Java development environment will be to install Java JDK. And the first thing we need to do is to check to see if we even have it. So we're going to open up a terminal window and run a java-version command. So let's go into our terminal and we'll paste that command in. And when we run it, we see that we have no Java runtime present. So we're just going to OK that dialog there, and let's go back to our instructions to see what to do next. Okay, if we did have Java installed, we would have seen something like this. What version it was and what runtime was installed. And since we don't have it installed, we ended up getting no Java runtime present as the message. So let's go ahead and install Java 11 following these steps. So we're going to go ahead and go to Adopt OpenJDK, and we're going to choose the defaults, which is the version Java 11 and the hotspot VM, and then we're going to follow the prompts once we download that release. So let's go ahead and open this link in a new tab, and here we are at Adopt OpenJDK, and you can see here already selected is Java 11 and the hotspot VM we wanted. If it didn't detect your operating system correctly, which it did here for Mac OS, you could just go to the other releases, and then you can see here that the operating systems are supported: Linux, Windows, and Mac OS. So let's go ahead and go back to what was detected for us, and you can see here that Mac OS was detected, and that's good. So let's go ahead and click on latest release, and that's going to download. Okay, that's downloaded, so let's go ahead and click on that once we've checked our instructions to see what to do next. So we're going to follow the prompt. So let's click on it, and it's going to open the installer package, and we're just going to go ahead and hit the continue button and accept the license. And then we're just going to go ahead and click install, and I'll have to enter my password, and then it starts installing. Okay, that's all finished, and we don't need it, so let's just go ahead and delete it. So now what we want to do is go ahead and run that Java version command again in our terminal window and see what we get now. So we'll paste, and there it is. Java 11 is installed just as we wanted. Okay, now let's install Visual Studio Code. It's a nice code editor. So the steps to install is we'll be going to visualstudio.com, and we're going to go ahead and download and extract the binary, and we can run it from where it is, or we can move it to our applications folder. So let's go ahead and open that in a new tab. Okay, so here we are on Visual Studio Code's page. You can see it automatically detected our operating system, and it would detect Windows and Linux as well. So let's go ahead and download that. And while it's downloading that, you can look at their webpage. It's a really nice code editor. I like it. It's lightweight. You could use a full-blown Java editor such as IntelliJ's IDEA. But for now, let's just go ahead and keep it light, and we'll use Visual Studio Code. Okay, that's done downloading, so let's go ahead and click it to extract it. And it extracted into our downloads folder. So I can drag it over to my applications folder, or I could just go ahead and launch it from here. I'll click open. And now here we are in Visual Studio Code. Okay, so the first thing I'm going to want to do is go back to our instructions, and I like to work on the command line, and we did all these steps. So I like a command line launcher. It's hard to say. And so the keyword code will launch the editor for us. So let's go ahead and close that out. We don't need it. And Command-Shift-P opened the palette for me on OS X, and I'm going to type the word code even though it showed up on the top there. It might not show up on the top for you. And that installed code on the path. So if I type that word, it'll launch this editor, and that's typing it in the terminal window. Okay, the next thing I want to do is install the Java extension pack since we'll be developing Java. So again, I'm going to do Shift-Command-P to open up the palette for all the commands, and then I want to install something. So I'm going to type the word install. And then we see install extensions. I like that one, so I'll click it. And now Java is what we want to install, and the Java extension pack is the one that we want. So let's click the install button here. And it's going to install several extensions for us. I got a pop-up message that said something about Java in my workspace. I'll click later on that. It's because I've done this before. You probably won't get that message. And now we got a message that says that we're in lightweight Java mode. Now, we probably want as much help as we can get. So switching to a heavier weight mode will probably work better for us, but I'm not sure about that. Lightweight mode might be enough, but let's go ahead and put us into a heavier mode that gives the editor the ability to help us even more. So I'll click on that, and then it says, are we sure we want to switch to standard mode? And yes, we do. Light mode would be for those who are more experienced. And I have a Docker message on there. You might have that too. You just close all the messages that don't have any relevance. Alright, so we've got the extension pack installed, and it looks like we're all done here. Hi everybody. In this lesson we're going to create our very first Java application. It's going to be very small and it's Hello World, which is typically the application that most languages start you off with. And so we're going to follow suit here with Hello World. And don't worry about the Java specifics here. The point of this exercise is really just about creating the file, compiling it, and run it. We'll get into the specifics later. I'll describe some as we go, but really the focus is on creating the file, compiling it, and running it. So here we go. All right, so let's open up our Visual Studio Code editor that we downloaded in How to Set Up a Java Development Environment previously. So I'll just click to open it, and it typically starts off with a Welcome tab. It might not if you told it not to do that, but New File is an option here. Also Command N on Mac, and I believe it's Control N on Windows will create a new file, or there's also the file menu up above as most applications have. So File, New File would create a new file. So let's go ahead. I'm going to do Command N. I'm on a Mac, and that gave me a new file. I'm going to close this Welcome. And so I've got Untitled -1 here, so I want to name it something else. And if I type the word that I want here, and it's Hello World, .java, and that's the source file. So let's flip back to the lessons plan because I jumped ahead a little bit. How to run this Java application down here. To run this Java application, open Visual Studio Code, which we did, and create a new file named hello world.java with the content above. So that's what we're doing right now. So if I type the first thing here and I hit Command S to save it, or Control S if I'm on Windows, it'll go ahead and pop up with the words that I typed here. So it's just a little shortcut to getting us. Otherwise, I have to navigate and type in the name here. So it's just easier to do it there. So that's just a little trick that I do. Save, and then it's going to want to replace it because I already tried to do this before. So let's go ahead and replace. Your dialog won't say that you had it before unless you did try it and you're trying it again. Okay, so now we don't need this. So I just highlighted it all and deleted. So let's go back to the instructions for the lesson. And we did the first one. So the next one is to open a terminal window in the folder we saved the Hello World Java source file. And we're not at that step yet because we actually need to put the contents above in our file, which we did not do yet. So let's go ahead and do line by line. I want you to type, not copy and paste, because we're going to build muscle memory on these Java keywords and get used to how things are formatted. And your fingers will just do the typing for you in some cases once you get good at building that muscle memory. So public class Hello World defines this class. Hello World uppercase H, uppercase W is the name of this class. And we're going to go ahead and type that out. So public class Hello World. All right, and that ended with a curly bracket. And you'll notice here that the editor helped finish the brackets with the end bracket, and this ends up making our class body. So in between these brackets is called the class body, and the class is called Hello World. Java classes typically have uppercase letters for the words, so they're readable. All right, so what's the next line to type out? Our next line is public static void main, and that's where Java applications typically start off. That's the entry point. When you run the application, it starts off and comes in here, and then it starts running the application. So public static void main is the first thing we're going to type. So let's do that. And you'll notice that the editor is helping us because we installed the Java extension pack before. So that's public static void main, and this has to be called this with these words here so that it actually executes properly. And the next thing is open a parenthesis. So these are where our parameters come in. Parameters are arguments that we pass in that can be used within this function body. And we're going to start off with a string array. And so this is the class string, and then square brackets to start off an array. So let's go ahead and type out that. So we have a parenthesis, and it finished the end parenthesis for us, and uppercase S for string, and then 2 square brackets, and that made a string array. You can put a size in here, but because we don't know what this is going to be and we're not actually declaring it for our use, we're actually taking it in that came in from the environment. So we're just going to leave it like that, empty. And args is what it's called for the variable name. We can call this anything we want to, but typically it's called args. And then we're going to go ahead and start off a function body with a curly bracket, and the editor will finish that off for us. All right, so what's the next line? The next line is system, which is a built-in Java class. And then when you want to call or access a member of a class, you're going to use a dot or a period to point that you want one of those things. And then you can do that again. Since this one's a property, we're going to go ahead and do another dot to call a function. So let's do system.out.println, and then we'll get into this part after. So system, and you'll notice it helped us. So here I could stop typing and actually just hit enter, and it would get that for us because it's noticing that this is the Java system class that we want in the java.lang package, which we'll learn about later. So I'm going to keep typing though because I'm trying to learn how to get my muscle memory. So system.out. All right, and so you'll notice that the editor is helping us again. At least we're getting confirmation that we're typing it right. So then we do out and then print line. Okay, and so that's that. And let's go ahead and flip over to the instructions again. And we're going to open a parenthesis and then type in quotes. So double quotes is a string literal in Java, and we'll learn more about that later. So we're going to type in hello world in double quotes and then close with a parenthesis. So let's do that. So open parenthesis, open double quote, hello world. And exclamation point was what it said there. And then all Java statements end with a semicolon, or at least most of them do. So we'll put a semicolon there. And you notice that if it's not there, it shows up kind of curly with red underneath it. And that's showing us that there was something wrong. Okay, so now get in the habit of hitting save. So Command S is almost something I automatically do. So that's what I do after I type out a line or something that I'm happy with. I'll hit Command S. So if anything happens, I accidentally destroy and paste over all of my typing, it won't all be gone because the file is saved. Or if the editor should crash, which doesn't happen very often, but it used to in the old days. All right, so we've got that all done. So let's go ahead and flip back to our application. And it looks finished to me. So then what's the next instruction, which we read before? So we're going to open a terminal window in the folder we saved the file in, and let's do that next. So I'm going to open up a terminal window, and I'm in my home folder, which is where I believe I saved that file. So if I ls, it's dir on Windows, I'll see hello world.java, which is the one we're looking for. All right, so what's the next instruction? Okay, so we opened the terminal window there. Okay, now to compile the Java source file into a class file, which is an executable or runnable in Java, we're going to use the Java C command and then put our Java source file. So let's go ahead and do that. C hello world. And if I hit tab here on Windows and on Mac or Linux, it should finish it for me. So let's go ahead and do that since we're at the file system. So hello world.java is what we want. So then I'll hit enter here and it'll compile. Now it just returns if there was something wrong, it would give us an error. Okay, so then what's the next instruction? Let's go ahead and take a look at that first just to see. All right, so when we do ls now, we see here's our Java and here's our class file. So that's exactly what we wanted. Okay, so now the next instruction is to run this Java class file with this command, Java and hello world. Remember the case, uppercase H, uppercase W. Let's go ahead and do that. And I'm gonna hit tab again and see it tried to, with tab it tried to finish the file name for us. We don't use the dot when we're trying to execute the program. So we go ahead and backspace that out and then hit enter. And you'll see that our string came out, hello, comma, world, exclamation point. So we actually successfully had run this application, and here's the sample output just as we got. And we'll learn more about running Java applications later. They get a tiny bit more complex than this, not much, a little bit more to learn about running them, but we'll keep it simple for now. And the nice thing about running Visual Studio Code with the Java extension pack is we don't always have to open the terminal window. So let's go ahead and do that, because that's a little bit easier. And then when we actually really want to run our Java application, then we'll go through the trouble of opening a terminal window. So let's learn how to do this in Visual Studio Code now. So I'm going to go back to Visual Studio Code. And you'll notice when we finish typing out this line here, Visual Studio Code gave us these options up above. One's for run, and that's to run it. One's to debug. Now, I usually do debug because I sometimes debug the application, so I just always run debug here. And let's go ahead and click on that here. And it will compile in this terminal output here. So it compiles it for us. And I have a breakpoint set from before. So I'm just going to close that, and we'll learn about that again after. If I do have a breakpoint, then this play button up on top will do it for me. So I'm just going to click that. And here's our output, hello world. So let's go ahead and run that again without debug on. And I'll click. And it's going to run it again. So there's hello world. So let's go ahead and do it with debug again so that we see what it does. So you'll notice over here by the numbers, if you move your mouse, a little dim red dot appears. So and it'll do it on code that's executable. So let's do it on line 3, and then the dot gets brighter. So now if we debug again, it stops right here, and we can inspect certain things. We don't have much to inspect here. We can see our args by hovering over it, and it's empty, so there's really nothing in it. But when we get more complex, we'll see how to do that. But this is debugging an application, so we run that, and we get hello world again. And you can just hit run. Even if we have a breakpoint, it'll just go ahead and run and ignore our breakpoint. It cleared the terminal window, and then it went ahead and ran our application. And that's running it in the terminal window of Visual Studio Code, so we don't have to open the terminal window in Windows, Linux, or Mac OS. And that's the end of our lesson. Thanks for watching. Hi everybody. In this lesson we're going to learn the anatomy of a Java class file. So Java source file basically is a bunch of programming in Java that you name something.java. And so what goes inside of that file is all this stuff. So let's go ahead and describe it. So this is a comment, or at least one way of doing a comment with // and then you go ahead and type what you want. There's other forms of comments dealing with slashes and stars. Let's just keep it simple, and let's just do the double slashes for our comments for now. What's usually at the top of a Java class file is the package statement. So what this package statement does is it helps you organize your Java classes into a folder-like hierarchy. And these, in fact, do become folders on your file system, except they're not separated by slashes in the Java source code, but they do end up with slashes in the on the file system. So com.fullstackclouddeveloper.tutorial would be com/fullstackclouddeveloper/tutorial, and then the file my first Java application.java would be in that folder. And that's how the packages work. So and there's protections around package. So a package can see the files within its folder, but it can't see the files within other folders unless they're called public or something that allows them to see them. So folders are separated. Okay, and we've got an import statement, usually comes after the package statement. And an import statement here is using a JSON builder to take in as a class that we will use later on in the code down below. And this is something that's in another jar file, which is a Java archive. A bunch of Java class files get compiled and then bundled into a jar file, and a jar file can then be included in your application, and then you get to take advantage of all the classes that are built in. Java has a ton of library classes that you can take in and build your applications with, which makes the ecosystem very helpful because there's so much out there, and you can build on top of all of those. And so this is how you bring one in. So this one basically turns a class object into a JSON string, which is pretty much the way websites communicate data back and forth these days. And so that's an import statement. The class declaration, class is the designator here, and then here's the name. My first Java application, notice the uppercase letter of the first letter of each word, and that's how Java names their classes. And then we've got the public keyword here. Now public on a class declaration means that any Java class can see this. So basically any Java thing in the world can see this class and instantiate it if there's if it's allowed to be instantiated, but they can see this class. Whereas if you left that off of there, and that's the other option, it becomes a default access, which means that only files within this default package, which is basically empty, no folders, can see that class. Otherwise, that's pretty much it. The next thing we see in here is a variable member. So it's a member because it belongs to this class and it's in that scope. So this curly bracket here starts the scope of the class and it goes down to the bottom. So anything that's inside of these brackets is visible within to other things within those same brackets. So this is private, so you can't see it outside of the brackets, you can't see it outside of the class, but you can see it within these brackets. So there's the string name, and string is a class that we'll go over later on. It's how you type words, sentences, paragraphs in Java. Okay, so public static void main is what we saw in Hello World, and that is the entry point for an Java application. And it takes in a string array of arguments, so you type at the command line whatever the name of the application is. In this case, it's my first application. So we would type Java space my first application space whatever parameters we wanted to pass in, and they'd all come in here in a string array, and then we could just go ahead and take them out with the index 0, 1, 2, 3, 4. Here's a string variable declared name within the scope of this function. So this is the function scope here, whereas we were looking at class scope before. Now remember, here's the class scope variable named name, and it's visible within here. So what's bad about this is that there's a variable name that is hiding this one, because this one is visible in this function, but because there's one named here, when you're down here using name right here, it's using this name and not that name up there. If you want to use, and I should have said that backwards, this refers to this instance of class. So if I wanted to use this name here, I'd want to put this dot name right here. So this is actually bad practice right here, and it's a good example of things that you shouldn't do with variables, and it shows an example of how the scoping works and how you have to be careful to make sure your names are unique, because if you have them be the same, then it kind of gets confusing. But this is legal, and it'll compile just fine. It's just not good practice. Okay, and here's we're calling the constructor with the new keyword here. So we're constructing this my first Java application object with the parameter name, and it's going to go ahead and set that name in the constructor, and we'll see that down below. And then we're going to call a method on this one called print, and it's going to print a message out to the console, and then we're going to call a different print that prints it out as a JSON string, so print as JSON. And these are methods, and we'll get into the difference between methods and functions in a minute. All right, so here's our class constructor, and you could have many class constructors. This is one, and it's taking in a name. And now you see name here as a parameter, and name here, and then you see name again here, which is referring to this dot name. Now this is okay, and this is actually good practice because it's the parameter name that's coming in, and that one's fine. And then here's the instance name. So this is actually good to use because we know what this one is actually going to. So if we had many of these coming in, we would know how to line them up. It's when you're hiding a variable that's bad. And in this case, this does not hide the variable. Okay, let's see. Next thing we have here is a function. So this is a private function, so it's only visible within this class. So within the class scope, there's a function called getMessage that returns a string, and that's what makes it a function, is that it's returning something, returning some an integer, another kind of number, a string, an object. As long as it's returning something, it's called a function. And it takes in a name parameter, just like the other ones above. And this one is actually returning a string, hello, name, exclamation point, and that's what that one returns. So that's a private function within this class. And then here's a method. So what makes this a method is void. Void is basically nothing. It's saying this function returns nothing, which then makes it a method, at least in what we call it, a method. And this one's also private, and it doesn't take any arguments. And within its body, it's calling the other private getMessage to get the message here with a name parameter. Now this name is visible, and it's the class instance name because there's no other name in the area, so it's this one. So you could put this dot name and it would be equal to the same name. And then we've got another function call. This one's calling the system, built-in system class. As a static member here is out, which is probably the output console. And then print line is printing the line to the console, and it's going to print that message. All right, so that's a function. And here's another method here. That was a function call. Here's another method here, the print as JSON that we saw above. And this one's calling system as well. And now it's making use of that class that we imported. So it's instantiating it with new JSON builder, which is the object that has a set pretty printing function on it, which formats the string nicely, which returns something that has a create, and which returns something that has a toJSON. And so that's pretty much the anatomy of a Java class. It looks longer than it really is just because of all the comments that are written. It's actually quite a small program and there's not much to it, but there's a lot of explanation in here, which is all specified down here below. Packages, we go through imports, class declaration, just like we went through, the constructors and variables, and then functions versus methods. So it's all written down here, what we talked about in this Java class example up above. And so that's the anatomy of a Java class, and we'll get into that more as we learn a little bit more going through the lessons. Thanks for watching. Hi everyone. In this lesson we're going to learn how to call functions in Java. So we'll be setting up a class that calls a function of another class, so you learn how to call functions in other classes. So as we learned in the anatomy of a Java class, functions and methods are basically the same thing, except that a function returns a value and a method does not. Now you can call either the same, although one can assign a value, it doesn't have to, even if it returns one, and the other can't assign a value, and that would be a method. So to call one, all you have to do, if it's a function within your own class, you just call it by name, and you say get message in this case, what parameter it takes, if any, and then assign it to a value. That's optional. You really don't have to assign it to a value if you're not going to use the value. Or you can be really explicit and say this get message, and then that'll call that function. But really you don't do this unless you need to, because there's another get message somewhere in there that's scoped funny, although that should not happen. Okay, and then calling functions on another class, what you typically have is another class that's an instance of the class, or it's a static function call. But let's just go ahead and go with the simple case right now, and that's creating another instance. So here's another class being instantiated, and then here we're calling on other dot get message and the name. So that's how you would call a function in another class from a class. And so now we're going to do an exercise on setting this up. And the exercise is to create a new class called greeting. So you're going to do this and refer to the previous lessons if you need to. You're going to create a greeting.java class file. And here is the body of it. And again, you want to type that out, okay? And then you'll be creating this mostly on your own. Yeah, there's a lot of text here that kind of describes what's going on. So you're going to create this greeting. It's going to have a function that returns a string, and the function name's hello, and it's going to call hello world. So it's the same thing. We're really just replacing our call in our hello world exercise from up above in the hello world lesson. And we're going to replace it with greeting. And so here's what it'll look like down here. So we're going to modify the hello world application, and instead of having it be, this is the original, instead of having it say system.out.println, we want to call greeting.hello and replace this part right here. So that's the exercise. Pause the video here because I'm going to actually do the exercise in the video, but go ahead and pause the video now and try to do the exercise yourself, and then hit play again and you'll see us doing it in this video. Okay, go ahead and pause. Okay, so now we're unpaused, or you're unpaused, and we're going to go ahead and implement this function. So I'm going to go ahead and open up Visual Studio Code, and that is not where I want it to be. So let's move it so you can see it. Okay, so we've got our original Hello World application here, and there's the hello world. Let's go ahead and run that. And in our terminal, it's going to compile, and then it's going to hopefully put out hello world somewhere. Oh, I've got a breakpoint because I'm debugging, so let's go ahead and just let that run through after I remove that dot. Okay, hello world, so it still works. All right, so what I want to do now is close some of these windows so we can see better. All right, so that's all gone. Let's go ahead and see what this file system looks like. I am not in our project. I don't know if that really matters at all. I don't think it does. So if you're not in the project, don't worry about it. We're just going to go ahead and create another class. So we've got our original hello world, and if you don't have it, just go ahead and copy and paste it in to get it here, so and save it as hello world.java. In the whatever folder you're in, it's fine. We're not using packages yet, so it's a folder hierarchy isn't important. Just as long as the other class is created in the same folder that this one is, which it should be automatically if you're using VS Code to do this. Okay, so we've got our original and it runs. So now what I'm going to do is create a new one called greeting, right? Because that's what the instruction said. It said create a new class named greeting with a function called hello that returns a string hello world. So let's go ahead and do that. All right, so I'm going to create a new file here. So I'm going to hit Command New because I'm on a Mac, and that gives me a new file, and I want this to be called greeting.java. And then I'm going to hit Command S to save, and then it's going to save in whatever folder I'm currently in, so that should be the same one as hello world. So now I don't need this, and now I'm going to do this and create this greeting.java class file. Now I can refer back to here if I want to, but I'm going to try and do it from memory. So it's going to say public class greeting. I'm going to type it out to you. I'm not going to copy and paste. Public string hello is the function, return hello world, and 2 brackets. That shouldn't be too bad. So here it goes. All right, so I need a public class because I need a class and I want it to be visible to everywhere, and it's going to be called greeting. And then I'm going to open the bracket, and it's going to do that for me. Now I want a public function because I want it to be called from another other classes. And it's going to return a string, and I want it to be called hello. And then it's a function that doesn't take any arguments, I believe. Let me go check that really quick. Nope, no arguments. And then we want it to return, and if you hover over the red part here, it says, it gives us an error, so that's kind of nice. This method must return a result of type string. So it's kind of a little reminder, so that's nice. So we want to return, and then we're going to say hello world. And don't forget the semicolon at the end. All right, that should do it. So I hit Command S to save it, and so now this file is saved. Notice there's not a debug or a run link up here because this is not an executable class because it doesn't have a public static void main method. But our hello world one does. So we're going to go now, the instructions say to replace the hello world literal string with our greeting class and call the function hello. So let's go ahead and do that. So let's go to our hello world, and we're going to replace the words, the string literal hello world with a new greeting. And notice how it finished it for me. It found it in the same folder. So greeting, and then I want to call the function hello on this. Dot hello, and there it is. And I'll Command S to save it, or Control S if you're on Windows, and then I'm going to go ahead and run it, and we should get the same result. Okay, it spit out hello world. How do we know it's different? How do we know it's not just running the same one and this isn't happening? Well, we can experiment. You can do anything you want. You're not going to break anything, so let's go ahead and do some experimentation here. Let's go to greeting.java, and let's say hello. How about Bob? Okay, and we'll save that. And then let's go back over to here, and let's run that and see what changes. Now it says hello Bob, so it's definitely running our greeting. So let's make it say something else. Instead of hello Bob, let's just make it say anything. This is fun. All right, and I'll save it and then run it. Okay, so that's how you call a function from another class that's in another class. And also remember to use the keyword to instantiate that other class if you're not calling a static method. But forget I said anything about static methods. We'll get into that later. Okay, that's it. Thanks for watching. Hi everyone. In this lesson we're going to talk about variables in Java. Now Java is a strongly typed language, which means you have to specify the type strongly because it's not like Python where the variables are can be various types. Same thing with JavaScript, right? A var variable in JavaScript can be an integer, it could be a string, it could be all kinds of things. Well, in Java it's strongly typed, meaning it has to be a type that they specify. And now an object can be anything, but that's pretty much the only thing. Anything other than object has to be the type that it's supposed to be as far as it's declared. Now, the types that are built into Java, there's primitive types, and then you can create many different objects, and those are also types. And Java provides many of those, and we'll get into those in a minute. But let's talk about the primitive types first. Now, primitive types are building blocks for building your applications. Variables are very important. Without the variables, you can't really do much with a program. Branch logic won't work on static numbers like 5 and 6. Someone has to be able to enter a number in. It gets stored in a variable, and then you do some logic on the variable. So variables are very important in any language. So the ones that are primitives in Java are integer types. And that's a number without any decimals, right? And so they have integer, they have long, they have various sizes of numbers without decimals. But integer and long are the more popular ones. And then they have variables that have decimal values, so numbers that have decimal values, and that's doubles and floats. And then they've got true, false, Boolean. And then they've got byte, which is a very small piece of data, so things are all made up of bytes. Like an integer is made up of bytes, a long is made up of so many bytes. So byte is the smallest unit, but you can use it and define it and set it as a variable. Short's a little bit bigger than a byte, and then there's a character, which are the basic building blocks of our string arguments. So strings are things like these words here, any of these letters. So a string is a bunch of characters all strung together. So that's why they call it the object string that characters make up. And we'll get into string in a little bit. Okay, so now we've got a definition of these. Now, integer is for whole numbers. That's not a decimal. And if you just type a number in Java like 5, its default type is going to be integer. And that's what this one is proving here. Now, object can be anything, right? So you set the object equal to 5. We don't know what the type is yet, but if we go ahead and inspect and see what the name of the class that O is holding, we see that it's an integer. And then we can go ahead and test integer and see what the maximum values are. And I don't know what that is. What is that? 2 million? Or 2 billion? Looks like 2 billion something. So there's a min and a max, right? So it goes to negative and it goes to positive max values. Now, a long is the same thing, just a lot bigger in value. And I didn't put the value down here, but it's a lot larger. But same things. Now, you can't just say 5 and expect it to be a long. You have to put something in it to make it a long, unless you declare the variable type as a long. We'll see that in a second. But so 5L means I want this 5 to be a long. And if we store that in the object and then inspect the object, we see that it's now equal to a long type. And the long value, that could be part of your exercise. Take your Hello World program that we worked on before, and then go ahead and do the min and the max and see what it comes out to be. And I think that's what will make the exercise for this one. We'll do a bunch of variables and we'll do some things at the end of this as our exercise. Okay, so a long, if you declare it as a long and then you just set it as a number, you don't need the L anymore because it knows that you're setting it as a long. So then it'll turn that 5 into a long, and it's equal to 5L, which is a long. Okay, and now double, that's the decimal number. Now, that's it's like long is the biggest int primitive, and double is the largest decimal primitive. So again, any of the decimal numbers that you specify without saying the type at the end here, or without declaring its type, is going to end up being a double. So 5.2, for example, has a class name, if we check it, of double. And double is a big floating point number, which is really large. We'd have to see what that number comes out to. Maybe that could be part of the exercise too. Make this number not be exponential so that we could see how big it really is. And if you want to declare a double, you could just declare the variable double, d equals 5.2, and it'll be equal to the double value. So that 5.2 got turned into a double just by declaring the type. Float is a smaller type, so double is to long as float is to integer. So it's a little bit smaller. So 5f will define this 5 as a float, and we can see that here if we inspect the object. And then the float values are smaller than double, and we should also make that an exercise to do that as well. And so if you declare it as a float here, it'll go ahead and make that 5 a float type. Now Boolean's for true false, so yes or no, and that's just true or false. Set it to the object, it comes out as Boolean, and you could just define it Boolean b equals true, and that's how that works. Now bytes are small, right? It's the smallest building block, and it's a very, very tiny integer. But it makes up, a byte basically makes up almost everything in the, everything stored as a byte. So this is the basic building block here. So we can declare the byte as a 1, and then go ahead and capture the object with the byte and see what it is, and we see here that it's a byte. And then the value ranges from 127 positive to 128 negative on that. Now short's a little bit bigger, so it's a smaller integer. There's no decimals. And then so you declare it as a short, and we capture the object, and we see short, and then it's about what, 32,767. That's the traditional old-time integer. I don't know how many bits that is, but it's 16 maybe, I'm not sure. All right, so and that should be another exercise that we do. So character is the basic building block for strings. And so you declare a character with a single quote. So I want A to be this character. And then we check the object class, and we see that it's of type character. Now, characters are also integers. You've probably seen an ASCII2 chart. They've got a number representing a character and then the character itself. So A is actually represented by the integer 97. So then we could see here, just by declaring an int with the character A, we're going to actually get 97, which is the ASCII code for A. And then we see that it's an integer type. Okay, now strings, they're sequences of characters. And so they make up words, sentences, and more. So if we want to store someone's name, their password, their username, their name, their street address, those are all stored in strings. And a string is simple. You just double quote and type whatever you want to in here. It doesn't have to be a single word. It could be space, it's sentences, anything you want to type in there, pretty much. Special characters have to be escaped if they're in there, but we'll get into that later. All right, and you could also create a string this way. No one does this, but you could do it with new string hello. And actually, we do that somewhere in these tutorials. I remember needing to do it somewhere, and I don't remember the case, but it's a very rare thing that anyone types new string. Okay, and then another way to do it is to actually make the character array that makes up these letters. So here's the characters that make up that string, and there's them individually. And then you do new string characters for the array, and it'll go ahead and make the hello string. Now, string is an object, so you can actually do operations on it. So you could see its length, right? So you can set 1, 2, 3. Now see, this is a string, and I could test the length on it, and the length is equal to 13. And I could set that length equal to an integer and do operations with whatever 13 ends up being. You can also turn it into the character array. So I've got hello and turn it into a character array. It ends up being the same array that we used up above. And then you could do things like substrings. So I can chop this string into something smaller. So I'm going to chop it from 4 all the way to the end. So I just do a substring starting at index 4, and I put the numbers up here. Java arrays pretty much start, and indexes start at 0 for the most part. So here is 0, 1, 2, 3, 4, and that's how it starts. So 4 is actually where this T is here. And if you do a substring 4, it'll go ahead and get 4 to the end. Now there's another substring that will do a range, right? So we've got 4 to 7. So I want to do, let's go from 4, which is the T, to 7, which is the space. Now the last one doesn't include, so it goes up to, so it goes from 4 up to 7. So it doesn't actually include 7. So it's going to pull out the word 2 here. Now starts with, you can, and there's lots of operations. You could look at the string documentation, which there's a link somewhere in here in this document. So now you can do, does it start with 1? True. And then you get a Boolean. Does it end with 3? True. And you get a Boolean. I can also replace something. So let's replace this word TWO with TOO, and then you end up with this string. All right, and so there's other things you can do. You can do a split, and you can split things. I'm going to split on space, and I'm going to pull out each of the individual words here. So I've got this sentence, and I'm going to pull out split. Index 0 is 1, the next one is 2, and index 2 is 3. So remember, 0 base, 0, 1, 2. Okay, and then we could get parts this way. So instead of doing the split operation multiple times and getting them this way, do it one time, assign it to a string array of parts, and then I could do part 0, part 1, part 2, and get them equal that way. Now reference types, those are in string is a reference type, although it's considered a literal because you can do this to it. So it's kind of a hybrid, but it's definitely a reference type, but it's one of the base types. It's almost primitive, but it's not. Okay, so reference types, and so string is a reference type, and we see that up above. It was included with the primitives because it kind of acts primitive-ish. So now there's date objects, very important class if you're doing anything with dates. And so there's Java support for good Java support for dates now. It was a little bit clunkier before, but it's gotten a lot better. So you can get now, which will get the current date and time. You can go ahead and start operating with it. You can add days. So I could take now, which was June 27th when I did this, and add 30 days. And then it comes out to July 27th. I can also get the month, and it says it's June. I could also get the day of the week, and that's Sunday. I could get the day of the year, so it's the 178th day. I can parse a date, so I could give it a string and actually get the date from it. And then I could actually format the date and get a formatted string like this, Saturday, May 29th, 2021. Okay, arrays. An array is a collection of a particular type, unless you do an array of object, which could be anything for each index. So remember, zero-based again. So here's an integer array, 1, 4, 3, 2. Now it stays in sequence order like this. And then I can initialize an array with 10 slots in it, and those slots will default to whatever the holding type's default value is. So in the case of integer, it's 0. So this will default to an array of 10 zeros. And then you can see here that I'm pulling out the first one from that, and it's giving me a 0. I could get the length of an array. This one says 4 because it's actually this one up here, not the one that I'm using there. And then you can see the indexes 0, 1, 2, 3 is how that works. And then same as we did above, you can get the array values out. And then here's array index 2 is giving me 7 in one of these. I don't know what that is. Let's see, what is this one? I actually don't know what this example is. Let's see. Oh, I'm assigning it. Sorry about that. Okay, so I'm assigning my array subscript 2, which would be this 3 over here, to the value 7. And then if I pull it out, it's coming out to 7. So the third value in is now a 7 instead of what it was, which was a 3. I could also add 2 of them together because remember, they're just integers. So I'm going to take 0 and I'm going to take 1. I'm going to add them together and get the sum. So that's a 2 and a 5, and it's going to come out to 7. Now a list is an array type, or it's an ordered collection, and there's various types of lists, and of course you can make your own, but the ones that are built in are stack, linked list, array list, and vector, and array list is the most popular. It's the one you use the most by a lot, at least I do. And then there's an interface list to make it simple, so you can just assign it to list and whatever the type is. Like here, this is the generic list, and here is an array list. Now this one is creating an array list of objects, so I can store an integer, I could store a character, I could store a string, I could store a float, I could store any object in here, and this type of array. And go through and read this in detail. I'm just going through it kind of quickly to get you oriented. Now as a typed system, you can actually define list. So this up here is the same as this default, which is saying it's an object. And as a shortcut, you don't have to specify the type on the right side, but you do have to put this inside to say that, yes, I am specifying the type that's over here. To create a list of integers, very similar, just say I'm going to do integer, and then that's the empty type that says it's integers, and then you just add them to this list here like this, and that's what it comes out to, and so you could get it as an array. Now you can sort a collection by using the collections class and just do the sort method on it, and it'll go ahead and put them in their natural order, whatever the objects are inside of that list. And then you can get the elements in a list just like you could in an array, but this is actually using a function because this is a class object type, and I'm just going to call get index 2 in this case, which is now 3 because it's sorted. and then I can find out the index of what value is 3 and what index position is it. So I'm going to say that, and it's going to tell me it's index position 2, which is this slot right here. And then I could get the size of the list, and it's equal to 4. Okay, maps are key value pairs. So there's a couple of those built in, and then there's lots of third-party libraries for array lists and for maps. Hash map for me is the most used one, and it's just key value pairs, so it's simple. You just do an interface map, and then you say what type it is. It's a hash map, and this is the equivalent of doing objects in this map. So I say put, and that's my key, and then my value is hello. So if I do a put on this, when I say I want the map element key 1, it'll return to me hello. And if I want the map element hi, it will return to me 26. And that's how maps work. And you can see that's how it comes out here. 1 is equal to hello, hi is equal to 26, true is equal to yes, the string. Now that's the equivalent here of mapping an object keys to value keys as far as objects. So object and object keys, object values. And then you can specify the types, which is what you normally want to do. You don't really want to use object unless you need to. So this was a string key, so I'm taking names and say these are tests. I'm taking someone's name, and then I'm mapping it to their test score. So here Ricky scored a 90, Lucy scored a 93, Fred an 80, and Ethel a 91. And so you could use it maps in that way. And so now I want to get the score for Lucy. So I just say map.get Lucy, and it returns me a 93. And then if I want to replace the value for Ricky, because there was a mistake, I just do a put again, and with the key, so it'll take Ricky and replace whatever his score was with an 89. And then if I say give me Ricky's score again, it'll say 89, whereas Ricky had a 90 before, so miscounted there. And those are maps. And those are all the variable types in Java. And now, of course, it's an object-oriented language. You can extend the language and make as many different types as you want, but these are the primitives and the ones that are most often used in Java. And so go ahead and go through this list in more detail. And as an exercise, what I'd like you to do is take the Hello World program that you have, and I'll go ahead and put this in the lesson plan here as an exercise. And copy and paste or type is probably the best thing to do. Type some of these into the Hello World program, and then do a system out print line on whatever the variable is, and see what kind of values you get. So just go ahead and explore and change things. See these words here? Go ahead and change them to something else, and then do a split. Split on something else, put commas in between, and then do a split on comma and see how that works out. So that's the exercise I want you to do. I'll get a little bit more explicit on some examples of what to do, but always just experiment and do whatever you want to do to learn. Don't just do what the instructor tells you to do exactly, unless you're handing something in, but always experiment and always try to grow your knowledge and see how things work. Okay, so I'll go ahead and make another cut of the video that adds the exercise. But that's the end of this discussion on variables. Thanks for watching. Hi, everybody. Okay, we're back for the exercise that was added to variables from the lesson we just had. So I'm going to scroll down to the bottom because that's where the exercise is. And you can reread through that because it's really just going over stuff that's inside of here, a subset of it, not all of it. All right, so in exercise 3, what we're going to do is print a bunch of variable values. So we're going to take our Hello World application that we modified, and we're going to modify it again, and we're going to print out a value that you make up, or you could use one that's already there, of each of the primitive types. So you're going to create a variable with, let's say, an integer, and then you're going to print it out, and then run it, and then see what happens. And you could keep adding to it, or you could keep replacing. It's up to you. We'll see how we do it. I'm not sure how I'm going to approach it yet either. Then, since I left off the long value in the lesson itself, go ahead and print out the minimum and maximum values of long and see what those are. All right, so for strings, we're going to create a sentence. So you can type out any sentence you want. And then let's see how long the sentence is, so how many characters it is. It'll tell you the length, and print that out. And then I want you to replace the third word, or whatever word you want. It doesn't have to be a third one, but that's just a number I'll throw out there. So replace the third word in the sentence with a different word, and print out the sentence and see how it's different. And then I want you to split the sentence into an array of its words. So create an array of the words. And then I want you to print out the array of the words and then print out the fourth word in the sentence, or, you know, you can print out any word you want. Just experiment. Don't just do what this says here. Mess with it. See what you can do with it. All right, and then we're going to do something with dates. We're going to create a new date that's, you know, now, basically, and then print out that date and see what it turns out to be, and then print the month or the year or the day of the week, anything you want to do. Go ahead and see what you can do with it, but month is a suggestion. All right, and then we're going to do lists and maps. So for the list, I want you to just create an array list of integers, add 5 numbers to the list in random order, so not in sequential order, and then use the collections class to sort the list, and then print out the list to see the new sorted order. So that's an easy one for lists. And then on maps, I want you to create an address book with a map. So it's going to be a string name and a string value, which would be the address. So you're going to add names for the keys, and you're going to add addresses for the values. And then I want you to print out the map and see what the address book looks like after you've added a few names and addresses. And then print out the size. It'll tell you how many entries you have in the address book. And then get an address for one of the names. So say Bob Roberts was one of the names that you entered in the address book. Get his address and print it out. Okay, that's those are the exercises. And go ahead and pause the video here, because I'm going to go ahead and go through it. See if you could do these exercises on your own, and refer to the video back if you need to. And then have fun. Okay, go ahead and pause the video. Okay, so we're back, and you're probably back. I'm going to go ahead and start these exercises. So I'm going to open up my Visual Studio Code editor, and I've got the Hello World program in the state that we had it before with the new greeting class. That was pretty cool. Okay, so that's nice. So I'm just going to delete this, and then it said in the instructions, primitives. So print out a variable value for each primitive type. All right, so let's go up to the top of this thing, because that's where the types are. And you could go through each one of these, like down here. I'm going to go through the list right here. So int is the first one. So I'm probably just going to do a bunch of them. So I'm going to declare an int, and I'm just going to call it I. You can call it whatever you want to, but I'm going to call it I, and let's say 17 is the number. And then I want to print that one out, so I'm going to do system.out.println. And I'm going to start using the help over here to speed up my typing a little bit. All right, so let's do I, and then let's go ahead, save, and then I'm going to run this. And you see 17 printed out. Now, you might want to play with it a little bit too, so let's do this just to see the type, because it's one of those things that we had, right? Where 17 doesn't really say anything about the type, but this will turn it into the type. So let's go ahead and do this one as 18, and then let's get rid of that I. We don't care about that right now. And let's do o.getClass.getName, and let's see what the type of 18 is. Is it an integer? Should be, right? Because that's the default type. So let's save and then debug that. Yep, it's an integer. All right, let's change it to a long. Just add an L. And yep, now it's a long. Let's do, and of course I'm going off the exercise now, but this is kind of fun. All right, so let's see if I could turn it into a decimal just by adding a D. And run it after saving it, and yep, it's a double. Okay, so let's go ahead and continue with the exercise, which is what I was supposed to be doing. But I want you to experiment as well. Okay, so back to the instructions. So that was int. So let's do a long, which we kind of did already, but let's go ahead and erase all this stuff and start over with a long. So long, L equals, long's a big number, but let's just randomly type in numbers here. And then I have to put an L here. I don't know why though. Oh, because it exceeded the length. Let's see what happens if we don't exceed the length. Okay, now it's happy. So I must have typed in a number here that was too big for int, because this is integer by default, right? It doesn't know that it's assigning over here yet until it's run. So I have to tell it, okay, that's a long. All right, and then let's print that out. That's a big number. And we'll debug. debug or run, and there's the number right there. That's pretty big. Okay, let's do, okay, that was long. What's next on the list? Double. So let's do a double. Now remember, double has a decimal, and that's the default type. So 8.9 is going to be the default type. So if I print that one out, and we're going to do D, and let's just run. We don't need to debug right now. So 8.9, so that works. Let's turn it into a float. So is that going to actually, do I need to put the F here or not? Let's see what happens. What's it? Mismatch. Can't convert from double to float. So it thinks this is a double, right? So we do have to put the F. Because remember, it's doing this right side type. So it says default for decimal numbers is double. So it can't take a double and turn it into a float, because a float's smaller than a double. It might not fit. So they throw an error there. And now we do 8.9. So that works. So we learned something there. So that's good. So a double is the number type over here, and the float's on the left side. You can't assign a double to a float. All right, so Boolean. Boolean is a true-false thing. And let's do true. All right, and that's going to print out true. It should. So we're not actually doing anything tricky here. We're just printing out what it is. All right, so what I want to do now, there's true. All right, so what I want to do now is do we remember do we do conditionals yet? Let's see, did we talk about those? We, anatomy, we did calling functions, running variables. Okay, we didn't talk about conditionals yet, so I won't do that. Let's see, so that's it for Boolean. What was the next one on the list? Byte. So how do we get a byte? Do we just do this? Would that work? Where's the run thing? There it is. Yep, that works. So that's 1. Let's see, 45. Okay, how about a number that's bigger than byte? Because I think byte went to 127, is that right? So you could always just go to the definition down here, and 127. So let's see if we can set it to something bigger than 127. Let's go 129. And what does it do? Doesn't like it. Oh, because now it's saying it's an int to a byte. So if I made it under 127, would it work? 126. Does it do the conversion then? Yep. So if it's greater than the byte, it won't convert it. So the maximum of the byte was 127. So going over that said, okay, no, it's an integer. It can't be a byte anymore, so that won't work. Oh, that's neat to know. Okay, so let's do the minus side of this thing, and I think it's minus 128. And let's go ahead and run that. And obviously I'm doing more than it says in the exercise, but that's what I want you to do too. So this is going to do the same thing with the integer. Yep, can't do it because it's trying to convert from an int to a byte even though it's negative. Okay, very good. All right, so Boolean. And what's next? Short and then char. All right, so let's do short. There's an uppercase short and there's a lowercase short. The uppercase short is a object or a class, and same thing with uppercase L for long, uppercase D for double, and then those actually have operations on them that you can do. And we can experiment with that since we're here. Might as well do something fun. All right, so 1, 2, 3, 4. Will short fit in that? And I think I'm making this exercise video take a lot longer than it should because I keep experimenting. All right, so let's run. 1, 2, 3, 4. Let's go bigger. Oops, those are letters. All right, that definitely won't fit in the short, and it's already complaining. It's out of range, too big. Okay. Well, we did one already, so let's do char was the last one, right? So we're going to do char equals, or C equals, how about A? How about A? All right, we'll run that, and that's going to give us a C. Or, I mean, an A. Sorry, the variable name is C. And then we can set it to, how about its integer value? And I equals C. Let's see what that does. Does that work? Let's print out I. Yep. Now that's the ASCII code. So 97 is the ASCII code. So you'll get into that later, and some of you might know this already, but there's key codes, a number associated to each key on your keyboard, and then other characters aren't even on your keyboard. And that's the ASCII table. And it's got each key or each character is a value, or a number value, an integer. Okay, so that is the end of that part. And let's go scroll down to the bottom of the exercise again. Sorry if this is making you dizzy scrolling so fast. All right, so next thing we want to do is check the minimum and max value of long. All right, let's do that real quick. So it's long, and that gets us stuff. So let's do min. Oh, I don't need the min of a thing. I just want to know the min value. So that one right there. And I could just system out print line. That's helping me too much on that one. All right, so the minimum value is a big negative number. And the maximum value is a big long number. Oops, not there, right there. Okay, so that's that. Okay, strings, so we're going to make a sentence. Let's do that first. All right, so it's a string, and we'll just call it sentence, and let's say this is a Java 2. Let's do uppercase Java because it's a name. Tutorial on variables. How does that sound? Okay, and don't forget the semicolon at the end. Okay, so now we've got a sentence, and what's it say to do with the sentence? Print out the length. So sentence dot length. So this is going to tell me how many characters there are. 37. Okay. What else? Sentence. Replace the third word in the sentence with a different word and print out the sentence. Okay. So the third word's an A. I don't like that one. So let's go to the how about this one? I'm going to replace the word tutorial. So I'm just going to replace this word tutorial. So let's do that. So let's do sentence dot replace. And it takes a character sequence, so I want to replace the word tutorial. I'm going to replace it with the word with the word lesson. And then print it out. I think I have to assign it. Let's see what happens. So if I print out the sentence here, let's see if it does the original or if it does the one that was replaced, because I don't know if it does it. I do know, but you might not know. So let's see what happens. So sometimes if you don't know, just try an experiment and print it out. So this is a tutorial on variables. So it printed the original. So let's go ahead and assign this to a new, let's do sentence 2. Okay, and then we're going to print out sentence 2, and that should be different. This is a Java lesson on variables, so that worked. So you have to assign it, so it's not modifying the original, it's actually giving us a new one. Okay, so that's that. What else do you do with the sentence? Replace the third word. Okay, now let's see how many words we have. Don't need that. We want to do sentence dot split, and let's split on space, because that's usually what does something with sentences and words. All right, and so we want a string array, and let's call this words. And let's print it out so we can see it. Otherwise, we won't know what's going on. Okay, and we'll print that. And ooh, it's printing out an array of string like that. So how do we get our words out of this array? Okay, let's see. To get our words out of the this array, let's try something. Okay, so Arraylist was in our exercise. So let's go ahead and do a list, and then we'll make a new Arraylist out of it. And we'll pass in words, because that should work. And you'll notice it helped us and did the imports up here for us, which is nice. Otherwise, we'd have to look them up and see where was Arraylist, where is list, and then we could add it. So now let's see if we print out not words here, but list. And let's run that. Cannot infer arguments of list. Oh yeah, you have to tell it what type it is. So if it's on here on the left side, it'll infer it its words over here. Otherwise, you could put it, this would be explicit on both sides if you did this, and that's legal. But they shorten it. They made it so you can not have to do that. All right, so now let's run it, and let's see what we get. Okay, it still doesn't like that. So let's tell it what it is. And try again. Okay, constructor is undefined, so it doesn't actually do that with that string array of words, which is weird because I always thought that it did. Let's do it this way. All right, so it's always a learning experience, right? So that constructor doesn't exist. So what we can do is we can do an arrays class, and we can do as list, and then we could pass in words. Let's see if that works. Okay, ready? There it is. This is a Java tutorial on variables. And notice the comma, so it's telling us each word. Okay, so now we've got a list. Let's go ahead and what's the exercise tell us to do again? No, I was messing around with Visual Studio trying to see how to get things to work. Okay, so let's see. String, we print the sentence length, which we did. Replace the third word, which we did. Split into words, which we just did. And print out the array of words, which we did. And then print out the fourth word in the sentence. All right, a couple ways we could do this one then. All right, so we can use the original words array, which was the intention of the exercise. So let's go ahead and do that first. Let's do system out, print line, and let's do words. And we want the fourth word, so that would be actually index 3, because it's 0 based, right? What did it say in the instructions? Print out the fourth word in the sentence. Yes, so it's 0 based. So 0, let's go ahead and look at our printout. We got 0, 1, 2, 3. Did it say fourth? Fourth word. 0, 1, 2, 3, 4. Wait, but the fourth word is this one. So 0, 1, 2, 3. I'm not going to count it that way. 1, 2, 3, 4. It's Java, so it's 0, 1, 2, 3 is the index. Okay, that was complicated. All right, so it's 3 is the index. And let's verify that by printing it. Okay, so Java is the fourth word in the sentence, the third index in the array. Wait, index 3 in the array because it's 0 based. See, that's confusing. You get used to it, but see, even it confuses me sometimes, especially when you're mixing, 1-based instructions with 0-based programming. Okay, so that's that one. And what was the rest? And that was the end of strings. All right, so dates, we're going to create a new date for now and print out the date variable. All right, so let's go ahead and get rid of this one. That was a little more complicated than I thought it was going to be. Sorry about that. All right, so let's do a new date, and I think it's local date, or is it locale date? Okay, I don't really know. I don't remember. let's go back to our tutorial. And reference types, there's date, so it's local date. All right, so let's do that. Let's assign a local date, and it's that one, Java time, and let's just call it date. And we'll do local, well, I don't remember. It's local date.now. So even though I've been doing this for a while, I don't remember. So I always refer back to documentation whenever I don't remember something, which is often. And I've been doing this for a long time, so don't be worried if you have to look stuff up. It's part of the job, and it's part of learning. Okay, and let's run that. Okay, today is July 14th of 2021. Okay, what's next? And the exercise, sorry if this is making you dizzy. Print out the date variable, which we did, get the month of the date variable. Okay, so let's go ahead and date dot get day of month, month value. That'll give us the number. Get month. Let's see what that does. July. Okay, and just for fun, let's see what month value did. It's going to give us an integer, it says. 7. So it's the 7th. Yeah, that's right. July's the 7th month. Okay, that's it for dates. How about, what was next? Arraylist, which we kind of played with already a little bit, but let's go ahead and do one. It says create 5 numbers in a random order. Use the collections class to sort the list and then print it out to see the new sorted order. Okay, so let's go ahead and start a new array list. All right, so we want a list of integers. And let's just call it list equals new array list. Okay, so now we're going to add some things to it. So list.add. Let's add 3. How about 19? What did it say, 5 numbers? How about 0? Let's do a negative number. And then something in between. How about 5? Okay, let's print this out just to see what that does. We're going to print list, and we know ArrayList print because that's what we did before. Okay, there they are, and that's in random order. So now let's go ahead and sort it. So it said to use the collections class. And we want to sort. And we want to sort the list. All right, and then let's print out the list and see if we need to do a new list variable, or will it sort the list in place? Don't know yet. So let's see if it sorts this list in place, which I think it does. So let's go ahead and run that. Collections cannot be resolved. So let's do this again. So collections, collections. Okay, there. Sort. So it didn't. I must have hit a key that didn't add the import up there. All right, so we're going to print that list. We're going to sort the list and then print it out. Okay, here's the sorted list, and that makes sense. Okay, that worked. What was next? Okay, we did that. So next is map. So this is where we're going to make the address book, and we're going to use string keys and string values. And we'll just probably add a couple entries. So this one's actually kind of self-explanatory. We're going to print the address book out, see how many entries we have, and then get a particular one. And then this is all pretty much driven by you and the names that you put in it. So let's do this. We're going to create a map. And we're going to say it's a string key and string values. And let's call it addresses. And let's do it in, let's just do a regular hash map. That's the one that you use the most. Okay, and so addresses. So we're going to do addresses.put. And let's give it a name. So how about Bob let's just do first names, and then we'll do an address. 123 any street. Okay, that's one. All right, I'm just going to copy and paste that. I don't want to type it again. All right, Bob. How about Bill? And he lives on 2345 that drive. And then one more. And you can make these as long as you want. I'm just doing street address right now. Bill, and how about Tom? And he lives at 12345 Main Street. Okay, so what the instructions say, and then print out the map to see the address book. Okay, so let's do that. What's it called? Addresses? Okay, so let's print that, or run that. Tom equals that address, Bob equals that address, and Bill equals that address. Now notice that it's in a different order than even that I typed in, because a hash map is putting it in the order that it can best pull things out for itself. So there are different types of maps. Let's do a tree map. And let's see what that does differently. And you can look this up. You just basically type in Java maps or map types, and it'll tell you what they are. And I think the actual lesson here did that too. So let's go ahead and run this, and then we'll go look and see if we actually listed it out. Now notice it's in alphabetical order by their name. Okay, let's go ahead and look at the instructions on map. Did we talk about them? Yep, hash map, tree map, hash table, and linked hash map are some of the ones built in. So tree map is sorted. Linked hash map will put it in the order that you entered it in. And then hash table is the same thing as hash map. It's just thread safe if you have multiple threads running. That's an advanced topic. We won't get into that here. Okay, so we printed out the addresses, and we're now sorting it, which is not part of the exercise, but that's great because we're experimenting. Okay, let's see how many entries we have in the address book. Addresses.size. And we run. We have 3. Okay, and then what's the last thing? Get the address for one of the names and print that out. So let's do that. So just use the same one. So addresses dot get for, let's do Bill. And 2345 that drive, and that's where Bill lives. Okay, I think that was the last thing in the exercise, right? Okay, it was. All right, so that's the exercise for variables. Go ahead and keep experimenting and playing around with it, and see you in the next lesson. Hi everybody. So in this lesson we're going to learn about math in Java. Now the nice thing is that it's pretty much the same in all languages. The math is very, very similar, so learning it here will be transferable to any other language, say JavaScript, which we will be learning in other tutorials. So what you learn here is going to be very relevant. So let's see. First thing is we've got a couple of, these are all standard across all languages. I really haven't seen much difference other than the way that the syntax is and how you declare variables. So we already know about our variables, and so now we're just doing simple math. 2 plus 3 equals 5. 5 minus 3 equals 2, and that's pretty much how it works. So I'm just going to run through these. I'm going to take our Hello World program, and we're just going to run through a few of these, and then we're going to do some exercises down at the bottom. So I'm going to go ahead and open up Visual Studio Code, and we've got our Hello World program, so let's use that again. So I'm just going to go ahead and delete everything out of here, and the first examples were integer I, and I type I because it's shorter. Usually you want to do more descriptive names, like in the writing there it says sum. So let's see, just pick any numbers you want. You can just experiment and see what happens here. So 3 plus 3, and then let's system out that. And what's I? Alright, so then we'll just go ahead and run this. And we end it with 6, and so that works good. Let's change some numbers around. Let's make 34 plus 32. All right, 66. So you see how that works. Let's go back and see what's next in there. We do subtraction. All right, let's subtract it then. I'm wondering if run automatically saves. So let's do that on the next one. So let's do 5 times 3, which is what that one has. I'm just going to run and see if it saves it automatically. It does, so I don't have to hit the save button all the time. All right. So that was so this is all pretty standard stuff. Okay, division is the /. So let's do 15 divided by 3. Okay, so that's how that works. Remainder. Some of you might not know modulo or modulus. So that'll give you the remainder of a number. So 17 divided by 3, what's the remainder? So let's do 17 divided by 3, and we'll run that. And the remainder is 2, and that's right. Okay, so operator precedence. Now this is going to be something that we're going to learn something new in. So here's 2 plus 3 times 4 equals 14 and not 20, because it's going to do the 3 times 4 even though the 2 comes first, and then it's going to add it to it. So let's go ahead. I'm just going to copy and paste this one. Okay, so the answer, I'm going to change that to an I just because I don't feel like typing everything. Alright, so if we run this one, it is 14. Now in the description here it says we can change that by grouping operations first, so parentheses. So it says here parentheses come, so these are the forms of parentheses, so square brackets and parentheses, and access to a member come before multiplication, whereas right now multiplication in this example comes before addition and subtraction. So it's going to do these first before it does that. So we want to change that order. So let's go ahead and put parentheses around these to get this to evaluate first and then that. Okay, so let's do that. So let's put parentheses around the 2 and the 3. And then when we run this, we get 20, which changed the answer. So that's good. All right, and same thing, the modulo operator is right here. So we can, let's go ahead and just copy this portion. And the answer is 4, but I want to have the add operation come first. So then I'll just put parentheses around it. So that's how you change the order of the way you want things processed. Because I say I want this to be 5, not 3. So I want to go ahead and make that come first. So run this. And now it changed the answer. All right, that's great. Okay, so now there's some other operations. The math class provides a lot of math, and there's a document link here where you can see all the different functions there are. So for example, there's absolute value, square root, maximum of 2 numbers, and then raise something to the power of. So let's just do a couple of these. We'll just do the ones that are here. So let's go ahead and say I want the absolute value of minus 89. And that should print out 89 instead of minus 89. Yep. Okay, and what's the other example? Square root. Square root. Let's try the square root of 89. I wonder what that is. It's probably going to give me a decimal number, so that's probably not. I mean, it's okay. It is math, but that's just harder to comprehend. Oh, mismatch. Can't convert double to an integer because it ends up being a decimal value. So I'd have to change this to a double. And I get a funky number, but I think 189 is square rootable. Let's see, with the whole numbers. Nope. 289 is. I know it was one of these. I think it's 289. Yep, 289 is 17. So now I could change this back to an integer. or not? Oh, square root only returns a double. I see. So say I wanted to make this an integer. Can I do that? By casting it. So this is a cast operator, so I'm putting parentheses around this, and it's going to try and change this into an integer. I don't know if this will work, but let's try it. I'm just experimenting. It did, so it gave me just the integer portion. So if I wanted to force it to be an integer, I can cast it. It'll tell me if it couldn't, but that works. So let's do one that is a decimal and see what happens with when we cast it. It should truncate it, which it did, because remember it was 13 point something, and so now it truncated to just the integer portion of the answer. So we learned a little something there. And then let's go ahead and do some exercises so we can apply the math. Okay, so we want to calculate the area of a triangle. And the area of a triangle is base, 1/2 base times height. And let's see, a triangle with a base of 10, let's say, and a height of 15. So what you want to do now is pause your video, and then I'm going to do some of these. We've got a couple of them. One's to calculate a triangle. Another's a little bit more complicated. Calculate a future value with interest. And then another one is, say you're going to go ahead and pay in something into some investment account, and you're earning 8% interest. So let's go ahead, and this is much more complicated, but we'll see how things group by doing something difficult. So pause your video, and then come back, and you'll see us do it together. Okay, so you're back, and here we go. Let's do the triangle one. So you have to try and set these things up, and I haven't done these before. I just wrote them out. So 1/2 base times height. So let's do b divided by 2. That'll give us the base times the height. And that'll give us an answer. Let's make it a decimal answer, because there could be decimal numbers. So we don't have a b. So here's where we're going to change things up. So we're going to say b. Let's go ahead and spell it out, so that way it's more clear. This is what you're going to do when you're programming. You're going to make these more clear. So it said the base was 10, and it said the height was 15. Yes. All right, so now let's see what our answer is. Let's print out area. And let's run this. 75. So 1/2 the base is 5 times 15 is 75. That is correct. Okay, so did you see how we did that? We set it up by putting in what the formula is, and then we backtracked a little bit, made it more readable, added the answer, and then put these over here. So this could actually be turned into a function by, let's see, does this do that? Let's see if we can refactor it and extract method. So now we've got a method, and it's going to ask for a name. So let's do area of triangle. So now we've got a function, so now we could just change the numbers, and actually we don't even need these variables anymore. We could just pass it in like this. And if we run that, we should still get 75. And we could change some things around. Let's do something that we can actually divide, though. All right, so if the base is now 20, that would the answer should now be 150. Yep. Okay, so that works. So that's the area of a triangle. Next one, this is much more complicated. Let's just set it up the way it says it. All right, so we're going to do this. So this is the tricky part, and this is the part that you need to learn. Is I've done this before a long time ago, and so I don't remember what I did before. So I just do it straight. What does it say to do? So we're going to do PV. And then it says, and that's going to time something in parentheses. So times in Java is like this, and other programs as well. And we're going to take 1 plus I, and then we're going to raise that to the n. All right, there was a math.pow up above here. So we're going to do math.pow, and it said take that and to the n. So then let's put n in here, because the way that math.pow works is it does the number you want to raise to the power you want to raise it to. Here's the number we want to raise and the number we want to raise it to. Okay, and then is that done? Okay, and that should give us FV. Let's make that a double. And you see how I'm backtracking in. So now I think I've gotten this written out. And I'm going to do, let's do doubles. So let's say we have $10,000, because I think that's what it said. It said take 10,000. And then we're going to take another double. And we're going to say it's I, and it's going to equal to 0.08, because it said 8%, right? And then n. So n is probably okay to be an integer, 20 years. So you see how this is setting up. I haven't done this before, so I'm just backtracking. I went ahead and put it in, and then I'm backtracking out the variables to fill this in, and then let's see what we get. And I know this is generally correct because I did have done this before. That's 46. So we could do this with Google and see if we got the right answer. Let's do future value. Let's see if any of these work fine. Okay, so this one's close. So we didn't do anything with that. We don't have that payment in, and then this was 20 years. All right, let's see what we get. Okay, we got the right answer. Okay, and we'll use this one for the next one. Okay, that's cool. That worked. Okay, and the next one is slightly more complicated. So let's do this. We've got, oh, again, if you want to change this into a function, you just highlight it, and then right-click on the highlighted part, refactor, extract method, and let's just call this FV for short. You want to spell it out. All right, and then you could just make it so you plug in values. And then you don't need these anymore. Now you've pretty much made a calculator function. And it got the right answer again. Okay, so now let's do the next one. This one is, we can keep the future value there. Okay, it's PMT. And it said times something in parentheses. And I got this formula from the internet. And then times something else. So then this one's going to be times something in parentheses again. And then on the top, this was a fraction. So on the top, it's going to be something in parentheses. You notice I'm just typing what it says. I'm not doing anything else different. Okay, now this one's trickier because there's a power again. So we're going to do that around the parentheses. So we've got math.pow. And we've got this function, and then we've got an n that we want to raise it to. Okay, and then outside of that, got -1, it said? Yes. And that whole thing is going to be divided by I. All right, so knowing how the operators work that we learned, this is going to happen first unless we do something. So let's go ahead and put parentheses around this. All right, so now that's going to give us that value. So let's try this. We have to backtrack out the variables now. We don't want this one anymore. You use doubles when in doubt. That way you get the decimal answers. Okay, and I believe this had $500. And what's the next variable? I. and that is 8%. So a percentage is expressed like this. And then n was 20 again. And that's a fixed number. We're not doing decimals right now. So n equals 20. All right, I think that's everything. Let's try that. And we've got 24,711. Let's see, using this thing. All right, so we didn't have a starting amount in there. And we had 500 here. Oh, it needs to be something. Okay, 0. 22. What do we get? 24. Something is different here. All right, what's our formula look like? We're close, but something's just not right. So maybe this has to calculate first. Let's try that. Although it looks like it should, because it's going left to right, and these are all multiplication operations. All right, that didn't change the answer. So I'm wondering if something is wrong with the way we type this out. And so you can look where the parentheses are and see if that helps anything. So that's a math power thing, so that's fine. And you notice how I'm moving the cursor to the parentheses and it's showing the other side. Okay, that's weird because I think this should actually be right. Could their calculator be off? I doubt it. Oh, okay, they're giving us some numbers here. Oh, why is it saying this? That shouldn't be there. Oh, wait, is it? Total interest. Okay, I don't know why it's doing this. Let's try this. Ah, beginning. That's what's different. So this calculator is doing payments made at the beginning instead of the end. So we pick beginning, and now we have the right answer. Okay, so we did type it in right. That's good to know. Okay, so that's how you do it. You backtrack, and then you can turn this into a function by highlighting it. Refactor and extract method. And let's see, future value of payment. Let's say investment, because that's what's more accurate. Okay, and we'll take the values and put them here. Oh, did something wrong. Oh, wow. Okay, and there. Okay, and we'll run that. All right, and there's our answer. So that's how you do it. So you've got the basics for creating a formula with the building blocks, the addition, subtraction, multiplication, division, the math class as well. And then putting it together is the process that you just saw. You have to type it out and then backtrack. So that's how that works. Also provided in the lesson plan is a link to the math class. And here you go ahead and get familiar with it. And you see all the different functions it has for all the different mathing. So it's got trigonometry, it's got finance, it's got all kinds of different things in here. So go ahead and take a look at that. And that's math. And it works the same almost in every language. JavaScript is very similar. It has a math class as well. And the order of operations is the same. So this will transfer directly over to that. And thanks for watching. Hi everybody. In this lesson, we're going to learn about the Java assignment operators. Again, this is very similar to what you'll see in other languages and JavaScript in particular, because that's what we'll be learning next as far as a language goes. So we'll be learning JavaScript, and this is directly applied to learning JavaScript as well. So if you learn it here, you'll know it in JavaScript when we get to it. Okay, so assignment operators, we've been using them already, especially this one. The equals operator, I guess we haven't used any of the others yet. Well, we have. We've used the incrementers, and I'll show you those in a little bit. So this equals operator we've been using, obviously, it's setting a variable equal to the value on the right side. So declare your variable type, and you've seen this already that we've been doing it. Variable name could be anything. I named this one thing. Equals to the value on the right side. So in this case, thing will be equal to 2 once this operator happens. Okay, so these other ones aren't used very much. It's a shortcut, and I'll show you that when we start playing with these a little bit. But it's a shortcut for thing equals thing plus 2 in this case. So here's where we're incrementing it by a number. So thing equals 2, and then thing plus equals 3 becomes 5. You can do the same thing by saying thing equals thing plus 3, and that will equal 5. Same thing, but this is just shorthand, and you might see it in some programs. It's handy to reduce the typing. I don't use them very often, but sometimes I do. And then these are they all follow the same suit as far as the math operators go that we just did. So subtraction does what you would expect. Thing minus equals 2. If thing was 5, it's now equal to 3. Same thing with multiplication. So this is going to be a quick lesson, but we'll get into a little bit of a coding learning part of this, and that will make it more clear if it's not clear now. Multiplication, I think we just did that one. Oh, we didn't. We did subtraction. So if thing is equal to 5, then thing times equals 3 is 15. So it's just doing the operation without having to specify the variable again. It's a shortcut. And then division, you'll see that one. And then same thing with modulo. It's going to divide by 6 and then give you the remainder. So that's how that works. Now, ones that we have seen before also, this plus plus operator, we've used this in our for loops. So when we covered loops, we had an incrementer at the back of the for loop, and that's pretty much what I use those for. Sometimes if you're in some kind of a while loop or you're incrementing something, you'll use these. Now, there's a post and there's a pre. So a post incrementer, which is the one I think is used more often, is you can set the counter equal to something. In this case, we call the variable counter. And if you do a plus plus operation on it, it will just increment by 1. So it's used often enough that Java and other languages have added it as an operation. So in this case, I will equal 1 because if you access it when the operation is occurring, it's going to increment the variable after it returns the value of it. So when it's read, it's going to read the value that it currently is and give that to you, and then it's going to go ahead and increment it after that. So in this case, I is equal to 1. The counter is now equal to 2, so the next time it's accessed, for j here, it will be equal to 2. And the pre-incrementer is the same thing, but it's going to do it first. So if our counter is equal to 1, and then we go ahead and read that variable, it's going to increment it first and then give us the variable value. So then we've got an I equals 2 in this case, and then the counter equals 2, so it gave it to us already incremented. And then if we access it, it's going to be equal to 2 still. We got the same thing for decrementers, and this could be used in the case where you want to count down. So if you're in a for loop, you would count down, or if you're in another kind of loop, you would basically be counting backwards, counting down. So in this case, our counter is equal to 3, and in the case of the post decrementer, we're going to read the variable as the value was before it was decremented, and then it'll be decremented. In this case, I equals 3, counter equals 2. And then when we read the variable value again, it's decremented. And then in the case of the pre, just like the case of incrementing, in decrementing, it's going to give it to us before or after it does the decrementing. So in this case, counter equals 3. We're going to decrement the counter, and it's going to read, and we'll get 2, and the counter is equal to 2. And then if we read counter again, j will be equal to 2. So that's how those decrementers and assignment operators work. Again, I don't use them very often, but they are a handy shortcut. The decrementers get used very often, especially this. I do for loops, and so the post incrementer in for loops is used very often. Okay, so that's how those work. Let's just go ahead and try a few of them, and then this lesson will be done. All right, so I'm going to take our hello world application, and let's just do a decrementer. So, all right, let's just run through each of them. So I equals 0, which we've seen before. So let's go ahead and system out, print line that. All right, and so if we run that, we're going to get 0, which we did. Okay, so now let's go ahead and kind of set up what we had before. Let's call this counter. And spell it right would help. Okay, so it's counter, and let's set it equal to 1. All right, so then let's do the same thing that was in the lesson. Might as well. So we'll set that to I, and we're going to do counter plus plus. And let's go ahead and print this out here. And you guys play with these too, so you get used to them, because you will see them, and they are used in other languages. All right, let's see what I is, and then let's see what counter is. Okay, here we go. Okay, so I is 1, didn't increment yet, and then counter is equal to 2, but let's make it a little bit easier to read for us. Okay, so let's do that again. Okay, now we can see I equals 1 and counter equals 2, so it post incremented it. All right, so let's do a decrement operation on it. And let's increment or increase that value. And if we run this one, okay, so we had it equal to 3, it decremented, I is equal to 3 when we did this operation, so this operation right here, and then we've got the counter here. Now you could also do this without assigning the variable, so we could actually do this. So it's going to return the value here, and then this will be incremented or decremented. Ready? Here we go. So equals 3, and then it equals 2. That's a little less clear, so let's go back. I'm hitting Command Z to go backwards. Okay, so let's do a couple more. So if our counter is 3, let's go ahead and do a plus operation. Now you would use this operation if you want to increment by more than 1. So let's go ahead and increment by 2. And there's no pre and post on these. Oh, I isn't the one. We want to do counter. Okay, sorry about that. Plus equals 2. Okay. So now we're just going to look at counter. There is no pre and post on these. So this should come out to be 5. And it does. Okay, so let's do them for each. So we've got a times operator. And that's 6. See that down here. And let's do a minus operator. Did we do that? I don't remember if we did. That should equal 1. It does. Okay, and then we'll do a division operator. Now this is going to give us a non-decimal number because we're using integers here. Let's do that really quick just to see. See, it gave us 1, even though it's actually 1.5. So let's go ahead and change this type to a double. Now we get 1.5. That's what we expected. Okay, and then same thing for the modulo operator. Let's go ahead and make this, I don't know, 17, I guess. And let's go ahead and do 5. Oh, modulo 5. And that should give us 2. And it did. Okay, so that works. And then, did we do the decrementers? I don't think we did those yet. So let's go ahead and these work with doubles or ints. I'm just going to do ints. All right, so let's do system dot print line. Okay, so let's decrement that value. And so you could do these various ways. So if I do it here, it's going to print 16 because I'm doing it post or pre. If I do it here, it's going to give 17, which it did. And the value is, got a bunch of spaces at the end there. And the value is going to be 16. Let's see, where is that? The run button, there it is. So we've got 17 because it's a post operation, and then 16 is what the value is now. All right, and then that was minus minus. Let's do plus plus. I don't know if I did plus plus. If I'm doing it again, then it's all right, more practice. All right, it's 17 at the operation, and then 18 here. All right, and then now let's do the pre-operations. So that should give us 18 and 18, which it did. Okay, that's it for the assignment operators. You won't see them too much. Actually, let's go ahead and do one more thing. You've seen this before, but I'm just going to do it so it'll be familiar to you, because this is where you will see it. So int I equals 0. You will see this. You've seen this already in a couple of them. I less than 5, let's do. And then I plus plus. That's one that you will see a lot. All right, so let's print this out. And we're going to print I. So what you're going to see here is it's going to start at 0. Now if I did a different operation, it should do the same thing. So in this case, it won't matter. It'll still start at 0 because we're assigning it to 0 here. So it's going to count, but we'll see what happens anyway. All right, so it's 0, 1, 2, 3, 4. Now if we do a post on this, you'll see that it's going to be the same. And we'll explain why in a second. Still 0. The value I is being read right here at the beginning. And it's being read every time it comes around. So it doesn't matter when you increment it on this side. It's going to go ahead and increment. And we're not capturing the value here of this operation. We're only capturing I here. So the value is being incremented and then it's being changed over here. So we're not assigning. So that's the difference there. And that's one that you'll see. So you'll typically see it this way. That's the one that's used most, because it actually makes more sense in this context. Okay, and that's it for assignment operators. Thanks for watching. Hi everybody. In this lesson we're going to learn about logic operators in Java, and this helps us with conditional logic, where we do different code depending on certain situations, and these logic operators help us do that. For example, this first one, the equality operator, tells us whether something on the left is true to something on the right. Now it could be a statement on the left and a variable on the right. Anything left and right that returns a value, a Boolean value, which is true or false, can be evaluated on either side of a equals operator, equality operator, and that's used with double equal signs. So for example, if a variable I is equal to 3 and a variable j is equal to 2, this Boolean value will be false if we ask, is I equal to j, because it isn't. So that won't evaluate to true unless they are in fact equal. Now, these are typically used in a condition statement, so an if statement. So what you would really do is you would only do this if you're trying to save this variable. Otherwise, you would just do this, right? If you don't need the variable to reuse again later on to know that this condition is true and you need to know it multiple times, if you only need it once, you typically just do this. If I is equal to j, then do some code. And in this case, it says, is I equal to j? And so what I want you to do now is kind of just play with these and put them in your Hello World application. So what I'm going to do is replace that code and then have this in there, and let's just see what it does. I don't know what it did. It looks like it printed out Hello World, which is weird. Let's try that again. Either that or there's some kind of weird error in here. I don't see how. That's just strange, right? Okay, let's do, I like to leave the errors in, so you guys, if this happens to you, you'll be able to figure it out, because there's some weird things going on with this one. Okay, so now we're at a break statement, and maybe this shook it loose. Let's go ahead and just step over. Okay, it's telling us that I is equal to 3 and j is equal to 2. And then we're going to evaluate, and it just jumped right over it, didn't it? Oh, because they're not equal, right? So it just jumped out of it. And so what's happening is the program is exiting because there's nothing to do here. So let's go ahead and do something about that. Let's let it run through. So the debugger's nice to help you understand what's going on. So what happened is it got to here and said they're not equal, and it just exited on us because we didn't tell it to do anything else. So it didn't tell us this, and we didn't tell it to tell us anything if it wasn't the case. So let's go ahead and do an else statement. And we're going to learn about this in the next lesson. But I just want to have this print out for us. Why isn't it doing 2 spaces for me? That's because this is set to 4. And 4 is okay. I think the document's formatted in 2. That's why it's doing this. So just do that. Okay, so I is not equal to j. Now we'll see something come out. Okay, I is not equal to j. Now these are if-else statements, so we're going to get into that in the next lesson. Don't worry about it. It just, in this case, so that you know, if it's true, it's going to do this. Else, if it's false, it's going to do this. So that way it'll help us through this part of the lesson. Okay, so that's how that one works. Let's go off to another one. And so that is the equals operator. If it's equal, then it'll do something. Otherwise, do something else. Now here's another one. This is the inequality operator, and that says, is it not equal? So we're going to go ahead and change our program back to the way it was, and then we'll do this evaluation. So not. And some people call this a bang. It's an exclamation point. So is I not equal to j, and then it'll do this code. So let's go ahead and try that out. So if we do not here, let's just go ahead and flip these statements. Okay, so now it's going to print this one. They're not equal to j. I is not equal to j. Let's go ahead and run it. Okay, so I is not equal to j. Let's go ahead and set them equal. We'll make j equal to 3 now. And now it says I is equal to j. So that's how that works. So if we're saying here, if it's not equal, then I want to do this. Otherwise, do this. Okay, so let's see what our next operator is. Okay, here's the less than or equal to. And same situation, it's same as in math, right? So less than or equal to, that's what this one's doing. So we'll just keep our same program, and let's just alter this like that. So is j less than or equal to? In this case, it's going to say no. And let's not leave this equal to. Let's see. J is not less than or equal to j. And let's go ahead and copy that. So, oops. So we don't have to do that again. And we'll just remove the word not here. So this, in this case, I is less than or equal to j. All right, let's do that. So it should come in here because they're equal. And it did. And to confirm that, we could just use our debugger. And then we step through it with these buttons up here. Step, step, they're equal, and it went in here. So that's what we wanted. Okay, and then we can just set them not equal. So I will still be less than j in this case, right? So it's going to go through and it's going to do this case again. So it is less than or equal to j. But if we flip this around and now run it, it's not less than or equal to. So you're kind of learning about the if-else right now, as well as the conditional operators. So that's less than or equal to. And these are starting to get self-explanatory now that we're going through it, because now we're just going to flip it to greater than or equal to. And it's that simple. And let's just change the words here. And we're just doing this for the human readability of it. Now, if it's true, we're going to do this, right? So if it's true. And in this case, it is true. And I like to debug in these cases just because we can see what's going on. So we'll go ahead and step. Is there a keystroke for step? F10. Let's do that so we don't have to keep using the mouse. All right, and it went right in there, and that's what we wanted. Okay, so that's good. And then we know what it's going to do if we flip it the other way, like flip the values. So we don't have to do that. You can do it if you want to play around with it. Okay, now those are the equal operators, right? Is it equal? Is it not equal? Is it greater than or equal to? Is it less than or equal to? Now we're going to get into ANDing operations. So this allows us to do more than one of those operations, as you'll see here. Now we have many variables, and we've got a couple of conditional statements here. So let's go ahead and do this. I'm just going to copy and paste that example in here. And remember, I would prefer it if you guys type, because you're learning how to get that muscle memory with your fingers, because I can think of the word for, like a for loop, and my fingers will just type it out. Of course, my brain is telling it to, but it's remembering how to do that. So the strokes just come easier. I don't have to think about what I'm typing. It just kind of happens because I've done it so many times. So you want to keep practicing that. All right, so we've got I equals 3, j equals 3, k equals 7, and l equals 5. So this condition here is going to evaluate to true. And this condition over here is going to also evaluate to true. So we should get this to come out. And so let's try our debug here so we can see it. And then we step, and it is true. So then we get that to print out, and we see that. So that's the AND operation. So it's saying this and that have to be true. If it's not true, then the whole thing won't happen. So let's just put this in here. And eventually you get used to the IntelliSense too, so then your typing comes even faster because you're only typing a couple of letters of a word, and then the ID helps you finish it. All right, we don't need to type out everything here. Let's just say it is not true. Okay? Now if we step through this, and what did we say it was, F10? All right, so it's not true. So this did not evaluate to true. One side of it did not. So I and j are equal, but k is greater than l. So it said, nope, not this one. So they both have to be true if you use the AND in order for this to happen. And you could have many ANDs. You just don't want it to get too complicated. So you don't want to have too many of them. You have to break up the logic if you're going to have a lot of those. But these both have to evaluate to true because it's an AND. So this and that have to be true. Okay, so let's just go ahead and let that run through, and let's do another one. All right, this is the OR operator. Now, it's either one of these sides can be true, and then it'll work. All right, so then we're doing it differently too. We're not using all those variables. All right, so let's do this one. Okay, we've got I equal to 3 and j equal to 7. So now we're checking, is I greater than 5? And in this case, it's no, so that's false. And then is j less than 10? Yes, it's true. Even though this one's true, this one's false, so it's going to go ahead and say that either one of these is not true. So let's go ahead and run that. Let's debug it again. F10. Okay, so either I is greater than 5, or j is less than 10. Oh, because it's an or, right? So one of them is true, and it is this one that's true. So j is less than 10. So that did come in here because one of them is true. That it's not an and condition. My brain just thought that for a second. It's either one of these can be true. Okay, so if this one's false, then this one gets evaluated. In the case of an and, if an and was here, this one's false, this won't even get touched. Okay, so let's go ahead and let that run through. Okay, so that's an or. So let's go ahead and make them both false. Let's just copy this. I don't want to type all that though. I'll just say not true, and then we'll run that through. Okay, not true, so it came in here. So that's how the or operator works, right? So either one of them has to be true. Okay, and you could have many of those as well. Okay, and now we've got the not operator, so we can change things to be not just on the outside of something. So let's go ahead and let's just use this example because it's simple. Okay, so we've got a equal to 1 and b equal to 2. Our Boolean result should be false. Let's go ahead and print that out. All right, we'll run it, and it should come out to false, and something's undefined. Oh, missed the L here. Okay, so that's false, so that's good, and that's what we wanted. Now, just by simply changing this, by putting not in front of it. Now, this, the order operation, I don't know what this is going to do. Let's go ahead and just try it out. I want to put parentheses around this, and in fact, it looks like it's asking me to because a is not a Boolean, so it won't do that anyway. So we have to put parentheses here and here. So now, let's make this a true statement. So a is less than b. Okay, so it's going to be a true statement, but it's going to be equal to false because of the not. So basically what we're saying is this not true, and which would be true. So it's almost like a double negative, but that's how it works. So a is in fact less than b in this case. So that will evaluate to true, but we're going to say, is it not true? And this will say, yeah, it's not true, so it's false. Right? That's kind of tricky, isn't it? Okay, so it's going to be true here, and it's going to come out to false as the answer. So let's run that. All right, the answer is false because this is true, and we're asking, is it not true? And so it's telling us, yeah, it's not true. It's giving us a false. It's almost like a yes, no. Or is it? I don't know. It's kind of confusing. So these nots are kind of tricky. So it's going to basically, the way you can look at it is it's going to take what is in here and it's true, and it's just going to flip it to the other way, right? So it's going to be false. If you try to think of what it's saying in English, that's going to give you trouble. So just think it's going to flip it. So if this is a true statement, it's going to flip it to false. If it's a false statement, it's going to flip it to true. That might be the easier way to think of it. It's hard to think in double negatives or a negating operation like that. Okay, so now that's because this is false, it flips to true. Hopefully that helps you. Otherwise, it's back to, is this not false? And that should be true. So, or is this not true? And that should be true. That's difficult for me, so I flip. All right, so, okay, so what's next? We are looking at operator precedence now. Okay, so that means the and is evaluated before the or statement. So if you have multiples of these, the ands will be executed first, so from left to right. So the ands will go first, and then the ors will go back when we read left to right, and these will be evaluated. So let's go ahead and take a look at the example we have here. So in this example, we've got B and C. This is going to execute first here. So B and C equals 5 evaluates to false because B equals C is false and C equals 5 is also false. So both of these are false. And then the next thing that executes is A equals D, and A does equal D because they're both equal to 1, and that makes the whole condition equal to true because this one's done and that one's false, or this one, which is true. So then this statement will execute. So let's go ahead and try that out. I'm going to copy paste and you type. All right, so I'm going to put this in here and let's run it. All right, so this code will execute, which it did. So now let's go ahead and see what it says next. All right, when we add parentheses, A and D or B and C evaluates, because we're going to add the parentheses, and parentheses, what's in parentheses gets evaluated first if we look at precedence from before. But B equals C evaluates to false, making the whole condition false, so the statement will not execute. Okay, so what it's saying here is these two are going to execute. Highlighting doesn't work real well. All right, so A equals D is true, B equals C is false. This is a true statement though because one of them is true. There's an or there. So this side is true and this side is false. So now it won't execute because this side's false. So I'll just go and add the parentheses to make it more clear what we're doing. So same statement we had before, which was true and came in to the statement. Now we add parentheses to change the order of the operations. Instead of these two happening together, these two will happen together because of the grouping. And if we run this, we didn't get any output. So let's go ahead and make it tell us what it did. And let's just say statement is false. Okay, ready? Or actually it's the condition. Condition is false. Okay, so when we run this, it should come into here. Condition is false. That's correct. Okay, so we can change operator precedence just like we could change the order of math operations. We can change these operations by adding parentheses, which get evaluated first. And is there anything else? That's it for this lesson. Thanks for watching. Hi everybody. Okay, in this lesson we're going to handle branch logic. So branch logic, you've seen this throughout all of these other lessons, really just an if, else statements, and we've been using those all along in simple form, but we've been using them with conditions, so you're used to seeing them really. So this is just going to be a little bit of a more full example so you can see what it looks like in a more complete example at how it could be used. But you've already been seeing them as far as the if statements go, and then I'll show a switch statement down below. That's another form of branching, and that one's a little bit more specific. So let's go ahead and take a look at the if statement. So basically the way they work is you've got if and else, which you've seen. So if this, else do that. You could also have other else ifs, so a bunch of ifs working together, and as soon as one of them is satisfied, it stops processing and goes outside of the whole block. So let's assume, for example, that someone has a test score of 83, and we want to assign grades to them like A, B, C, D, E, and F, or not E, but F. So we would just do what we've seen before. Here's a condition that you've seen. If score equals 100 and score is greater than or equal to 90, then do this, right? So now there's an else if. So else if the score is less than 90 and the score is greater than or equal to 80, then it's a B. And then we do the same thing for C, the same thing for D, and then else, which you've seen before, you got an F. So that's just a more complete example of how the if-else statements work, but you've already been seeing them. So that should be kind of like review with just an expanded case. And we can play with that too. Let's go ahead. We'll just copy and paste, and you should type, but I'll copy paste, and we'll just put this in here like this. Okay, so now we've got the score, and let's see, 83 is a B, right? So let's go ahead and run this. You got a B. Let's change the score to 75. You got a C. Okay, so now let's go ahead and see how this thing works. So what's happening, let's go ahead and debug it, and let's see what it's actually doing. All right, so it's stopping here and setting score equal to 75. So then we're going to step, and it's evaluating this one. Didn't hit it This one didn't hit it. This one, it hit it. So, and then once it goes, it should exit out of here because it already processed one. So it hit the next line just because that's the way the debugger works, but it did not go to the rest of these. And we could test that out too. We'll do something to test that out. All right, let's do this. So it's between, we've got 75. It's between this one, so it's going to hit it. But let's do something to make it so it'll stop before that. So let's put an else here, else if. Let's do score equals 75, which it does. So it should execute this one and not the next one, right? So it should not go in here. And we'll just say, you got a 75. All right, so now if we run this, it's going to come in here. It should not execute that one. And so that's how we'll see that how this works. So we've got our breakpoint, and then we go. And now here's the case where it's going to go in. Okay, it's in there, and then it's going to jump to the next, but not go into it. And see, it jumps straight over it. So as soon as it satisfies one, it's finished. And so we just got a 75, not necessarily B. Okay, so that's how that works for the if statements. And so you're kind of used to those, and that's how they work in a complete example, and that's really all there is to it, not much. Most of these things, there's really not much to know. It's just, you know, having practice with it. All right, so next up is a switch statement, which is a little bit more specific. So in this case, a switch statement takes a value and then evaluates a case. So these aren't conditions, these are a case. So in the case of a month, which counts zero-based, it's 11 is December, 0 is January. So we're going to map out the seasons here, right? So if it's these three, and the case statement uses a break to break out of it. Whereas an if statement, once one's executed, it'll fall out. A case statement will keep executing the ones that match until you break to make it come out. Okay, so that's how that works. And let's go ahead and play with this one. Like the else if, there's an else equivalent, and this is the default. So if you don't know anything, it's just going to come to the bottom. Default, do this. So break statement's how you get out of things. So let's do this. Let's take this example, and we'll put it in our Hello World program. And we'll save it. And so month is 5 here. Let's run that. And that had to finish that one off. Okay. So it says it's summer, and June is summer. All right, so let's start with case 11 and see what happens. Let's use our debugger. Okay, so we're at 11, and that's December. We're going to step, and we're into winter, and we break. So that's out. Now let's take the break statements away and see what happens. So if we don't break, it should come down to the bottom as unknown. Let's see what it does. So it got winter, it's getting summer, spring, summer, fall, and now unknown. So you see without the breakpoint, or without the break, it will just keep falling through like a rock. So to exit out, so otherwise you could put in something here, something there, and it'll do all the cases that match. And so that's the difference between an if-else, if. So it's called, they usually call them if, then, else. But in the case of Java, it looks like if, else, which only executes one time, one condition met, and it does it by condition, whereas this one is for a specific case, and it can execute many of the cases. So here's how that works. And that's pretty much it for the branch logic. Use them all over the place. As you have seen in these lessons, we use them quite a bit. We haven't used the switch statement, and I don't use that one as much. The if statement is definitely much more flexible to me, and it can do all the things that the case statement can do, with the exception of this multiple checks. But you can emulate the same thing with an if statement. You just do if, and then do another if, not an else if, just an if, outside, outside, outside. So here, just to show you what I'm talking about, you can emulate something similar here. If you just do an if, and I'll just put the word condition here because we don't have to type it out. Okay, if condition, right? And then it'll do this one. And instead of doing else or else if, you just do a different condition. And then it'll check just like it does in a case statement. Check this one, it'll check this one, and it'll execute them all. But you have the flexibility of doing conditions that are much more full. I typically don't use the switch statement unless I'm doing something for something numeric or something that I need multiple cases. Otherwise, it's the if statement. And that's it. Thanks for watching. Hi everybody. In this lesson we're going to cover loops in Java. So there's a couple ways to do looping. There's for loops and there's while loops, and then there's iterators, and there's probably a couple others, but those are the main ones. So the for loop is probably the most popular one, and you've already seen this in some of the other lessons. So what I want you to do again is play with these, type them out into your Hello World program. And we're going to do that right now with this one. I'm pasting. You should type because it helps you build muscle memory. All right, so in this case, this one's going to print out from 0 to 5. It's actually going to be 4, right, because it says less than 5, so that would be 4. And it's going to increment by 1, and you've seen all these parts now. So we're declaring a variable I. It's an integer. We're going to start at 0. We're going to go till as long as I is less than 5. And then we're going to increment by 1. And so that should print out 0 through 4. Let's go ahead and run that. And there it is, 0 through 4. So 5 numbers, 0 through 4. Now if we wanted this one base, we just change that to a 1. And if you want to do 5, you can do like that, or you can do like that. So then if we run that, we'll get 1 through 5. And there it is. Okay, so in the next part, you can actually increment by 2s by doing this. You've seen this addition assignment operator, right? And so we're going to say it's less than or equal to 8. So let's go ahead and just modify. So we want to count by 2s. We're going to start at 2, and we're going to go to 8, and we're going to increment by 2. So this is a way to count by 2s. So we're going to start at 2. We want to be less than or equal to 8 because we want 2, 4, 6, 8. And then here we're going to do the assignment operator on this with 2s. All right, so now if we run that, 2, 4, 6, 8. All right, so that's how that works. We can also go backwards. So we'll start at 5. As long as we're greater than 0, we're going to go ahead and decrement that number. So let's go ahead and do that. So let's count down. We're going to start at 5. And as long as we are greater than 0, let's go ahead and include 0. We're going to go backwards. So we decrement I. Now you could put this I on the other place because we're not accessing this variable as it's being operated on, so it doesn't matter. So typically we put it at the end because that's when it's being applied. That's when it makes sense to us. Okay, and we've got 5, 4, 3, 2, 1, 0 because we did this with the 0. If you do this, you're not going to get the 0. You're going to just get 5, 4, 3, 2, 1. Okay, so that's decrementing loops. All right, so now we've got an array list, and this is kind of an built-in thing with list. So it'll, or actually any collection, it'll go through a collection of names with this colon here. So let's go ahead and put this out. You type it, okay? And let's see, I'm going to do this. All right, so now it'll print the names as in this order. And so they are, there's the names right there, and it printed it out. So the way that this works is what's the type of thing in here? It's a string. And then what's the collection? So this just iterates through the collection. And that works for almost any type of collection. Now you could also increment it using a for loop. Let's just go ahead and get this part, and I'm just going to replace the loop. So we can iterate through the numbered indexes. So we're going to do 0, and then names has a size, right? So we want to do less than the size, and then we're going to increment by 1, and then we can just get it it's a list, so we can go ahead and get whatever index this is. And if we go ahead and run that, we get the names. And in this case, we printed out the indexes. Okay, another type of loop is a while loop. What are while loops good for? It's when you're not kind of counting or knowing what your range is. You're just kind of looping through, and then you have to figure out when it's going to stop. You might know when you want to stop, but you don't know what's in between, or there's some operation that's going to determine what's in between. There's various ways to do while loops. You can just say while true, which will loop forever, and then when you want various conditions to happen, you can use break statements to break out of it. So you could have different types of break statements in there, different conditions that cause it to break, otherwise it'll just keep going. Alright, so in this case we're going to go ahead and count by 8 again. Or count by 2s up to 8. So let's go ahead and run that. 2, 4, 6, 8, just like we saw before. Now we could do it like this too. Let's do this. So as I was telling you, you can do a while true, and that'll run forever, so you have to be careful with that one, really careful. And then we can say if I is greater than 8, we can break, and that'll break out of the loop. Now you have to be really careful with this while true. Okay, you don't want to do that very often. You have to make sure that something is going to break this, otherwise it'll just loop forever, and that'll spin your CPU out of control. It'll lock up the computer. It can do all kinds of things, so you really, really have to be careful with this. Probably shouldn't even be showing it to you right now. So there it is breaking. So you have to make sure that it definitely breaks. So, I mean, you got to put some kind of stop in there, maybe something ridiculous, like while I is less than 1,000,000 or while I is less than 1,000, something ridiculous, so that way it breaks out some kind of fail-safe to get out of there. Remember, just be really careful with while true, okay? Okay, iterators, that's the thing that's built into lists, and sometimes those are handy because you could pass them around into other functions and have things operate on them. Okay, so we've got our list of names again. We're going to get the iterator, and then this is an object that's iterating, so we ask, does it have next? And it'll keep whiling, so this is a while loop while it has next, so it's checking this condition. So this is a good while loop because it'll eventually run out of these. That while true one's dangerous, so really be careful with that one. There's our list. So that's how an iterator works. Okay, now let's go back and see what else we have. That's iterators. We got the output. That's good. And okay, here's where our exercise. Okay, so what we're going to do here is we're going to use the loops that we learned. And looking through the program, we're going to use a for loop, another for loop, and a while loop, and a bunch of if conditions. So this is really taking us through almost everything we've learned so far. We've got arrays of strings. We've got dates. So we've got quite a few things in this exercise. Now, it looks longer than it really is because of all the comments. And when we type this out, we're going to leave out the comments. So let's go ahead and get started. So we'll use our same hello world program again. And then the first thing we're going to do is get today. So that's local date dot now. So let's go ahead and let's set that up. So let's remove the code we had before. Let's remove the imports. Okay, so what's the first thing? And I'm going to go ahead and type this time. So local date, that's with the uppercase L. And if I hit enter on that, it should have done the import, and it did. Okay, so then let's just call it now equals local date dot now. All right, so that's the now function that we saw before, and that's setting it to now. And the next thing we want to do is go ahead and print it out as today is and whatever today says. Okay, so let's do that. System.out.println, and that's going to be today is. Yes, right here. Today is in quotes. Today is, and we'll put a colon and a space, and we'll do now. All right, so that'll print out what today is. So let's go ahead and run that. All right, there's today. Today is 7/20. Okay, and then the next thing is let's get the current month. So today.getMonth is what we want here. So let's do this. So here's a trick. Now, on the left side, we've got this variable being set up, and then we're setting it equal to the right side, which is today.getMonth. I'm going to go ahead and do this. I'm going to type the right side and then assign it to a variable and let the IDE finish this part and see if that's any better. All right, so today, let's see, we need to name this today, not now. I named it the wrong thing. I don't want to translate it right now since the lesson says today. Let's go ahead and name it today. And anytime you make a change, you might want to just run it just to make sure so you don't keep going and then all of a sudden there's some error way up above that you don't remember. So today is this date. Okay, that works. All right, so we're going to do today.getMonth. All right, so now I want to assign it to a variable. So if I hit command dot or control dot, it's going to say, give me an option. So let's assign it to a new local variable. And do we call it month of here? We call it current month. So let's go ahead and change the name here to current month. All right, and then the next thing we're going to do is get today with the first day of month. So today with first day with day of month 1. So that's going to give us the first day of the month. So let's do this and let's give it some space here. So today dot with day of month 1. Now let's assign that. So commands dot or control dot, and that's going to give me day of month. And what do we call it here? We called it just day because we're going to set this one. This is now the current day because we're building a calendar, right? So we want the first day of the month. We're going to print it where it goes: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, wherever it falls. And then we're going to fill out the rest of the calendar with it. All right, so that's the day. And then we've got days of the week. And this could be anything here. I just chose 2 letters just because it's kind of formatting. You can do whatever you want. Just remember it's going to be something with your formatting and your spacing. So let's see. It's a string array called days of week. So let's do that. Let's give some space. String array. So square brackets for an array, right? And days of week is what we called it. And it equals this array. So starting with Sunday through Saturday with 2 letters. So Sunday, Monday, Tuesday, Wednesday, oops, uppercase W on that one, Thursday, and I don't know if I used TH on there, I probably did, Friday, and Saturday. Okay, that gives us the days of the week. And okay, so now we want to go ahead and print out the top of our calendar. So we're going to do a for loop here. So we want the length of days of the week. So how many? That's 7 days. And we're going to increment it like we saw with the plus plus. And we're going to do an I variable. And then while I is greater than 0 and I is less than days of the week dot length. So what this is doing is printing out a space to move everything across. Oh wait, if I is greater to move the numbers across. So as long as we've got days of week, it's going to put a space in between each one with this. So as long as it's greater than 0, so it's got to be greater than 0. So the first one, it's not going to put the space first. So what this is doing, now remember the order of the execution here. So if this is true, it's going to print a blank space. Then it's going to print the day of the week with one of these things. Then it's going to print a blank line. So in this loop, it's going to do a blank space, but we don't want one here at the beginning of Sunday. We don't need it there. So we want it to be greater than 0. And then we're going to go into the length. So let's go ahead and try this out. So we got to do a for loop. Let's just do it right underneath because it goes with it. And it's an integer, I equals 0. So we're going to start at 0. I less than days of week dot length. And then I plus plus, we want to increment. All right, then the next thing we're going to do is if it is not Sunday, we're going to print a blank space. So so this is the conditions that we learned, right? So if I is greater than 0 and I is less than days of the week dot length, right here. So we don't want it to be the last thing because we don't want a space there, and we don't want it to be the first one. We don't want a space there. Then we'll go ahead and print out that blank space. And now strings can be double quotes and as many characters as you want. A character literal is just one character, so this is the actual space. Remember when we saw that with the characters in an earlier lesson. This is the actual space character, which is equal to int32. So it's an actual space character. All right, so that's going to print out blank lines. Now we probably won't see that in our window down here, so let's get the other one going. So we want to print out the day of the week. So then we're going to do days of week sub I. And I think that's what that said. I'm just going from memory here, or what I think it should be, and that is correct. Okay, so we can print this out and see what it actually ends up happening. So if we run, okay, it printed them out, but it did a print line. I want them to go across. So the example does print and does print. Print line is at the end to get the new line going. So you saw what happened when you do print line, it's going down. We don't want it to go down, we want it to go across. So we want to do just regular print. So print line will print whatever it is inside the parentheses, the parameter passed in, and then it'll do a new line and go to the next line. We don't want that. We want it to stay on the same line. Okay, so let's go ahead and run that. Okay, now it goes across, and that's what we wanted. Okay, and then at the end of that, we're going to make it do a new line. And with no argument, we just want a new line. We don't need anything printed out after it. So let's run that. Okay, there it is all the way across. So that's the top of our calendar. So we've got the today, and then we've got the days of the week, and now we need to fill in the numbers. So we want to get the right day of the week. So the first day of the week could start on Sunday, which is the beginning, and that's easy. But it could also start on Tuesday or Wednesday or Friday or anything, any of those days, right? We don't know what it's going to be. And we're going to format our days so that there's two numbers, right? So 1 through 31, maybe. But all the numbers that are less than 10, we want to have a space in front so everything lines up right. So like in our example down here, see this 8, we want it to line up right, so we need to put spaces in between. So what we're going to say is everything is 3 characters long, and 2 of them are the actual numbers of the day, even though 1 could be empty. All right, so that's here. So we've got 1, 2, 3 spaces in here, right? So it's 2 possible characters plus a space, so we're going to do 3. All right, so then we want this here, and we're gonna do day, so that's the day that we're assigning. Get day of week, get value, so it's going to give us the number. So let's do that. So day dot get day of week dot get value, and then I'm going to do the assignment, and I think we want to assign, we're going to give it a good name called day of week. The value is just really generic. Oh, we don't want days a week, we want day of week. Okay, so that's a number. So we want to print spaces until we get to that number. So we're going to start on the first one, which is Sunday. So let's start an I. We're going to do I less than days of the week dot length. And then we're going to increment. And why is this complaining? Int I. Got to put the variable there. So it was complaining because I didn't do it right. All right, now this is complaining because days a week is not used. Okay, so inside of that loop, try and see if you could do this from memory if you can. Otherwise, refer back. But try and think about what it is we're trying to accomplish here. We're trying to get spaces in for every one that this isn't. So let's assume that, I don't know what it's going to be, but this month starts on Tuesday. So we're going to print out 3 spaces for Saturday and 3 spaces for Monday, and then we'll get the real number on Tuesday. So we're going to want to print here, system.out.print. Now remember, we want to go across from left to right, not top to bottom. So we're just going to use the regular print. And we're going to do 3 spaces because that's how we're going to format our calendar. because of the numbers. Does that make sense? Okay. Otherwise, we could not do this and we just see them all jumbled together, and then we'll have to format it later. But trust me on this one, it's 3. You could actually just see the top right here. There's 3. There's 3. We want everything to line up. All right, so we're going to print 3, 3, and then we should be lined up on Tuesday. Okay? So we won't see anything because they're just spaces, so we have to actually print something else. So that's just getting us spaces, so we won't see anything until we actually do something in here. And let's run it, though, to make sure it works. Okay, and we've got spaces. Don't know where we end up. Okay, and let's do the next part of it. Okay, now we're going to do the while loop. So while the current month equals day of get month. So while current month equals day.get month. So what we're trying to do here is we want to loop through each day of this month. And as soon as the day is no longer in this month, we want to stop looping. So say we're in July, because we are right now at the time of this recording. And by the time we get to July 31st, the next day is going to be June 1st. And as soon as June 1st is there, we're going to say, hey, day, what month are you in? And it's going to say, or not June, it'll be August. It'll say, I'm in August. Okay, that's not our current month. We're going to stop because we're in July. And that's the one that we want. Okay, so we're going to do while current month equals. So try to think of what we're trying to accomplish and see if you can do it yourself. Otherwise, refer back. So if current month, which we have up on top, equals day.getMonth, then we're going to do something. Otherwise, we don't want to do it and we want it to stop. All right, so then the next thing we're going to do is get the day of the month, which is the number. So we're going to do day.get day of month. And that's going to give us the day number. Now I'm going to assign it to a variable using this. And what do we call it? Day of month. So we took their suggestion, which is good. You always want to try and be descriptive of your variables, otherwise you won't remember what they are. Okay, so now if the number is less than 10, we're going to want to print a space in front of it, right? Because let's go to our example down here. Okay, it's going to start on Thursday. So we need 3 spaces. 3 spaces, and this is the loop that we're doing up in front, right? 3 spaces, and then 3 spaces, and then 3 more spaces. So we're going to do that 4 times. Now we're underneath the T. We don't want our 1 there. We want our 1 here, so we're going to put a space in front of it. Okay, so we're going to print a space, and we don't want to print line, even though it's telling us, it keeps suggesting printing a new line. That's not what we want. Now, we want that if day of the month is less than 10, so only has 1 character or 1 thing that would be printed out. Okay, and is that what our example says? Yes, so I'm thinking right so far. All right, so now we've got spaces in front of it, which is what we want. Now we want to go ahead and print out that day of month. So let's go ahead and print it. And we don't want to print line. It keeps suggesting that. So day of month. All right, now we'll see something. So let's go ahead and run it without finishing, just to see where we are. Ah, it's running forever. How do you stop it? Okay, that was dangerous. Why is it running forever? Because we didn't increment the day. Okay. So, good question. How do you stop it? There's some controls. Let's do that stop button. Where's the controls? Wow, so how do we get back to it? Debug console. No. So here's a case of a while loop gone crazy, right? And is it still running? Did it stop? Yeah, it's still going. So let's Control C this. All right, that's how you stop it. Control C. Get down that window. So my computer actually got hot. I could feel it getting warm because it was just running like crazy. So this is a while loop gone mad. Okay, so it just kept going. So let's go ahead and put the incrementer in. So what so we're going to do day equals day plus 1 day. So let's definitely do that right now. Now I'm glad that happened because now you get to see what a crazy runaway loop went. We're going to do plus days and we're going to add 1. So now we're going to take today, we're going to add plus 1 day, and then that's going to set us equal to day. So then we'll stop on this month. So now let's print it out. And if we get a runaway, we know what to do now. We hit Control C in the terminal window. Okay, and look what it did. It went all the way out to here and then printed all the letters, all the numbers of the days, which is great, but that's not where we wanted it. So we've got our spaces there, and we've got our while here. Oh, and it's just printing spaces and the day of the week, which we have. So how did we get all the way out here? It looks like we have a print line somewhere. So that's one's proper. That looks right too. Oh, we never went back to the beginning? I don't know. Let's see if we can figure it out. Oh, we're not looping back. So we need to get back to the beginning line. So we ended up here on Saturday. We ended up printing a space, it looks like. And then we started printing our things, but we never went back to the beginning because we're just looping and adding days, but not ever going back to the beginning, getting a new line basically. So that's the point of this. So if the day is not Saturday, so Saturday is the last day of the week. So if not day, remember we flipped this, equals Saturday. So as long as it's not Saturday, go ahead and just print the space. So we want to do the space is coming after. So this one here is printing the space before the number to get our numbers to line up. This one here will print a space, and we're going to do if day. So, and you can refer back. I might not even remember this. Day dot day of week dot equals day of week dot Saturday. So we're saying if it's not equal to Saturday, we want to print the space. And we don't want to print line. We want to print just a space. Because we want to do, so we're going to do a space if it's less than 10, the number, and then we need a space so that way there's a space in between the day we're working on now and then the next day. So if that happens, we've got that going. All right, so let's run that. We don't know if our calendar is working yet, and this is an incremental process. It's not going to be perfect the first time. You have to work through it. All right, so now we've got spaces between our days, at least some of them. So 10 is not doing something, but that could be because we're supposed to be on a next line or something. I don't know why. And you can see this one has 2 spaces in between. So it's still kind of funky, but we're working through it. Okay, so then we've got those spaces. We got the space. So we've got a space happening after. We need that new line. We need to start over at the beginning somewhere. So what do we have here? So this one's adding their space, and now we're doing if the day, not the day, but if the day actually is Saturday that we just printed, we want to go ahead and do the new line. So that way we end up on the next line, which puts us at the beginning. So let's see how that works out. So if day, let's go ahead and do that. If day dot get day of week dot equals day of week dot Saturday. Then we want to print a new line, because after Saturday prints, we want to go back to the beginning of the line. And nothing in it. All right, now let's run that and see what we get. Oh, close. It did everything okay except for this. That needed to be over there. So what are all these spaces here? What all those spaces are must be this thing. So this thing's doing I equals 0, days of the week dot length. It's going all the way to there. I don't think that's right. I think what it needs to do is go to whatever day number this is. So let's check and see Did I just read it wrong? Okay, we've got to the day of the week is where we need to go. I went ahead and went all the way to the end of the week. And I mean, that happens in programming, even for someone who's been doing it as long as me. And that's why I just iterate through it. I run it. Oh, that's not what I want. I run it. Oh, it's closer, but not quite. Oh, I run it. Okay, that's better. So that's what we're going to do here. We're going to set this to days of the week. So that's what I did wrong here. So I did days of week dot length, which is a loop of all of them. I don't want to do all of them. I want this day of week. This one right here, because that's when I want to stop. I don't want to go all the way to the end. I want to stop when it is this day. So now what happens when we run it? That's better. And that actually is probably right. Let's confirm that by going to some calendar. So we want July 20th, and let's see what that calendar looks like. So I just copied that. Let's go to a browser and type in a calendar and just paste in this date. Sure, let's try the first one. Starts on a Thursday and ends on a Saturday, and there's 31 days. All right, let's see if that's what we got. Starts on a Thursday, ends on a Saturday, and there's 31 days. Okay, that's it. So we used loops and conditions and incrementers to get a calendar to print out. And that was a pretty challenging exercise. Okay, that's it. Thanks for watching. Hi, everybody. Okay, so for this lesson, we're going to learn about objects. At this point, you pretty much have the programming basics down. And those will apply pretty much to any programming language. There might be some specific syntax that's different, but you've got the basics down at this point. You've got variables, you've got functions, you've got calling functions, you've got loops and conditions and branch logic. And that's pretty much all there is to programming, and then it's just a bunch of that piled together to make bigger programs. So you've got all the basic building blocks at this point. Now, Java is an object-oriented language, and that means it's you break things up into objects that have functionality, and just it helps you maintain the projects programs a little bit easier. So we're going to start covering that stuff. So this is the point now where we start putting all that we've learned together into creating programs. And in Java, the way you create programs is with objects. So at this point, we're going to start, for the next few lessons here, we're going to start actually building programs with what we've learned. We've been doing that along the way with our exercises, and now we're actually going to start putting it together into objects, which Java is all about. Okay, so you've done a lot of this stuff already throughout. You can't really get away from it. So you've already done things like the new keyword. You've created new instances of objects. We're just going to describe it in a little bit more detail here. So a file object is a class that's built into Java. You can make your own file object too. It's as an object-oriented language. You can create your own objects, your own classes, whatever you want to do. But so the new keyword is how you start an instance of a class. So say you have a class. It's a definition of what an object can be, and you could have several of those with different, in this case, different file names. So you could have 3 different file instances, file objects, and each one has a different folder or file name. And so that's pretty much how those work, and you create those with the new keyword. Okay, so then you can call functions, and we've been doing this as well. So you call functions on another object. So this is another object here, so we're going to say this is a program that we have, a class that we made, and this could be our main hello world that we've been using. And we create a new file, sample text, and then we're going to call this function on it. Does this file exist? So you can say, I have a file, it's named this, and you say, is it actually there on the hard drive? And that's what this function is. And so that's how you call functions on another object from an object. Okay, object equality. Now this is a little bit tricky in Java. Equality is 2 different things. The dot equals is what we use to compare objects together. So you could create a new string, hello, and another string with the exact same word, and so that should be equal, right? But if you actually print out our equality operator, the double equal sign, A equals B, this is false. Now, why is it false? Because in Java, it's comparing the base identity of the object. So here it's getting the ID of the object. Is A equal to B? Well, no, but they're two separate instances. They're not the same instance, and that's what this is checking. So when you're working with objects, you actually want to use the dot equals function. Now, it's same set of strings here, hello and hello, A and B. Now we're going to say is A equals B with the function, and then it gets to true. So then it's actually seeing, are these two things equal? Hello does equal hello. And so that evaluates the true. So remember that. This double equals, it works great for numbers and primitives, doesn't work great for objects. You need to use the equals for objects. Okay, now variable scope. We learned about variables. We know how to assign them. Now, how are they visible? Some are visible in different contexts. So a class, which we've gone over already, so the anatomy of a class. And a class definition starts with these brackets, right? So this bracket here and that bracket ends it. So for class scope, which is what the one we're talking about now, any variable inside of the first bracket pair is visible to any other code inside of this class. So in this case, the variable name is available in the constructor, it's available in the in a function, and it's available in another function also within another code block, which is this for loop. So if you define it at the class level, and sometimes they call this member level, that variable is available anywhere within this class. Now function scope is smaller. Within this print function, name is not visible. I don't even see where name is defined here because it looks like I left it out. Oh, no, I didn't. I put it down here. So name is in this defined down in this function here, and it's visible in this for loop block here because when the variable is defined within these two bracket pairs, anything inside of the bracket pairs can see that variable. So name here is visible to this for loop, but it's not visible to this other function up here because it's not defined at the class level. It's defined in the function level, so only visible within this function. Loop scope is a little bit tighter, so we're going smaller now. This j variable and this I variable are visible within this for loop. So anything from for inside of this for configuration and its brackets is visible within this for loop, but not outside of it. So these two brackets right here have the visibility to anything defined within this for loop here. And then there's bracket scope. So anything that's inside of brackets. So you've got an if condition here. Here's two brackets. And chars is only visible inside of here. And letters is visible here because it's within this function block. So this is a bracket, set of brackets inside of a function. So that's where this is defined. So you see here this variable, and the way to tell is you can say, okay, here's the variable here. What's the next bracket up from it? Okay, it's this one. Where's the closing bracket here? Anything inside of there is visible. That variable is visible. Okay, object-oriented languages. There's a trait or an ability about objects in that they support inheritance. So what that means is if there's a class in Java that's defined either in the base language or some library that you're using, and it's not declared final, because you can call it final, which means final means you can't extend it. Otherwise, it's extendable. So you can go ahead and grab a class, say mammal, and extend it with lion. So you can create a new class from an existing class, and that's how you keep building on functionality. And that's how programs can get more complex. And then also you have libraries that allow you to build more powerful programs, and you can extend the library if it doesn't do what you need it to do. And it also helps you organize your program. So in the case of inheritance here, we're using mammal as the base class, and lion is the subclass, and it's extending the functionality. So mammals all have hair or fur, And so this is a trait of a mammal. And then a lion extending mammal, so being a mammal, but more specifically a lion, also can roar. So this is extending mammal. So in this example down here, if we're testing out inheritance in our main program, we can create a new lion, and then we can see that it has hair or fur, which is inherited from the mammal class that it extends. Now, composition is preferred over inheritance because in Java, you can only inherit from one parent class. And that gets pretty tricky if you get too deep in inheritance, or your program's really complex where you're trying to use a hierarchy of inheritance. It's really, really difficult. And it gets kind of unmaintainable. It works in some other situations, but for the most part, the more flexible way to go is called composition. And this is by implementing interfaces, so using the implements keyword in Java. So when you create your class, you're actually implementing traits called interfaces, and that's how you can have multiple inheritance in Java. And it's just more flexible and more maintainable. It's if your program gets really big, inheritance makes it a little bit harder. You can still use inheritance, but overall you don't want to just say we're strictly doing inheritance, because it does get too difficult as your program gets bigger. So composition is the way to go. So let's take example. Let's say we're building out users, right? So they have logins, they have names. So let's say in some contexts we want the person. We don't care that it's a user. We just want the person's name. And we don't care what their password is. We don't need it. So that would be the person context or the person interface. Same thing with login. We have usernames and passwords. For logging somebody in, don't necessarily care about their name. We just want to see if they have a username and password and it matches. So that's a login context or a login interface, and we don't really care about the name at that point. Now, the user is the implementation of a person and a login, and that's how the program gets stored, or sometimes we use it in a user context where a user has a username, a password, and a name. So we're going to implement person, we're going to implement login, and we're going to call our class user. And so this gives us the ability to have a user implement two different contexts. So this is a constructor, which you've seen, and here's the variables. And we're going to set it, so anytime you call a new user, you're going to give it a name, a username, and a password. And then here's the getters for those. Now, let's say that we have a login service. So this is our user service, and allows us to authenticate a user when they log in. So the password has to be equal for this user to have a successful login. So our user service, and we're not using a database here, we're just going to go ahead and use it as a map. And we're going to create a user called Wally at@gmail.com, and the password is ABCDEFG. And we're just going to add that as if this is a database. And then when we call the authenticate function, it's just going to take in the login information, which is username and password, and it's going to get users by this username. And then if the password, remember, .equals user's password, then we're going to return the user, which is in this case going to be sent out as a login, but it is in fact the user because that's how we're storing it. If it's not found, we're just going to throw an exception. In our case, stop the program, and we'll just say user not found. And so here's us testing out that login. So we're going to run main. We're going to pass in the username and password. We're going to access our user service to authenticate. And then we're going to get our login. And if the login's good, we're going to print hello. We're going to cast it here to a user. And that's probably not, this is a contrived example, but you can get it as a user, so you can get to the name. We're getting it as a login from the authenticate service, or the authenticate function, but here it is as a user, so we can get the user's name and say hello, whatever the username is, in this case Wally. Alright, so that's how that works. I think what we should probably do is, what I'd like you to do anyway, is go ahead and implement this authentication service. Now, I typed this out without actually programming it, so hopefully it all works. If it doesn't, it's great exercise for you to figure out what is wrong. I think for the most part it's right, but there might be something in there, and we could call it a game almost. Is it right? And so implement this composition. So you're going to make these classes, and remember, class name has to match the file name, right? And so go ahead and pause your video and try to do this exercise, and then I'm going to record it, me doing it, so you can watch along and see if your solution is the same. Okay, pause your video. Okay, so we're back, and now I'm going to start going ahead and implementing this. So I'm going to open up Visual Studio Code, and I'm going to start creating, it looks like I'm going to create 4 classes here, so 2 interfaces and a implementation class, and then I'm going to do a user service, and then for the 5th one we're going to use, I guess we'll create a new one, because now we're going to start practicing. We won't use our Hello World program anymore. Now we're going to start building real programs, so let's go ahead and build that out. Okay, so let's try and do as much as we can from our understanding of the problem. Try not to copy and paste any of this, type everything, and also try to see if you understand the concept. We've got, and so it's kind of simple. We've got a login, username, and password. We've got a person, just has a name, and we're going to call that a user. We should be able to type that out just by thinking as we're programming. So now you're going to start learning to think like a programmer and not just following along with some tutorial. All right, so let's go ahead and open up our editor. This is our Hello World program. Let's go ahead and just create our new set of classes. And it looks like I'm not in any kind of folder, so let's just close these all together. So we've created multiple classes before, and let's just use our keyboard. And we're going to clear this out too. So if you type clear in the terminal, it'll just wipe that out. Okay, so now we've got a blank editor. So I'm going to hit Command New, and it's it's Command N, and it's Control N on Windows. All right, so let's start a new class, and trying to do this from our understanding, not memorizing what's in the tutorial, but our understanding is that we need a login class and a person class as interfaces, and that's going to be implemented by the user, which is where the details will go. All right, so let's do that. So let's create a new class first, and we've got a file here. So let's call this one person.java, right, because it's got to match the name. We'll save, and we'll just leave it right there in whatever folder it is. We won't use packages yet. We'll get into that soon enough. All right, so then now you're going to go from what you've learned. So public class, right? We need a class first, and this is called person, and it starts with brackets. So now we've got our first set of brackets there, and person is going to have a name, and we're going to keep the name private here because you don't want anyone accessing these details. You'll provide a getter or setter for that. And now this is an interface, so the interface doesn't have the scoping like that. So string, and it's going to be name. And so that is specifying what our interface is going to have. And I put the word class here, and that was wrong. This is actually interface. And why doesn't it like that? Blank final field may not have been initialized. Of course not, because this is an interface. Oh, we don't need public either. And we don't have variables here. This is actually an interface. So see, even I am forgetting how to do this. So if you have to refer back to the tutorial, go ahead, or you could just fumble along like I'm doing. So string, this is an interface, so it needs to have a function. So this is how we want to implement that. And now it's happy. So at least the IDE is helping us out a little bit. All right, so we're going to have a function named getName in our person interface. All right, so that's that. So let's go ahead and make our user class now. So I'm going to hit N. I'm going to create user.java. And this is a class this time. And it implements person. So some IDEs complain. I don't know if this one will. If you don't have the implemented methods, and this one does not complain that I know of, but maybe it does, and I just don't know how to make it complain. And by complain, I mean it tells me that it's not implementing the interface. And sometimes you can discover it by, if I click on person, nope. All right, so let's implement the interface here. And by implementing it means make the code the way it should be. The interface just defines what the name of the thing is and what it returns. And now we have to put in the body of it. So here we'll make it public because we want it to be visible. And it's going to return a string because that's what the interface says, and it's get name, right? Because that, and now we can refer back to this. So it's get name, and we're going to return a name variable. Now here's a problem. Where's our name variable stored? We don't have it. So this is kind of working. It's not really working backwards. It's working iteratively, and it helps self-discover what code is needed. So you're going to type what you think you need, and then you're going to discover what's needed by as you type. Like, oh wait, I don't have a name variable. So then you go up here and implement that. So private string name. Okay, so now that's going to go ahead and return that. Now, our constructor, which is what an object or what a class needs to actually construct something, is where we're going to actually assign this value. All right, so constructor doesn't return anything. So public user, and we're going to pass in the name. And then we're going to set this name, which is this name up here. So this refers to the instance of this class, and equals the name that's being passed in. So now if anyone wants this, they're going to pass it in here. And notice that I haven't implemented the login part yet. What I'm trying to do is go all the way through to the end, and then I'll fill in the details of what's left, because this allows me to get to something that's a value that I can test as quickly as possible. I could have tried to type out everything, the person interface, the login interface, but then it's taking me longer to get to something where I can start testing it and seeing if it's working. So I'm trying to get to something that's the smallest thing I can do that actually is valuable to test. So I'm at user, I've got name. So let's go ahead and make that program that we're going to use to test this thing out. And we can call it whatever we want, but let's call it, what was it? Test. I have no idea what it was called. Let's just keep the names consistent since this is a tutorial. User service, that's something we need, but not yet. So test user login. So that's what I'm going to call it. So this is the class that I'm starting now. Test user login.java. Let's save that. Okay, and this is a public class. Test user login. Now this is going to be our the actual entry point of the program. So we need a public static void main, right? And it's going to take a string array of arguments. Okay, and this is our entry point. So this is the thing that we get our actual run and debug. So now we're going to start testing out some stuff. So this isn't the real code maybe that we're using. So we have a new user, which we have here, and it implements person, so it's going to have a name. So let's go ahead and just type in Wally, because that's what our example had. All right, and then let's assign this by using, I used command dot, and then you can use control dot if you're on Windows, and we're going to have a user there. Okay, so now we've got the constructor. It's actually being tested. Let's go ahead and system out printline this. Now this is going to probably be throwaway code maybe. I'm not sure. I'm just trying to implement something and get to something testable. Let's go ahead and run this and see if we get... Okay, so user just printed out the user object. So let's do user dot get name, because that's the interface that we wanted, right? Interface method or function we wanted. And it printed out Wally. Okay, so now we've got that going for us. All right. We want to log in this user. So at this point we can create the user. They're not saved anywhere, but we could actually create the class. Let's go back to the tutorial now, because I'm starting to forget what our purpose is. And this is kind of the definition. Okay, so we want something that logs people in and is for our user. So we have a user, but they need a login. At this point, would I implement the login part now or the service part now? I would probably do the service part now, because the code that we have now is just creating an object user and just spitting out the name. Anything with the login part is kind of not very useful yet. But creating the starting to fill in the login, the user service with authenticate starts giving us a purpose for adding the login. And so as long as we have a purpose, it'll help guide us along the way. So now this is thinking like a programmer, thinking like a software engineer, trying to figure out what the purpose is and let the purpose drive what you're coding. Because if you're just implementing stuff, it's kind of hard to think about. Where if you actually have a purpose in mind, then it guides you as far as the thinking goes and what needs to be done. All right, and let's try and keep the names consistent, at least for me, because I'm trying to share this with other people, and I've written it down this way. Okay, so it's going to be a user service, and it's going to have a user. So let's just go ahead and start that off. So I'm going to start a new class, and it's going to be a public user service. Oh, wait, I need to save it as Java first, so let's go user service.java. Okay, and that's a public class user service. Okay, and it doesn't need a constructor. I gotta tell it's a class, otherwise it's gonna complain. All right, and it has users, right? So this is our user service, and we're not using a database. Otherwise, this would be accessing a database. But we're just gonna use a map as our database right now. And you remember map from one of our other lessons. So the map, we're gonna key it off of the username. Someone's gonna log in with their username and have a password, and we're gonna store the user. So we want to store the user by their email address or their username. So let's go ahead and call that a string, because that's what an email, I'm assuming email address, it could be name, but let's assume email address for now. And we're going to store the user. Okay, so that's, we're going to call users, and let's make a new hash map. You guys remember that from one of the other lessons too. Okay, and so now we're going to use a static code block to initialize this, and let's actually make this static, so any instance of user service will be able to access this, and let's make it public. Actually, we don't have to make it public because it's visible. So let's just make it private, and we don't want anyone accessing our users directly. We're going to be the ones interacting with it. So in this case, we're going to make a new user. So here's where we're going to call new user, and it's going to have name. Now you're going to see where this purpose comes in. All right, so new name, and let's assign that to a local variable, and then let's add it to our users map. So users dot put, right, for a map, user dot get name. That's the name. I actually want it by the login username, right? So see how the purpose is being driven by what we're trying to accomplish. So now we need a login. So it's okay to leave this off for now and go and implement the rest, because now this is actually driving what we're implementing. So our user class needs something. So our user class needs to implement a login, and this is where we start making the other things. So now our other interface we need is called login. Now that class doesn't exist yet. So some IDEs will prompt you, and IntelliJ, so when you start writing more intensive Java programs, a more powerful IDE might be useful. There's probably a way to get it to do it here. I am just not sure what it is. And we're learning, so let's type it out for now. So we need a login interface. So let's create a new class, and we're going to call this one login.java. And then we'll make our interface. So this is a public interface. That's called login. All right, so you could also, we know what methods or what functions we need. We need a get username, and we need a get password. But let's let the purpose drive what we actually fill in here. So starting to work like a software engineer, starting to work like a programmer. Let the purpose drive the program. So let's start filling in our user service, and it'll help drive what we need here. So our user is going to be added to our users map. So users dot, and we're going to do put. And now we need user dot, and what do we want? Get name isn't what we want. We want get username, because this is the username that we want to map our users by. All right, so we don't have that function, right? So let's go ahead and add it to our login interface. So we need a string get username, and it's a function. Okay, so now we have to go to our user class and add that. So IDEs help you do this, but this is good that we don't know how to use this IDE in this way yet, because it's forcing us to learn how to do this without the help that might hinder us from learning. So then username. Now remember, we're working almost, it's like working backwards, but it's allowing the purpose to help us figure out how to implement this. So username is not a variable that we have yet up here. So we're going to go ahead and fill that in. All right, so now we've got a username there. Our username's not getting set by our object, so let's add it to our constructor. And we'll assign it here. Okay, so now we've got username on our user, so let's go back to our test program. And this is almost like test-driven development. I'm not teaching you unit testing yet in this set of lessons, because that's a little bit more advanced topic, but that is actually what we're doing right here. This is called test-driven development, but we're not actually doing test-driven because I'm in the user class. What I would actually be doing if we were doing test-driven development is we'd create a test, which is kind of what this one is supposed to be, and we'd be filling it in that way. So we're actually doing programming this way. So we've got our user service, and we're just working kind of backwards. But it might be valuable by the end of this set of tutorials to start doing test-driven development, just to show you what that's like. And maybe in our last exercise, we'll do it that way, because that makes more sense to me for learning. All right, so now we're going to go ahead and put our user here in the value. Okay, so now we've got this. We're adding our user to it. So let's go ahead and just, this will be throwaway code. Let's see, out.println. And let's just print out our user's map, just so we see what it is. All right, so that's putting this here. We've got a user service, so that should print out somewhere, I hope. And let's see. If it doesn't, we'll figure it out. But we're doing this. We don't need this anymore. And so I actually don't know if anything's going to happen with that user service and this printing out. It's a static class. We'll access it and see if anything happens here. Okay, so let's go ahead and access it here. Let's do user service dot, and we don't have actually anything to do here, right? We've got a static class and a static initializer, which needs the static keyword to initialize anything. All right, so that'll run static, which means when a class is first introduced and used to create an instance, it's going to run static things. And a static thing is, this is available to all instances of this class. So anytime we create a user service, these things are here. So let's go ahead and create a new user service and see if that prints out anything. I hope it does. In theory, it should. It started to do something. Unresolved compilation problem cannot resolve. Name cannot be resolved to a variable. And it's saying it's in the user service init. So can I click on that and jump to it? Apparently not. All right, so it's saying add our user service line 8 in user service. So line 8. Yeah, where is name? That's because we're creating this right here on the fly. So name is actually Wally. And our constructor also has a username at gmail.com. Okay, now let's see what happens. So at least it's going to print something once we get it working right. So let's go back to our program and run it. All right, so there's our kind of database, and it's got the user right there, and it's Wally at gmail.com is equal to that user. So that's pretty much working. So now let's let our purpose keep guiding us. Our user service doesn't need to print that out anymore. All right, so what's the next thing we want to do? we're going to want to log somebody in. So let's go ahead and start filling this thing in now. So now oh, did I just delete the user service code that we had? All right, so we've got a user service. Let's assign it to a variable. All right, so we've got our user service. And now we're going to start using the user service to authenticate someone, which just means they're logging in. So our user service needs to have this function, which does not yet exist. And we're going to want to pass in the username. So gmail.com for Wally, and the password, and A, B, C, D, E, F, G for fun. All right, so then, and let's say it passes us back a login object. That's what we had there. And we just want to know that we got a login object or not. All right, so now our user service does not have an authenticate function, right? Because we didn't implement one. So now that's going to drive us to actually create one. So we want that to be public, and we're going to return back a login, and we're going to say authenticate. And it's going to take in the username and the password. Okay, and so how are we going to do this? It wants us to return something. So we can simply do this if we want to return something now. And in unit testing, this is kind of what you would do. So you'd return null, and then you'd run your test, and it would say, your test should say it wants a actual login, and if it returns null, it'll say, okay, your test failed, now you have to make it work. All right, so to make this work, though, we want to get our user, so we're going to use users.get, and we're going to get it by the username. Now, I wrote those classes out in the tutorial. Now we're actually implementing it as if those weren't written, and we're doing it from scratch. So you're learning how a programmer or how a software engineer thinks to build a program that they kind of conceptually know what they want to do, but haven't done it yet, or hasn't made it yet. So now we're going through that thought process. Okay, so this get is going to return type user. So we want to define a user, and that's what's going to capture that. Okay, so then what do we want to do now? We want to make sure the password is right. So if a user dot get password, because we got a user, we think. We don't know, actually, and we'll need to check that. So there's the user's password, and we've got a password coming in here, so we want to see that they're equal. So let's go ahead and use the password that's coming in, because we know that probably has a value. And we'll see if it's equals the user that we got from our pseudo database, and make sure those are equal. And if they are equal, we'll then return the user. If they're not equal, we'll throw a new exception. Let's make it a runtime exception. Not that it matters, but runtime exception will exit the program, kind of, or at least it tells us that it should exit the program. Okay, so I see something wrong here already, and I don't know if the tutorial code has this in it. There's a possibility that this username coming in here will not match anything in our database. And if that is the case, this user will be null, and this will throw a null pointer exception. And we could test that out, but let's just go ahead and do what we know. So the user must not be null, and the password must be equal to return the user. Otherwise, it's going to throw this exception, because either the user wasn't found or the password wasn't found. And in this case, we can just say authentication error, or credentials do not match, because you don't want to give away in security stuff, you want to give away the fact that, oh, okay, those credentials are right, but they don't match. So that way you aren't giving anyone information that, okay, I got a username right, now I just have to figure out the password. Credentials do not match. So that way it's not really telling them anything. And I don't think I put that in the tutorial, but let's go ahead and run that here. Okay, so we've got that. And let's run this. Okay, so our authenticate takes a username and password. Are we there yet? Username and password. Let's see if we get a login. And let's see what it prints out. Okay, so method password is not defined for type user. Well, that's interesting. So this program's actually helping us now that we don't have some of the things that we need. So, yep, get password is in fact not defined, and neither is the password there. So we're actually missing some parts. So our user service is where we're building the user out here. It needs to actually pass in the password. A, B, C, D, E, F, G. We're just having a fake database here, right? So that's added there. So then on our user, let's go ahead and add this to our constructor. And we'll store this for our object. And then we're going to go ahead and allow someone to read that. And this would be done better as test first development, so you could see it in full. But again, that's probably too advanced right now for this lesson, so we're just going to do it this way and get the learning experience in here. So get password. So this is allowing the broken program to guide our implementation, because we have to fix things that are broken. All right, so if we run the program now, what's it going to do? It should be another error, I'm guessing. Password cannot be resolved to a field, and that's in our user service, or in our user, sorry. Let's see, we've got password here, password here. Ah, didn't create the field, which is what it told us. So the errors are guiding us. All right, so now we've got that password. Then let's just run it again and see what happens. Oh, we got a user back. That's pretty cool. So it's actually working now. And let's go ahead and see. We've got the user. So let's see their username. Let's see which one we got. We know which one we got because this is the one we passed in. So let's go ahead and run that. And it should be wally@gmail.com, which it is. All right, so now let's go ahead and instead of getting the username, so we've got a login. Let's go ahead and do this. Let's get this as a user. And we're gonna cast it, because that's what we did in that tutorial right up. And we're gonna take login, and we know it's a user. Sometimes you don't know that, and we might want to write some other program, but let's just keep it simple for now. We know that login is in fact a user, so we're gonna cast it to a user so we can access the user get name function. And let's go ahead and run that, and everything just fell into place. We got Wally. So now let's go ahead and say hello. Hello, Wally. And we'll run that. Okay. I'm actually a little surprised myself, because that filled in rather naturally as we just went, and it filled in the program. It might be close to the tutorial definition. I think it probably is pretty close, and so we implemented it from scratch as we went, and it might be the same, it might be a little bit different, but we actually did it without referring back to the tutorial. I think we actually made an improvement here too, because I think this would be a problem. So let's go ahead and test that out. If we try to log in somebody that's not in there, let's say Bob@Gmail, and I think we're going to get a program exit is my guess. Let's see what we get. It's got a runtime exception, credentials do not match. So we got the error that we were expecting. So let's put Wally back in here. Okay, it's working. So that's how you think like a programmer, think like a software engineer, implementing a solution by letting the purpose guide your programming and letting errors, and if in the case of test first development, letting test failures guide what you need to implement. And so that's kind of how programmers and software engineers work. That's it. Thanks for watching. Hi everybody. In this lesson we're going to go ahead and continue with our objects and now talk about member access. So access from the outside of a class to other classes on the outside. So you have an instance of a class and it's got protections around certain functions that you want to keep private. You don't want anyone calling those. And the ones that you have public or accessible with public or protected or default level. So that way other objects can interact with your functions, just like we did before when we showed that you can call a function from another class. And now you can protect certain things, and the reasons that we protect implementation is so you have the flexibility to change the way things work inside of your class without breaking the thing that's calling it. Because say it's calling the run function of some machine that you have that's doing something, and you find out that there's a better way to optimize the way the machine runs. You want to be able to change that implementation and still have that other program that could be compiled separately or could be your own class not have to change just because you changed something on the inside. So what that's called is encapsulation. It's an object-oriented principle where we basically are hiding data or hiding implementation on the inside of the class, so that way when there's an instance that's being accessed from the outside, you're free to change what you need to change to make that work better, fix bugs or whatever, without breaking everybody. Because imagine you have this library that you made and you've got all this code in there, and now there's thousands or millions of people using this library, and you go to change one thing because somebody reported a bug, and when you fix that, all million of those people have to recompile their program to use the new one. It's not what you want. So typically you want the interface of the thing that they're calling to remain unchanged, and that be the only thing that they're interacting with, not looking at the details on the inside, so that way you can change everything that you need to on the inside. Okay, so let's talk about this. So there's different levels of access and there's different levels of protection. So at the class level, that's where the class is defined. We can say that a class is public, which means the whole world can get to it and instantiate it and use it. Of course, the members inside of it can be protected from there, but the class is available for use, and whatever it makes available is available for use. Now, classes can be either public or they can be default, which means only things inside the same package that can see them and instantiate them. Otherwise, public means the whole world can see the class. Okay, so when it's in public, the class can be seen outside of it, even in another package. So here we have this one in com my package, and this is my class. And then we have another package, com some other package, and then we're going to go ahead and import in my class, and then here we can go ahead and instantiate that class and then access its public function that says say hello. So that's doing public. Now when there's a class that's defined with default, which means you don't actually specify anything up front, no public, and you just say it's a class, my class. Now when something in the other package tries to access it, it's going to get an error that this thing's not found. It's not visible, so it can't instantiate this. So it will have no access, a no access violation or something like that. So public is usually what you want your classes to be. But for your internal program, you could have classes that are hidden and they have implementation in your program that could be a library that somebody else is using, but they can't see these classes in there. And that's how you, like we explained, you can maintain your program, break things up the way you want to break them up without having to expose the details to the outside, so that you don't break things when you make changes that you need to make changes to. All right, so member level access, and that's inside of these classes. So what we just talked about was the class itself. Now we're talking about within the class brackets. And so you can define these as public, protected, or default access. And so it's very similar. So public means that the whole world can see this function as long as the class is visible. And then, and so here is an example of that. So this other package, other class has access to instantiate my class and can call these things on it. And so that's how that works. Now, this member here is, we also made, now you don't normally want to make a member variable public, but in this case, for example, you can do that. And there's some cases where that might be something you want to do, but for the most part, you want to data hide these too, because what if you want to change this variable name? Because now it doesn't make sense that it's a name, maybe it becomes a username, something like that. So you want to be able to hide what your implementation is. But in this case, for example, you can make this variable name public, and you can make this function name public. And then this class, some other package, some other program, wherever, can actually instantiate those. Now, protected is another way of saying you can subclass this. We showed that in how you extend things or implement things. The interfaces don't actually have these protections on them. They don't need them. But if you're going to extend a class, you can make this protected. So now only a class that extends my class can actually see this variable name and this function name. So here, this would not be visible to something that does not subclass my class. So this one is just trying to use my class, and the class is public, so it can instantiate it, but it can't call say hello, and it can't access name. And then default, it works similar to did with classes. It's got to be in the same package in order to see this. So again, a class in another package can instantiate the public class, but can't access the function or the variable name. So those are protections. Now, private means that it can't see it at all. Nothing can see it, only inside the class can see it. So in this case, my class is public. Name, which is proper, is hidden. So that's private. Say hello is also private. And then we have a public function that's is actually looking at say hello and name, and it'll go ahead and you can access this one, and then this one can access these. So that's a way of allowing the user to interact in a known way that this one is actually very known, because the user is only going to call this. And so anything inside of here can change, and it can return, and it won't break anything because you're just going to still return a string. So that's why we do that. And then same thing here, error, it's got private access only, it won't be able to get to it. So that's how protections work in Java. And you've kind of been working with these already, and it gets more clear why we do this as you go along. The programs that we're making in a beginner level course like this aren't really big enough to actually see the benefits as much, but you definitely want to follow best practice. You want your member variables to be private. You want to limit the number of public functions you make to only those that people who are interacting with them need to call, and you want to keep those not changing so that you don't break everybody who's using it just because you change that. So if you have a public function that takes parameters and has a return type, you don't want to break that. You want to keep that signature, method signature, the same, and that's what that's called. So this would be a public method signature. Let's get one with parameters if we have one. There isn't one, is there? Nope, there isn't one with parameters. Okay, well, anyway, what you want to do is keep the method signatures consistent. Whenever you have a public one like this one, you're just going to keep it consistent. You don't change that. You can change anything on the inside, and you can change anything inside the class as long as it's not visible. Anything that you made visible, you kind of want to keep it the same. Otherwise, it's called a breaking change, where it's a change you made and it breaks things, and you don't really want that. Okay, so that's how protections work. There's not really a good exercise for this one, other than going ahead and implementing this example in your IDE. Go ahead and go open up Visual Studio Code and just play around with these exact examples and see if you get the same outputs. I typed these in without putting them in Visual Studio Code, and see if you get the same results that these say. If it says error, you should see an error. And that's it for this one. Thanks for watching. Hi everybody. Okay, we're kind of wrapping up the object-oriented principles here in Java with object-oriented concepts. So we talked about inheritance, we talked about interfaces, so composition. We've talked a little bit about encapsulation, hiding implementation inside of a class. Now we're going to talk about the object-oriented concepts that help hope that we bring it more together. And then in the next lesson, we're going to actually build something with everything we've learned, because this is really the last thing we need to learn here to be effective in Java. And we can start creating some pretty good programs with what we know already. And there's not really much more as far as the language is concerned to learn. You'll have to learn some specifics about some things that you want to do. But at this point, after this lesson, you have all the basic tools you need. So basically, you have all the Legos you need to build pretty much anything you want. Okay, so here we go with classes. So a class is the definition of something. You've seen this already. But we're going to talk about it in object-oriented terms. If you're going for a job and they ask you about object-oriented principles, this is going to tell you some of the answers. Okay, so a class has properties and methods. Okay, and we've seen that already. Properties are the member variables, and methods are functions that you can call. They either return something or they don't. And so that's how a class works. They have logic inside, so they encapsulate the information. So you don't see the implementation. You just say, I want this thing to do something. And you don't really know how it does it. It just does it. You might know how it does it, but it's not important to your program. Your program just knows, calls that method signature, and then it'll do what you expect it to do. If they do an update to the program, you don't expect your program to break. And that's how classes work. So let's use an example. Lion King's a good one. So we've got Simba, and he's an instance of a lion, right? We talked about lion and mammals before. And Simba has properties. He's got a name. His name's Simba. His age, he's 1, and his size, he's small. He's not full grown yet. And then there's Mufasa, who's also an instance of lion. And his properties are, his name is Mufasa, his age is 12, and his size is big. Okay, so the methods for all lions are the same, right? The class lion is all the same for everyone, but the instances are different. So for all lions, they can run, they can sleep, and they can roar. And so as instances, we can instantiate them this way. So we're going to go ahead and do Simba, and that's his name, there's his age, and there's his size, and then Mufasa, 12 and big, right? Okay, so now we can make Mufasa roar by calling his roar function, and we can make Simba run by calling the run function. Okay, and so with inheritance, we have that going on. We don't have the breathe method inside of the lion class, because it's actually inside of the animal class or mammal class. It depends on how deep our hierarchy is. You only want to abstract what you can. So you know how the animal kingdom phylum thing works, probably in general at least. It's a pretty deep hierarchy. In your program, you don't want to go and implement all of that. You only need to implement what you need. So if you have a class that you implement and you see an abstraction, and that's another object-oriented principle, you're just going to make a base class and pull some stuff up in common. So that way you have, say, 2 instances of something. So let's say we've got a lion and we've got a cheetah, right? So cheetah is a different class and lion's a different class, but they both inherit from mammal would be, say, our next one up, or land animal or something. We only want to implement one level up unless we have a need to go higher. So we're only going to go as high as we need to go. And then anything that's in common, which sounds like a lot. I don't know if cheetahs can roar. Lions typically roar, but cheetahs can definitely run, and they can definitely breathe. So we can pull those up into the whatever we call it. Let's call it animal class, or we could even call them cats at this point. And we can pull that up there. And then the roar is what a lion has, and cheetah might not have anything special because they can run, but then in another object-oriented principle we'll talk about, they can run really fast, which is different than how a lion runs. Okay, so here are some of those terms that we're going to talk about now. All right, so there are 4 main terms in object-oriented. Now remember this, because if anyone's asking you a question in an interview, they're going to ask you, if it's about object-oriented, they're going to ask you what are the 4 tenets or the 4 attributes of object-oriented programming. And so polymorphism is one of them, and that's what we were just talking about with the cheetah versus the lion. Both of those animals can run. The implementation is different for a cheetah. A cheetah can run really fast, and a lion doesn't run as fast. So that's called polymorphism. We've got an animal, and in this case we're talking about a land animal. So we say, okay, I've got this land animal, happens to be a cheetah. I'm going to call the run method on that land animal, and it's going to go really fast. I'm going to call that same function on a lion. It's not going to run as fast. So that's polymorphism. The same function acts differently depending on the class. Okay, so, and a tortoise, of course, is going to go really slow. I don't even know if you could call tortoise a run, but maybe we can. All right, now abstraction is the art, I'm going to say, of looking at the commonality between classes and figuring out what can be pulled up or abstracted into a parent class that each of these can extend or implement as far as composition is concerned. So that way you reduce duplication, because if you have duplication and you have a breathe method in your line and you have a breathe method in your cheetah or tortoise, and they should be the same function, and you need to change it because, wait, I learned something new about breathing that I have to implement, you're going to have to implement it in two places, where if you pulled it up into a superclass or the parent class, you'd only have to change it in one place, because not just tortoise and lion are going to implement animal. It's going to be elephant, it's going to be giraffe, it's going to be all those, and you don't want to change all of them. So you want to abstract things up to a common base class as much as you can to reduce duplication. So as soon as you have two things, you want to start looking at reducing duplication. And that's how that works. So encapsulation we talked about before, that's where you're hiding the implementation or the data, so you can go ahead and make changes without breaking the world that's using your class, your library, whatever you end up making. And then inheritance we've talked about, of course, before. It's where something can extend whatever this other class is, so it's adding new functionality to it, and that's inherited. So the four basic principles are polymorphism. It's allowing the implementation to be different for the same function among different subclasses of a class, right? So land animal can just be called its run method, and then depending on what it actually is, a cheetah or a lion or an elephant or a tortoise, it'll just run the way that it's programmed to run, which is polymorphism. Abstraction is being able to actually pull up those common things into another class, so that way you can maintain it a lot easier and do the implementation in one place where it is then used throughout the hierarchy. And then encapsulation is where you're hiding things. This is just a summary overview of what we just went over. And then inheritance is where you can extend a class and add functionality to it. Okay, that's the end of the learning part. Well, actually, it's never the end of the learning part. You'll always be learning. But it's the end of teaching you Java principles in programming. Now, remember, these principles transfer to other languages. So learning them here is definitely beneficial to you, because you'll use them in any other language. If you learn C#, very similar language, all the principles are the same. In fact, the code is very much the same. The syntax is almost identical, some minor differences, some library differences, but other than that, they're pretty much the same. We're going to do a few exercise lessons after this, build some programs with everything you've learned. At this point, you know enough about Java to build pretty much anything you want. Anything else you need to learn, you just consult whatever documentation of the library you want to use is, or even Java's has a lot more built-in classes than we've covered here. But you have all the basic tools now to make whatever it is that you want to in Java. And we're going to make a few of those programs in the next few lessons. All right, thanks for watching. Hi, everybody. So this isn't really a lesson. Well, it is, but it's not. It's an exercise. And we're going to build a calculator that you can run on the console. So a simple calculator, but it works like a calculator, right? You type in numbers and you do arithmetic operations and you get answers. And so that's what we're going to make. And we're going to make it so it runs in the terminal window. We're going to use Java and the tools we've already learned. There's one thing I'm going to show you on here that we didn't learn in lessons, because programming is a lot, you know, the 80-20 rule. 80% of the stuff is what we learned here in these lessons. And the other 20 is stuff you have to learn with each project. Each project is different, so there's always something to learn. I've been doing this for a pretty long time, and it still follows that rule. 80% of the stuff that I do is stuff that I do all the time, and that's what I taught here. And then the other 20% is something I have to learn, and that's just how it goes. And that's a good thing, because we're always learning. So anyway, in this exercise, we're going to make the calculator. We're going to do addition, subtraction, multiplication, division, and you could add whatever else you want. I actually think about adding that memory feature, so you can do more complex calculations. You do a calculation, you put it in memory, do another calculation, and then add them together or something like that. So anyway, what we didn't learn in the lessons, because part of the 80-20 rule, one of the 20% things for this exercise is we need to get console input from the user, right? So they have to be able to enter a 4, then enter a plus, then enter a 5, and then we spit out the 9. Like I said, I've been doing this for a long time. I had to look it up on Google. I don't keep these things in my memory. I don't know how to do this, so I had to actually Google it. The first thing I Googled was Java console input. It got me decent results, but they were all for entering one time, right? So I had to modify that lookup to say Java console input, and then I said in a loop, because we want to keep asking the user, what's your next operation, what's your next operation, what's your next number, what's your next number, and so that's in a loop. So then I modified it to in a loop, and then I ended up getting an answer. Now, what it led me to wasn't the exact code I wanted, and it often doesn't. But what it did tell me is that the scanner class is what I want to use to get the input. Now, the scanner class is part of Java 11. I think it actually goes way back. It might even be in Java 5. I don't remember. It might even go all the way back to Java 1. I don't remember. But anyway, so you can look at the official documentation. Here's the link here in the instructions. Or you could just search Java 11 scanner, and you'll run right into the documentation. It'll be the first hit. Now, how it works is there's a scanner object, and you do system in. You remember how we had system out before to push stuff out? We have system in to read stuff in. So we need to do a new scanner on system in, and then we'll have that here. Now this try right here is a line that is officially called try with resources. Now the try is here, and the resource is the scanner. And what that does is once the code exits this block, Java will automatically close whatever resources it needs to. In this case, system in will be closed, or whatever handles have to open, and it'll close everything for us instead of us having to try and do that manually. Sometimes you don't get it right. This will automatically do it for us, which is kind of neat. All right, so then here's our while loop. So we're going to read the scanner. We're going to while true, and remember I told you while true is dangerous, right? But this is console input, so it's not going to be a loop that's going to spin, because this scanner next line is going to wait for the user to enter a 5 and then hit enter. Hit a plus sign and then hit enter. So it's not going to sit there in a loop. It's just going to sit there and wait. And so it's not that dangerous as it would be as if we were in a real loop that's just counting something, because then the CPU will just spin like crazy. And in this case, we made it say Q is if someone types the letter Q, uppercase Q, and hits enter, it'll go ahead and break out a loop and end the program. All right, so that's what you need to know that's new. Everything else you need to know is what we've learned here. So go ahead and pause your video and start making your calculator, and then we'll come back and I'll do it on the video too and see if we get a similar solution. All right, go ahead and pause your video. Okay, so we're back, and I'm going to pop open the code editor, and this is something I was playing with. Oh wait, no it's not. What is this? Oh, this is our exercise for doing the authentication exercise. All right, so what we're going to do then is I'm going to make a new class, and I'm going to call it calculator. I have to spell it right. Calculator. Wow, I had trouble spelling that. Okay. So I'm going to start there. I'm just going to do default package is fine. And then I don't need that anymore. And then it's going to be public class calculator. I'm going to have to try and spell that again, aren't I? Okay, I think I got it right. All right, so now I've got my calculator. So now I need a console application. So I want to public static void static void main. And so I'm just doing this from scratch. And that's what you did. So let's see how this one comes out. All right, so the first thing I need to do is get that code. So I'm going to go get that code because I don't remember it. I should try and actually remember it, though. I'll never use it again, though. So do I really need to remember it? I don't know. I'm just going to copy. I'm going to type it just like you had to. Or not that you had to, but you should have. All right, so it's going to be So the purpose is to get system in. So I'll be able to remember that. I'm going to use a scanner, so I'll be able to remember that. I'll use the IDE to set this variable, and then I'll put it in a try block. And then I know to while true. So I think I can remember this now. Not that you have to memorize everything, but it's kind of good practice because then it gets you thinking, what do I need to do here? So I already forgot. New scanner. And it's not a Nashorn scanner. I think it's this one. And then it's system.in. I'm going to set it to a variable. A scanner's fine. And then I'm going to put it in a try catch, or a try with resources block. All right, so that'll close when it exits. All right, and then I need to while true. And then I want to exit. So what was this? Scanner dot, and you can just go through the menu. The dot will help you discover, or you can go to the documentation, which is, let's just go there just for fun. Here's the documentation on the scanner. Not for really for fun. It's not really that much fun. It's documentation. So, and it's a lot of information. But it kind of tells you how to use it. And their examples are using numbers here. But it does give you some code. Do they have one with strings? I don't know if they do or not. I don't see one. Not yet, anyway. Nope, but they're telling you a lot about it. And then one of the neat things about this is if you're trying to discover how to use one of these things, look at this documentation. It's very detailed. Here's all the constructors that the scanner takes, and here's all the methods that the scanner has, which is a lot. And the one we're going to use is, see, it's got all these has next and stuff. This is a class that does a lot of stuff, but we're going to do something with reading a line. Next line, we're going to do this one. Advances the scanner past the current line and returns the input that was skipped. I don't know what that means, but all I know is when I call next line, if I hit the enter key, I'm going to get that string back, and we'll test that out. So anyway, that's documentation. It's called JavaDoc, and it's from Oracle. And just search in Java 11 docs, JDK 11 or something like that, and you'll run into that. Okay, so we're going to do next line, and let's assign that to a variable. So command dot for me, and I'm just going to call it line. And we don't have to type that much. And then I want to print it out. This isn't part of the calculator, but I want to see what I'm doing because we're learning. I don't know how to implement this calculator yet, so I'm trying to figure it out. So I want to see what the line is. And then I know that Control-C will stop the program, so I'm not really worried about this while loop. It's not doing a freewheeling counter. It is actually going to wait for me, so I will have time to have it not lock up my computer because it won't. So let's go ahead and run this. And I believe it's waiting for me. So if I hit 1, it's going to spit out 1. If I hit 3, if I hit G. Okay, so it's echoing what I'm typing in, so it's working. It's exactly what we wanted. So that's our input, so we're good to go there. Let's go ahead and do the Q thing that was there. So we did it if the letter equals Q. And I don't know if I'm going to keep this code either. This is just what was over there because I'm trying it out. So if it's equal to line. So if the line is equal to Q, I want a system exit with a 0, which means there's no error. So that'll exit the program. I could also just break, and that will get it out of this while loop. And that'll end the program itself too. But let's leave it at system exit just to show you how to exit. I don't know if this code's going to stay. I'm just trying to figure things out. All right, so I'm going to run this. And then I'm going to do G echo 3, and then uppercase Q. Echoed and did not quit. That's weird, right? We're still in there. All right, why didn't it exit? Uppercase Q. If Q equals line, then exit. Okay, it's not working the way I expected it to. All right, so just Control-C to get out of it. Let's debug then, because I really kind of thought that that would do something. And this could happen to you too. All right, so I'm going to hit, I'm just going to do Q. Okay, it's here. Line is Q, and Q is of course Q. So if I step system exit 0, okay, it closed it, which is what we wanted. That's weird. Okay, so I'm going to try run without debugging. Maybe it didn't recompile for some reason. Okay, let's do 1 and Q. Okay, it exited. It must not have compiled the first time we tried it. Okay, that could happen, so watch out for that. All right, so we need a calculator. So the first thing we're going to do is capture what's input. So I want a number. So I'm just going to run this again because I want to see what I want to do. All right, so I want to see a number, and I don't want to echo it out. I want to see an operation, and then I want to see another number, and that should spit out 4. So what do I need to do here? I'm getting this line in. So I need to know if it's a number or an operation, I think. A number should always be first. So let's do this. Let's see, how can we test if something's a number? It's a string that we're getting. So if we don't know, we can do this. We open up a browser tab and we say Java is string a number. And I like Stack Overflow. So let's try this. This was a popular question, and this was a popular answer. String utils. I don't want to do any library import, so I'm going to skip that one. Generally, it's done with a simple user thing. Is numeric. Okay, so we can make a function in this case. That one's pretty good. They're using double, parse double. And I'm not telling you to use exactly copy and paste. You should probably never do that. But just get the idea of what they're doing. Here they're using a double class, the static method, to find out if it's a string. If it is going to be a number, it's all good. If it's not, it's going to go into this try catch block, which means this is an error here. So let's use that concept. So double parse double. Let's see what we get there. So, and that's for line. So we're going to do double parse double, and we're going to parse line, and that'll tell us if it's a number or not. All right, so then they put theirs around a try catch. So a try block is try this, and if there's an error, you catch it. And we didn't go over this before, so this is more learning. And let's just catch any exception. Okay, and that'll tell us. So let's make it a function, because I don't want to have all this code in here. So let's do this. I'm just going to do control dot here, and it'll extract method, and then I'll have to turn it into some kind of function. Let's do is numeric. Okay, and I want it to return, well, actually, yeah, I do want it to return something. So I want it to return a Boolean. So if I do this, the IDE should complain, but it's not yet. But you'll notice here that the static method is not returning a Boolean yet. We want it to return a Boolean. Does that tell us, is it numeric? Yes or no? And if this is okay, it'll get to this next line. So we'll return true. If this is not okay, it's going to fall in here, which means return false. So that'll tell us if it's a number or not. So then we'll come in here. So let's go ahead and system out print line that. And I don't know where this solution is going. We'll find out, I guess. It's numeric. All right, so let's see what we have now. Let's run this. All right, so here we go. Q is not numeric. 2 is numeric, and it's not telling us anything. All right, time to debug. Okay, the uppercase Q is still working. All right, so then let's see what it's actually doing, because it should be telling us it's a number. All right, so let's do the number 1. All right, so here we are in this line, and if we step in, which is this one here, we get to parse that. We come over, and it returns true, and it's telling us it's numeric. Okay, it printed it out. Well, that's weird. It must not be compiling like I expected to. Okay, now it's waiting. And that's Q. And that's not a new number, so that'll run. Okay, weird. Something's kind of goofy here, but we'll figure that out. It's still working. We're just trying to figure stuff out. Okay, so its numeric is there. So now we've got a number, and we're going to do an operation. So if it's not a number, if it's a number, we want the number. So say it's 5. So we want number equals line. Oh, and we want it to actually give us the number value. And that's line. Okay, so if it was able to say it's numeric, we're going to get this number. What are we going to store this? Why would I store this number here? How's that going to help me right now? I'll have the number, and then I'll need an operation to go with it. So next time in the loop, this number won't be here. So I need to store it somewhere outside the loop. So let's put it up here. Let's call it double. And we've got a number. And I don't know if that's going to stay that way. Let's set it to 0, because that's usually how calculators start. Now this is the number that the user's inputting, so still don't know where this is going. All right, so we've got the number. We're going to store it up there, and then we're good. If it's not numeric, I want it to be one of those other things, plus, minus, or whatever. So one of the things I can do is, let's just do a switch statement. That work? We learned that before, right? So switch line, and we'll do case plus. And I don't know what we're going to do with that yet, so let's just do our cases. Actually, let's just do plus for now. Let's figure plus out before we go and put a bunch of code in there that might not even be good for us. All right, so we've got number. That's going to be first, and then we come in here, and we see if we've got a plus sign or something like that. So let's see, what would we do if it's a plus sign? We've got a number. Okay, so I'm just going to type out words here, and these could be variables. So the answer is going to be equal to the plus equals assignment operator. Remember that? So whatever our answer is going to be plus this number. So we don't have an answer. Let's put it up here. Let's put it above it just because I think it should go there, because that's the one that'll stick around longer. Okay, so now we've got an answer and we've got a number. Let's print this out. Okay, don't know what that's going to do. Let's not echo anymore. We don't need that. I have no idea what this is going to do. Let's find out. I'm going to debug it just because I want to see what it does. Okay, so let's do the first thing we need is a number. So let's say we want the number 3, and that's going to say number, so it's going to assign number to 3. That's good. Okay, now it's reading again, and we don't want to do plus. And it goes here, and it goes there. And answer is now equal to 3, because it was 0 before. So we did 3 plus. Okay, that's weird. I don't know if that's exactly what we want. Let's see. So we got an answer, but that's not really what we wanted. All right, we'll just run through and let's queue. Okay, so we got 3 and we did a plus. So we actually wanted to keep that number from before. So how do we do this? This is going to be longer than I thought it was going to be. Okay, so we've got a number and we've got an operation. So this is the operation and this is a number. We're adding 0. We did the plus, so it's kind of backwards. We almost wanted the number already. So we have a number, an operation, and then another number. So I know. We don't want to do the plus thing until we have the second number. So let's do this. this answer here won't happen until here. How'd that else statement get messed up like that? Okay. So we've got a number, right? Right now the answer is set to 0. It's going to come through here. We're going to get a number, and that's 3. We're going to assign the 3 up here. I don't want to calculate until I have another number, because I want a number plus a number to be where the answer comes in. So I don't know if this is going to work either, but instead of storing the number, I actually want to store the operation they picked here. And so I don't know if I need this case statement here. I think I need it somewhere else. So operation equals line, because that's going to be the operation we're keeping. So then let's store operation up here, and it's a string. And let's keep it, let's set it to null. Null means nothing. It's not set. All right, so it won't be set until it comes through here. And so operation is going to be set to something. When another number comes in, if there's an operation, then I want it to do the answer. So here's what I want. I want to do if operation is not equal to null, which means it is set. And then I want the answer to calculate. Does that make sense? Kind of weird. It's kind of loopy. But what happens is we want a number to be set, and then we want an operation to be set, and then when the next number comes in, we're going to do the calculation. I don't know if this is exactly right, because it still doesn't feel right to me. But let's try it. All right, so I'm going to debug. And let's do a 3. And we think we know what that's going to do, but let's step. It's going to get the number, and then it comes out. Okay, and then we're waiting for us to do something. Let's do 3 plus. And this one's going to say, there's the operation. Okay, and then it's going to wait. And let's do 3 plus 2. All right, now we're in. We've got a number, and the number is 2. We've got an answer which is set to 0, so that's not good, because it should have used the 3. And then we've got the number over here, so our answer is going to be fall a little short. We spit out just 2 because we didn't add the 3, so something's not quite right. Okay, I'm going to Q, or I can Control C. Okay, so if number comes in and operation is not set, let's go ahead and store the number as answer equals number. Wait, that doesn't make sense, does it? I mean, it does make sense, but it doesn't, because now we're storing number and answer. Does that matter? What my gut's telling me is that we don't need number up above, we need it down below. Let's just do this and see what it does. So then answer will be something. All right, let's try it. And string QG cannot be resolved. What does that mean? At line 11. I don't see it. How did that? So there's an error. String, why does it have this Q in the middle of it? Oh, yeah, there it is, right there. Okay. I accidentally typed a Q in there. Okay, so here we go. We're going to debug again. All right, so we've got 3. And what's that going to do? Step, step, step. Okay, now answer is going to be equal to 3. So step, it's waiting. Let's see, let's do a plus. And that's going to go to the operation. And now it's waiting. Let's do a 2. And now we've got a number here, which that's the 2. I don't know if it's important anymore. And then the answer is going to be 3 plus equals 2, and that should be 5. Hey, we got it. That worked. Okay, that's pretty good. All right, so let's do another operation. So we're going to take the 5 that came out, and we're going to minus 1. Oh wait, you have to minus first. Oh, we didn't do minus yet. It won't do anything. So I'm just going to Q. Because we only support plus right now. All right, so you notice that number got used here, but then it didn't actually, it's used only in these brackets in this context, so there's really no point to having the number up here because it's not used anywhere else. It's being used just here. So let's just define it there, and if we need it later on, we'll pull it up. But it looks like it's just going to be used in this context down here. Okay, so that's good. Let's support minus, because that's what we were trying to do next. So if it's the minus sign, okay, so that's that. Now, this looks pretty much the same as that one. That would actually do it. Okay. Because it'll say that it's, okay, it's not a, if it's a plus, it's going to come instead of operational line. If it's a minus, it's going to come in here instead of an operational line. We didn't need the duplicate code, so I just took that out. And let's see if we support minus now. Okay, we're going to do run. Let's just run it without debugging. All right, so we're going to do 2 plus 4, oops, plus 4 equals 6 minus 5, oops, minus 5 equals 11. It did plus. Why did it do that? Oh, because this right here. Okay, hold on a second. So then we need a switch here on operation. Do you see why? Because here we're only adding, no matter what the operation coming in, this is what we're doing. So we actually need to know, are we adding? Then do this one. And then are we subtracting? Minus equals number. And break. All right, does that make sense? I think so. All right, so now let's see what we get. One plus, oh, we're debugging. Plus, it's still debugging. 2, and what's it equal? 3. Okay, so that works. I'm going to stop this because I want it to, yeah, Control C. I want it to just run. Okay, so let's do 2. Oh, it's remembering whatever it was doing before. And sometimes this thing gets kind of silly. So I just close all those and let's just run it again. Because it's like maybe Control C didn't exit the program or something like that. So 1 plus 2 equals 3. Minus 1 equals 2. Okay, so we're supporting minus. So we're almost done here. So let's support a couple other things. So we're going to support times. And if we get a times, you kind of see where this is going now, don't you? Times, and then we're going to do times operation here. And that should work. Let's do, I'm pretty sure this is going to be the same thing, so let's do division. Okay, and then we want to support the division here. Divide. Okay, so only these characters will come through. All right, let's try that. Okay, let's run it. And let's do 1. That was weird. Plus 2 equals 3. Minus 1 equals 2 times 3. Oop. Times 3 equals -1. Okay, that's strange. That should have, I think that should have worked. But now we have to figure out why it didn't work. All right, so let's quit the program. All right, I'm going to close this terminal too, just because, and I'm going to do a debug. And I want to see what happens on this operation. So I'm going to set it to line 15. All right, so here we go. 1 plus 2. And that's a plus operation, so I'm going to let that one go through because we know that that one works. All right, let's do times 2. That should be 6, right? And it's got the operation. It's got that. Answer is now 6. That's going to actually work. So I think our terminal was had a weird state in it. All right, let's divide this by, let's divide it by 2. And we should get, I don't know what we're going to get. I think we should get 3. Oh, here, look, this division thing is wrong. It's got multiplication in it. So we got to change that. Okay, and I wonder if that system exit's actually the thing causing the problem. All right, so let's do this as a divide operation. I think our calculator's done here. Okay, so let's do this. We'll just run it this time. All right, so 1 plus 2 equals 3 times 4 equals 12. Divide by 4 equals 3. Okay, so that's actually working. We did all the operations. Oh, did we do a minus? Let's do minus 2 equals 1. Okay, so that's working. How about a clear? Because calculators have a clear, so you can keep going without having to keep doing this. So we want, if it's a C, like we have a Q down here, let's do this. Else if C equals line, let's do answer equals 0, because that'll set it back to 0. Okay, let's see if that works. Let's close this. Oh, maybe closing that's not the best idea either. Maybe I should have hit Q. Okay, so let's run. Okay, so we got 1 plus 3 equals 4 times 3 equals 12 minus 2 equals 10 divided by 5 equals 2. That's working. All right, let's clear. So I did C, and let's probably print out that we're back at 0. Let's do 1 plus 2. Okay, so it got kind of goofy there for a second. So let's stop the program with the Q. All right, so one thing we want to do is print out that we're back at 0. So let's do system.out.println, and we'll print out answer because that should now be 0. All right, and then maybe we want to clear the operator. All right, let's try that. Okay, ready? And close the terminal. All right, here we go. Okay, 1 plus 2 equals 3 times 4 equals 12. Clear. All right, 0. Okay, so then we've got 1 plus 3 equals 4. That's it. Our calculator's working. Let's clear again. Back at 0. 8 plus 3 equals 11. Okay, that's our calculator implementation, and it works. Add whatever other functionality you want, and that's it. Thanks for watching. Hi, everybody. Okay, welcome to exercise 8. This is where we're going to build a full stack application, our web server address book. We're going to use all the skills that we learned up to now, And we're going to throw in one more thing. I'm going to teach you a little bit about Spring Boot, which is an application server for Java, so it helps you build backends, and it also will serve up your website too, if that's how you want to configure it, and that's what we're going to make it do today. So this set of videos, so it's going to be a set of videos, not a single video, because I think this is a little bit bigger and I want to break it up. It's easier for me to record, probably easier for you to watch as well. And I'm just going to do it straight through. I did a little bit of it practice-wise, but otherwise I haven't done much of it. So you're going to watch the process. Sometimes I don't remember what it is that I need to do as far as programming goes, so you'll get to see me do a Google search for stuff and find the answers on MDN, Mozilla's developer network, usually sometimes Stack Overflow. So I'll be looking for stuff just like you would. I know a little bit more because I've been doing it for a while, so I know what to search for, and that's really the key. I don't usually remember how to do an API fetch from JavaScript in a web page, so you're going to see me fumble through some of these things, and that's a good thing because it'll be learning experience for both of us. Okay, so we're doing exercise 8, and we're going to do full stack. So we're going to learn how to set up a web server. We're going to learn how to build an index page and a single page app in pure vanilla JavaScript, and we're going to use Bootstrap to make it look pretty, run on a phone. And then we're going to do some URL fetch API calls to our backend, which is, this is a Java course, so we're going to be focused on the backend, and the backend is going to be a RESTful API written in Java, leveraging Spring Boot. So I'll show you how to do all of that, and let's go ahead and get started. Now, exercise 8. If I go ahead and click on exercise 8, this thing's so new. I actually don't have any instructions here right now. So what we're going to do is do the video. I'll put the instructions in after. All right, so the first thing is we're going to download the web server. Actually, we're not going to download it. We're going to download a ready-made web server, Spring Boot, for us. And so what we're going to do is open up a browser tab, and we're going to type in Spring Initializer. And you just type in Spring Init or something like that. But Spring Initializer, it's spelled without the E here. And just go ahead and hit enter on that. And here it is. So it's start.spring.io if you just want to type in the address. So I'm going to go here. Now, this is a kind of a code generator from Spring Boot, or Spring. I don't know which one it is. Spring Boot's the fancier version of Spring, or the one that's actually a little bit easier to program. And it's got a couple of things that make this development really easy. All right, so first thing we're going to do is take a Maven project, just because I think it's easier. Some people might like Gradle. Gradle's more programmy. Maven is more, it works. And then language, of course, is Java. These are some Java variants. And then we just take the default values here. And I'm going to just take the defaults for everything. We're just going to keep this simple. We're not really focused on Spring Boot right now, but you would enter group, and this is same thing as your package. So remember how we covered Java packages. So this would be the package that you want to use for your project. And in this case, it's com example. Typically, it's your reverse domain name. So I have a domain called nobody else's as well as Full Stack Cloud Developer. So I would be com.fullstackclouddeveloper dot something, or just that, and then the artifacts will determine everything else. An artifact is actually application name. This is human readable name. Here's a description. I don't even know where that shows up. And then here's the actual package that's going to be this application. So basically, this is our main group, and this is our package that we're going to do. So again, reverse domain name, and then whatever this project is usually what you use, one word, and then everything builds from there. Packaging, we're going to use a jar file. And then dependencies. We just want a simple dependency. We're going to build a web app, so we're just going to do web. And there's a whole bunch of other stuff in here. Don't even look at it right now unless you are somewhat familiar with Spring, and then you can go and add other stuff. I don't even know what's in there. So here's, let's do web, and that's all we need. So then we hit generate, and this is really cool. What it does is it downloads a demo zip file for us, and if we extract that, and Windows, I think you double click, it went ahead and unzipped it, and the really cool thing is it did a whole folder for us. So MVMW, this is Maven, that's what we chose, and this makes it easy to build the project. We're going to learn that too. A POM XML, that's the configuration file for Maven. It shows our dependencies, and we'll look at that too. And then it made our source folder structure for us with a test directory and a main directory. So remember how we were making programs in Visual Studio Code where we made a Java file and a class file? This is already organizing it for us into packages, and you'll see this here when we open this. So here's a demo application thing that will open with Visual Studio Code. This has the IntelliJ, so IntelliJ Ideas IDE, which is a full-featured Java IDE, probably the best one out there. And if we get stuck on Visual Studio Code, which I don't anticipate we will, we can go to IntelliJ. Otherwise, you can go ahead and be adventurous and explore with IntelliJ. In the advanced course or the intermediate courses, we will be using IntelliJ just because it's a little bit easier, and it's a good thing to learn because that's what you'd be using on the job in most cases if you're doing Java development. All right, so nicely this thing made a structure for us. So let's go ahead and open that project. So I'm going to go ahead and open my terminal window here. And I don't want to install an update right now. All right, so I'm going to go to my downloads folder because that's where it is. And it's in demo, right? Because that was the default. And I just took the default. You can add more stuff and play with it. Remember, explore. You can't break anything. Put stuff in, download the zip, see what it looks like, see what's different about it, and then do some learning with it. And we'll do more projects as we go. Spring Boot is going to be the thing that we're mostly in now for the Java backend stuff and for some of our front end stuff. Okay, so demo, this is the application. So here is what it looks like now. It went ahead and made all this stuff for us, and that's a tree command that I installed here. And there's the application Java, so that's the first Java file, and here's a unit test class Java file. We'll probably look at that a little bit. Let's save it more for the intermediate or advanced courses because it's a different subject. We're just trying to get ourselves oriented to start building applications, and then we'll get more advanced as we go. All right, so application, let's go ahead and do our code, and we'll just open dot, which is the current folder. All right, and then something about trusting, yes I do. Something about Docker, I don't really want to do that right now. And then it's loading up the Java install pack, which we set up in the setting up environment thing. Now we want to make sure that this is in standard mode. So if we click on it, we got the little hand. If we have the rocket, then we're in light mode. But since we have the thumbs up, we're in standard mode, and that's where we want to be because that actually helps us more than anything. All right, so let's get rid of this welcome. We don't need that. And I have no idea what this is doing, so I'll just let it do what it's doing. Oh, it wants to do some update, sure. Probably going to restart it, right? Okay, well, let's just keep going, and if it does, it does. Okay, so let's go ahead and explore source, main, Java. All right, this is where our source files are going to go. We were doing stuff probably on our desktop, probably in our downloads folder, wherever we were doing it before as a single file. Now we've got a package. So com example demo, if we open this Java file, we'll see package, just like we saw in the anatomy of a Java class lesson. Here's that package right here, and that's our reverse domain, and then whatever our project is, and this one's just called demo. Here's import statements, again, from anatomy of a Java class. These are actually pulling in class files that we didn't make from somebody else, and that's how they get in here. So here's the package right here, and here is the Java class file. I think we can even jump into it to see the source code. I wonder if this can do that. And in IntelliJ it can, and I believe this can too. Go to definition. Let's see what this does. Hey, look at that. So it decompiled the source code. So this is the application that we didn't write. Somebody else provided a jar file library, and I'll show you how to get those in here. And so this is their source code. It's a decompiled thing. All right, so here's, do you remember the main static method? This is the entry point, just like we did when we made our calculator or our hello world programs. This is main, and then it's actually running this application up here, which is really just starting off a web server, and it's going to start with our class, which is demo application. And then I'll show you what to do from here, but this is just that right here. So we could actually run and debug just like we did before. So let's go ahead and we'll just run. And then we'll see similar stuff happen to hello world, except a lot more techie stuff is going to happen. So Spring Boot loaded up, and it's on port 8080. So if we go to our browser now and go to port 8080 on here, so I'm just going to open a new tab, and I'm going to do localhost 8080, and I get an error. We don't have an index page. We don't have index.html page. And if you haven't done front end before, index.html is typically the entry point to a website or a web site's folders. And we don't have one of those yet. We just downloaded the server. So nice thing is, by getting this error, we know that our server's up. And now we need to do something to add to it. So let's go ahead and add to it really quick. And what we're going to do is in the resources, so Spring Boot actually set all this stuff up for us. And in the static folder, we've got nothing right now. So let's go ahead and make a new file. And let's call that index.html. All right, so what that's going to do is it's going to give Spring Boot an entry point for our web page. And this is where all the web page files will go, and you can put folders under here and everything else, images, whatever else you have, PDFs, attachments. And let's just make it say hello world. Oops, got to spell it right. Well, I don't have to, but it's better. All right, so that's what I'm going to save. And now when I run this application, it should show up. Now, if I just switched over here and hit refresh, it's not going to do anything because I have to actually restart the server so that it recognizes that folder or file is there. There's a way to configure it to have it do it automatically, but let's not get into that right now. Just restart. It's simple enough. So just like we did before, we'll Control-C or hit stop on this, and that shut it down, and we can go ahead and check that out by going refresh, all gone. And let's go ahead and go back to our application, and let's run that again. Okay, it's up on 8080 again. Here we go. We're going to refresh. And hello world. So right there, we've got the tiniest website in the world, just like we had the tiniest, well, it's not the tiniest website in the world. Spring Boot's actually kind of big, but it's a simple one-liner thing to get our web page up. And just like we did when we did hello world on the command line or in Java, now we've got it on a web page. All right, so let's go a little bit farther with this. So we want to make an address book. And address books have street address, name, phone number, and stuff like that. Now, here's another thing we're going to learn. So we're actually going to focus for maybe this lesson, maybe the next one. On the front end, we're going to mix in some back end as we need it, and then we're going to focus on the back end, because right now this is a Java course. We're going to focus on building back ends, and maybe the front end of this course will start filling in our front end course. So let's go ahead and open up a new browser tab. And we're going to go to Bootstrap. Now this is a, so Bootstrap something. I don't know what version they're on right now. Probably the first one that comes up is fine. I don't know what all this is. I think Bootstrap 5 is the new one. So let's hope if I click on that first thing that came up. Yep, current version is 5.1. All right, so this helps you build nice looking websites that are responsive. So if it's running on a desktop or a phone or a tablet, it looks good. It automatically shrinks itself and expands itself and all that other stuff. All right, so what we actually want from this is I want an address thingy, and I know that this thing has that. I'm not sure exactly where it is. I could do a search for it. Sure, let's do that. Does it have address? Reboot address. I wonder what that is. Misc elements, it said. Oh, okay, that's pretty snazzy. So that's for printing out. That's not what I want. I think what I want is in forms, or what we want. Now let's just go to forms. Oh, I guess you have to click on something. So let's just go to form control. All right, and let's see if we see something. So here's an example. There's another example. I know that there's a complex example in here that has an actual address, and that's why I brought us here. And it nicely has copy and paste HTML for us. And we'll get in more to the front end stuff in the front end course, but right now we're just trying to focus on the front end enough to get our back end going. Maybe it's an input group. That's looking a little bit better. I'm looking for something that looks addressy that I think I've seen before. Button add-ons. And this is a good thing to go through. See how nice it looks? Look at that, that's pretty snazzy, right? It's got all the copy and paste HTML right here, so that's really cool. All right, that's not it. How about layout? It's in one of these. I know I've seen it. Grid layout, gutters. This thing is really, oh, here it is, look at that. There's the address, email, password. We'll change that to something else, maybe phone number. Address. This looks like what we want. And then there's the copy and paste. Let's see if there's a better one underneath it. Otherwise, they're going to something else. All right, so this is the one we're going to take. All right, so I'm just going to copy right here, and we'll modify this and click to make sure. All right, so let's go over to our index.html page. Now, here's something that's up. This is in HTML right now. This is just text. So if I paste in the stuff that I just grabbed, it's HTML, that's great, and it'll probably run. Let's try it. Experiment, right? You can't break anything, just try it. So let's see what this does. I have no idea what this is going to do. I haven't tried this before. So if I refresh it here, it shouldn't do, oh, it did pull it in. Okay, so it looks like Spring Boot automatically is looking at index.html changes. Now that looks pretty ugly. I mean, it did bring in stuff, but it doesn't look as nice as it did on the Bootstrap page. So there's something missing. We just pasted the HTML into not even an HTML document because we just pasted in a form. Now there's other stuff that goes with HTML, and we're going to go find what that should be right now. Now we're pretending that we don't know anything about website programming yet. So we're exploring, we're learning, and I'm showing you where to go to learn some things. Let's go over to getting started. That'll probably help us. Introduction, sure. Tells us about it. Quick start. CSS, you guys will learn about that later in the front end course. That's what makes it lay out nice and look good. Here's a starter template. That looks like what we want. All right, so the starter template, what it does, and I'll explain this really quickly, is it sets up an HTML document for us. So our index.html page needs these things to tell it's HTML, what language, it's English. The header is where we put the title and other things that we're bringing in, like CSS files and stuff. And so here's the title. That's what shows up on the tab. And then here's the body where we put our HTML. Now we're going to go ahead and pull this stuff in. You can look down through more of this. It teaches you some things, but let's just go ahead and copy this right here. And I'm going to put it in above this because I already have the form that's going to be in our body, and I'll have to move it up there. But we want to get our page somewhat working. So this is a hello world. Everyone does that, huh? All right, so, and then here's some stuff. So here is the JavaScript thing. This one's separate Popper and Bootstrap.js. Why do I want that? It's commented out, so I don't want it. Let's get rid of it. And JavaScript, choose one of the two. Oh, we did that already. All right, so something with Popper. Let's go ahead and take that. All right, so let's leave that script there. Let's leave that hello world there too. That's fine. And let's take our form and let's put it in the body where it should be. So let's cut that. And inside the body here, we'll put it underneath our hello world thing. And the indentation's kind of off here, so we can fix that. I'm going to save that there. And then I think if I do a right click, format document, it went ahead and fixed all the indentation for us. I'm going to save that. Now you'll hopefully see our form look way better. So let's go ahead and go to our web page. And where's that? Over here. All right, let's see what it looks like now. Okay, that looks a little better. Well, actually, it's a lot better, but everything's smashed up to the sides. I don't like that. So one of the things you'll learn about Bootstrap is it helps lay things out, but you have to at least get the containers right. And so this is just the form. The form should be in something that actually allows it to lay out right. So let's go back to introduction, contents maybe. This is just telling us how everything's laid out. That's probably not what we want. Layout is probably what we want. Containers. And so you just explore this. You don't know much about it yet, and I don't really, I mean, I do front-end development, but I don't usually remember this stuff. Here's the default container. So we need a container, and we need our stuff, content here inside of our container. So if we actually, this is documentation for Bootstrap. If we inspected the page, we would see that those things, that address was actually in a container. So let's go ahead and just copy this. And this is what we want to put around our address. So let's go ahead and paste it here. Content goes in the middle of that thing, right? So let's make some space. Let's grab this form and stick it in the middle of that and see what it looks like after we're done. All right, so I just cut it with Command X or Control X on Windows. I paste it in here. Let's format this document again with a right click and format document. I have no idea if it did anything. It looks like it did. All right, so now we've got something inside of the container. Let's refresh the website and hope it looks better. All right, now it's squished it in, and that's good. Okay, look at Hello World still smashed over there. And we're going to, maybe we'll change it to address book or something. So let's put this inside of here. And now let's see how it looks. Hey, it moved it over. That's good. So let's just put address book because it's not hello world anymore. So let's just go ahead and make a change. And now we're getting a web page going. Address, that's my dog barking in the background. One of the dogs. All right, so address book. Okay, so we've got address book. Let's go ahead and see what that looks like. Refresh, and there we go. So it's looking good now. All right, so now we've got our address book. That is a front-end web page. So what we're going to do from here is fill in some more stuff. So we're going to learn a little bit of front-end development right now. And this is really just modifying stuff. So we already have a pretty good-looking address book. And one of the things you'll notice that's nice about Bootstrap, as it gets smaller, see how it's formatting and shrinking it. If I'm on a phone, now it looks like kind of like a phone. And if I stretch it back out again, it gets bigger and stretches. Now I'm on a tablet. Now I'm on a desktop. So that looks good, right? Okay. So email address, yeah, for an address book these days, we probably want that. Password, this isn't a user password thing. So let's go ahead and do some modifications here. And quick HTML lesson. Okay, HTML, start with a doc type HTML. That tells the browser what document it's loading. There are different versions of HTML. This tells it that it's the latest version of HTML, so the browser will respond to these tags appropriately. This is our tag that starts it off, HTML, and the English language is being used here. You could use other languages as well. Head is stuff that's defined for the header, various headers, things that the page needs, any imports of CSS, and of course the title. And some JavaScript goes here. Not really. We like it down at the bottom better. And so we're going through a little bit of anatomy of HTML here. And so head is a tag, and we'll look up these later in our front end lessons, what they all mean, but just use the template for now. And so that's how that works. You don't really have to look at it, but we do want to change a couple things. Well, let's change the title. That's what shows up in the tab to address book. Okay, and then we've got address book here, and that's good. So body, that's where our HTML content goes. Div, that's I'll call it a container object. It holds things. It's really for layout, and they use them for all kinds of things, but div is a very popular tag. And then H1 is a header. There's H1, H2, H3, H4, I think all the way to H6. The H1's big, like a title case. Then it gets subtitle and all the way down to 6, which it's much smaller. All right, form. Now forms are important because forms are the things that actually communicate with a backend through all of these inputs. So you've seen them before. A login page is a form typically. Any form that you filled out for an online application or anything else like that is an HTML form. And there's other attributes here. And this is a Bootstrap thingy that helps us with layout. And I don't think we'll get into that in this lesson, but we'll see. All right, another div, and this is a layout thing. So just to let you know, Bootstrap breaks things up into columns of 12. So a 6 here means it's going to take up half, which you'll see takes up half. And then 6 on the other side takes up half. And then 12 here takes up the whole 12. Okay, so that's how that kind of works. And then you could do 3, you can do 2, break things up. Okay, so these are divs. That's a label, so a label email. And here's the label email. And then input type is email address, so it's going to validate that it's email. And there's that. And so these are all pretty straightforward, yeah, but we'll learn more about it later on. All right, and then so we've got that. So let's go ahead and make a change here. Let's change password to phone. All right, and it's not a password type anymore. Let's put in a phone type. I don't know if it'll format as a phone, but maybe it will. And let's change the name or the ID of this one to input phone. And that means that this for label should be phone too. All right, so now if we go ahead and refresh our page, we've got phone, and we should be able to enter a phone number. I don't know if it'll format things. How about, I don't know, 222-555-1212. Okay, it doesn't format, so that's the number. It's free form. All right, So that's that. We've got states. Now this is a combo box here, and we could load up a bunch of states and have them be able to pick them. You've seen that before. But let's just go ahead and make that an input, just because this is a simple lesson and we don't want to get into that right now. So let's go ahead and replace that. So this is a select. We'll get into this in the HTML lessons, but inputs are things to type in. Selects are things to select from. Text area is things to type like paragraphs in. And there's a couple other things too. So let's just go ahead and replace that. We're going to cut it out and then paste in the input that we brought in. Type text, form control is fine. That helps us lay out and control things. Input, and this one's going to be, was it state? I think that's what it's called. I should remember the name. And we'll just get rid of the placeholder, and we'll learn about that later too. And why is that div way over there? Because it was a paste thing. So let's format it and see if that div goes somewhere else. Yep. Okay, so it nicely laid it out. So if it gets messy, because sometimes it does, just go ahead and lay it out format-wise. Okay, so that should give us a state. When we refresh and get rid of this select box, now we can type it. Okay, that makes it simple. Check me out, don't need it. And that is another type of input, which is of type checkbox. We don't need it, so let's just go ahead and cut that whole thing. So I'm going to cut it from the column definition div, okay? And right to the next div. So HTML tags typically have an open and close. Some of them don't, like inputs don't, but typically they have open and close. So this is an open, and that's a close. So slash, whatever the tag name is, and that's a tag, and this is called a tag, HTML tag. And usually we do the indentation with levels like this so we can see where everything is. You can jumble them up, put them all on one line, completely not readable, not maintainable. You want to make this easier on yourselves. Make the indentation so you can see where stuff begins and ends. All right, so don't need check me out, so get rid of that. Submit is the thing that you click on that actually does the save. We don't want it to say sign in. We want it to say save. All right, so now we'll go back in here. All right, so now we've got our form. And that is probably all we're going to do on this recording. What time are we at? We're already at 27 minutes. So I'm going to stop this recording, and we'll do a little bit more on the front end and then get into some back end stuff in the next lesson. All right, thanks for watching. That's a little bit of front end for you. See you in the lessons. Hi, everybody. Okay, so this is part 2 of the full stack exercise where we're making an address book. And we're going to do a little bit more front end to get this address book information to send to our server. And so let's go ahead and start doing that. We left off here where we had a completely done form, or at least a done enough form that we can save. So let's go ahead and make some adjustments here on this page. Now this is our HTML in there, so that's where our form is. Now we want to submit this to the server. So we've got a form here, and a form has a method, and that's it matches the HTTP verbs. So basically get will get information, post will create information, put will update information, delete will delete information. Then there's a couple of others, but those are the main 4 that we use. So we need to make some adjustments here, and then we also need to add some JavaScript for the way that we're actually going to do this. So the first thing we're going to do is let's see what this thing does if we hit that save button. What is it going to do? Let's put some information in here. It doesn't. Well, this is going to validate, so I have to put something that's valid. And then phone number is not going to validate, so it doesn't really matter. This isn't going to save anywhere right now. We're just trying to submit the form and see what happens to it. Okay, so I'm going to hit save. I don't need that. What's that? Okay. And hit save, and okay, so now it's trying to say site can't be reached. So it's trying to post something, and that's not really what we want. Okay, so let's go ahead and make the adjustment here on the form. All right, so what we're going to want it to do is go to somewhere in our application. So let's say we're going to have a method, and this is going to do create at first. It might do other things later, but we'll see. We might not even use this. But let's go ahead and make it post now. And then action is the URL it's actually going to go to. And it can be absolute or relative. If it's absolute, there might need to be some other things that need to be done, which is more advanced. So let's go ahead and say we're going to post this to addresses. And that is probably enough. So we'll make an addresses controller in Java and Spring Boot for our backend, and we'll see how that works in a later lesson, probably not this one. All right, so what happens now when we post this? All right, so let's refresh the page. So, oh, site can't be reached. That's what was wrong the first time. So let's see what it does now that we've modified it. So we need to go over here and actually start this application. That's what it was saying. Okay, so once this is started, then we'll see what it does. Okay, it's running on port 8080. Okay, let's go see. All right, so let's refresh this page. We've got our address book. Let's fill this stuff in again. That's remembering. That's nice. I don't have to keep typing. All right, now when I hit save, okay, now we're getting that error message where we don't have addresses, which is correct. Let's go back and change it to what it was, just so we see what it does, because this was actually what we were supposed to see before I didn't have the server running. All right, so let's refresh the page here, get rid of that right now. All right, and let's post it this way and see what it does by default when nothing's filled in. I really don't know what it's going to do. Maybe it'll do nothing. Let's see. Okay, it does nothing. Well, it did something. It cleared the form. It posted to itself, I guess. I have no idea what it did. If we want to know what it did, we can right-click, inspect, go to this network tab here. So this is an inspection editor. We'll get into this a little bit later on the front end side of things. But if we go ahead and do this again, we'll be able to see what it did. And there's lots of functions in this debugger, which we'll show you. In the full stack mini course, there is actually a lesson in there that goes over this. Okay, so what did it do? It posted to localhost, and that was it. So it just did this. And so you can go ahead and see what it did on the headers. It went ahead and didn't do anything. It just refreshed itself. It did a get on itself is what it did. And we could see that here if we go to a get. So it did a get request on itself with a question mark. So that's what the default form behavior is. And if we change it back to post, so method equals post, and we'll put the action back to addresses. Okay. And if we refresh the page and submit that again, let's see what it does. Let's open that debugger too, because we want to see what it's doing. And go to the network tab. Like I said, we'll go over this more in another lesson. All right, when we hit save on this one, now it's doing something completely different. It got a post request, I'll bet. Yep, there's our post. And did it post any variables? Request headers. So that's where we'd have stuff in it. But we don't have any form variables, and I'll show you why. Okay, so let's go back over here. All right, so for a form to post, and we'll go over this more in the front-end lessons, but you'll see these inputs here, right? So there's input, there's select, there's text area, and I think those are them. There might be another one. You'll see the ideas here, right? And the idea is used for the JavaScript side, so we can actually do things with it. But if we want it to send to the server, we need to give it a name. So I'm going to name it what we're going to put it on the server. So let's just call this one email. And now let's go ahead and see if we get a post variable. All right, so we'll do email. It doesn't remember. All right, now when I post, and let's go ahead and inspect this again. Network tab. I'm going to post. We get red, and it's 404, which means not found. But then if we go in here, we're going to see that it did send our name, or the email, which is what we wanted. So we have to put a name attribute on the input elements of the forms in order for it to actually send to the server. So let's go ahead and do that now for each one. And we're going to name them something that we're going to save on the server side, because something that makes sense. Like this input phone, that's not what we want on the server side. On the server side, we're going to actually save things differently. Input phone is probably okay for the front end, but it's really just too much wording. But that's what came by default from Bootstrap, so we'll keep it for now. We'll probably change it later. We'll see why. All right, so this one's going to be address. So let's call this one address 1 since we have an address 2. And there's address 2 there. So remember, it's name and address 2. All right, we're just going to do the rest of these. This one is city. This one is state. And then we'll have zip. And then we've got the button. That's fine. It's already working. And so now if we refresh the page again, I'm removing the addresses that we posted to. Okay, now it remembers again. It's kind of. I'm putting a value in each one. Caps. Okay, now when I save, we're on the network tab. Let's go ahead and clear this by clicking on this clear button. Now it's empty, and I save, and we get the 404, which is what we expected. It's a post request, and now we've got a bunch of values, one for all of our fields. So now it's actually sending to a server page that doesn't exist, addresses. And so that's what we do on the front end to get the post happening right now. There is another thing that we're going to do. We want to make a single page app because that's the way they do things nowadays. This is the old default behavior of things that was, I don't know how many years ago it was, where a form would post and it'd go to a new page. And that's what this is trying to do. What we actually want it to do is do what a single page application would do, which is also referred to as an SPA for short. It will just stay here and do something else. I think what we want to do with this page eventually is we're going to have where you can add here, and then we'll have a table down here of all your addresses, so that way you can see them all in one place, add a new address, and we'll see how this goes. I don't really know how the UI is going to come out yet, but right now we're starting here, and I want the save to actually go to the server and then stay here on this page with the intention of having a line here once we get into that lesson where the save actually happens, which is the next one. Okay, so let's go ahead and do that. Now, there's JavaScript tags like this here, and that's doing a source, so it's actually pulling in a JavaScript library from somewhere else. We can also do it where we have the script here for our page. And just to prove that it's working, let's say hello. And notice I use single quotes here. You can use double or single quotes. There is a difference between the two of them, not much unless you're looking at inputs that do substitution and stuff like that. So let's go ahead and leave that as is, and then let's refresh our page, and you'll see the alert comes up. So our JavaScript there is running. All right, so now there's a thing called URL fetch, and they refer to it as the fetch API. And what you do there is you use JavaScript to post to your form. So that way your page stays here, and it goes to the server, gets the data back, and stays on your server, and JavaScript goes ahead and refreshes it. That's getting into modern or contemporary JavaScript and web page building. We're not going to do it the old style. So let's go ahead and do this. I'm going to do a Google search for URL fetch API. And that should bring up the Mozilla Developers Network or something else that I might have searched for. If it doesn't, because my search results are going to be different than yours based on things that I've searched for, let's go ahead and do MDN. So that's the Mozilla Developers Network, and I like their documentation. And so here's the fetch API. And what we're going to do is, you can read through this document. Basically what it does is it makes communication with the server in JavaScript much easier. And so you'll see here that you fetch the URL, which would be similar to what we were doing. And this is a GET request by default. And then it gets back a response, and then we can do some things with it. All right, so we're going to look for some examples. So here's one that's actually posting. And I've been to this page several times, so I kind of know what I'm looking for. And I never bother remembering how to do it. I always come here if I need to. So here's the post. And this one will do a post or a put. And by how they have it paste here, it's a post. And then uploading a file, we're not really concerned with. Multiple files, not concerned with. Processing text line by line, not concerned with. I think that post one might be the best one as I'm scrolling through here. They're doing some other things and some responses. Okay, so that's the one we want. So let's go ahead and copy and paste that. So here it is here. We've got our data and we've got this. Okay, so let's go ahead and go back into here and we're going to paste our script right there. All right, so that's doing a fetch. Now, this isn't exactly what we want right now. It's just pasted here to be held until we actually make it do something, because right now this will not do what we want it to do. Okay, so if I actually run this, it's going to try and post this to some server because the script is just going to run, and that's not what we want either. So now what we want to do is we want to listen to this form submit when they actually click this button. So let's go ahead and go back here, and I like MDN. Let's keep that tab. So let's do MDN form submit listener. Okay, so now we're going to listen to the submit event. And so this is the documentation. That they have a lot of documentation on here, and they even have lessons to go through on here. So it's a great resource to go to. It's one of the ones that I go to the most for finding things. So here is how you add submit events. So this is the submit form, and then here's the JavaScript. So we're going to do form.add event listener down here, and that's going to give us the submit event and then the function that we want it to call. And they've got a function there. So let's go ahead and organize our code a little bit more. What we're going to do here is take this, and we're going to paste it in the top of our JavaScript. And of course, this is the back end course, but we're doing a little bit of front end here. So we won't get into too much detail here, but we are going to talk about what we're doing. So we're doing a document, which is this whole HTML document. We want the form, and we're going to get it by ID. So let's go see if our form actually has an ID, and it does not. So let's go ahead and add one. And it could be called anything. I'm just going to call it form for now. We might change it later, we'll see. And then so form is what they used. And then they had an add event listener on the submit, log submit. Let's just call ours add or save. That's what we called it, right? Because that's what our function is for the button. All right, so let's call our function save. And then what we're going to do is we're going to wrap this. And we'll get into JavaScript in the front end. Don't be too concerned. Just go ahead and follow along, and I'll explain what we're using here as we go. So in this case, we're going to add a function here. And we're going to add it as a variable. So const is a constant, and that's defining a variable that doesn't change. So we're going to say that this function doesn't change because it doesn't. Once we type it in, we're not going to actually do anything with it. And that's probably fine there. We're going to take in the form event, though. And then we add brackets, so this starts the function body. And so then we're going to enclose this in the function body. Okay, so now we've got a constant save function that takes this event. And so this is all going to be wrong because this is copy and pasted. But let's see what it does now. We should get something happening. And I'm just going to do this. So on script, it's going to run this and add an event listener. On save, let's go ahead and console. So that's going to go to that debug window that we keep opening and log. And I'll show you what this does. And let's do this. Save button. Okay, so let's go ahead and save and run this and see what it does. All right, something save, cannot access save before initialization. So made a mistake here. Oh, because we don't have what we need for this save, so it's trying to do something before we're ready. So what did I do wrong here? And I'm leaving errors in so you guys can see what I do wrong too, so that way in case you do it, you know how to fix it. Alright, so we've got a form here, and it says we're trying to access the submit before we actually even did anything, which is kind of a strange thing. Uncaught reference, cannot access save before initialization. So what this is actually kind of telling me is it doesn't know what the function save is. So what I'm going to do then is move it above it. Because what happened is it came along, ran into the form first, tried to call a save function that didn't exist yet, I think. So let's go ahead and see what this does. And our indentation got kind of messed up here from the paste. Let's go ahead and fix that right now while we're here because I'm thinking about it. So that goes in there, and that looks about right. We'll fix that again later, but that should be the indentation. Remember, just like in HTML, you want to see where things begin and end. This is a begin of a code block on this fetch call, so we want to have them line up. All right, so now let's go ahead and run this. Okay, we no longer get that error, so that's definitely what happened. So we want to make sure that our function is defined before we try and have something refer to it. And now it looks like it's remembering these values again. Okay, and now when I hit the save button, it said save button hit, but if we only saw, I saw it in a flash. You might not have seen it on the video, but there was a quick flash here. So one thing we can do is let's go ahead and not this one. Go back to this page. And what I did is I clicked on sources, and then here's our index page that's coming up. And it brought us right to our script, which is where we have our console log statement. Let's go ahead and I'm going to put a breakpoint just by clicking on that here, and then we're going to submit this form again. Okay, and so now we've got a breakpoint, and we could actually see what's going on here. So when I go ahead, and this is step over, so you can step into things that are called with step into. This is step out of if you step into something, and this is step over to the next thing. So I want to go from here to here. I can do things like debug things when I get to them. So let's go ahead and step over. And like I said, in the full stack mini course, there is a lesson that goes over this. Now we'll go over this again in the front end lessons in that course. But right now we're just trying to get enough of a front end up so we can get the back end. And you're learning a little bit to get familiar with it as we go. So this is our debugger. And we see that save button was clicked. So what's going to happen now is the form's going to do its default action, which is submitting. So this is listening for it. The form's still doing its thing. We have to stop the form from doing its thing. But let's do, while we're in here, I want to let you see something. So this user name example is going to set this variable called data. Notice it's empty right now. It's undefined. If I step over that, I can actually see its value. So that's kind of cool. We'll get into that more in this lesson, and then definitely in the front end courses we'll go over this a lot. All right, so now we're doing a fetch API call. Now this addresses might be what was called, so then we can expand this, go to the network, and see what happened here. So the 404 is the post request on the method, was the method, and it's doing our default form action. So what we want to do now is prevent that from happening. I know what it's called, but you don't. So let's go ahead and see how you would find out how to do that. Now, what's happening is the form is submitting, and we want to prevent that from happening. So those are the words we're going to type in. So I'm going to go here, open up a new tab, and I'm going to type in HTML form submit prevent. Oh, prevent default showed up. That must be searched a lot. And let's do MDN again at the end. And that'll give us here. So submit event. And this is telling us some of the things it can do. And this is where we actually got our thing. Oh, look at that. Okay, so in there, submit, something that we didn't look at, or I didn't tell you to look at, was the event prevent default, which would stop the form from submitting, which is what they were probably telling us to do here if we read through this. So we want to go ahead and do that in our code. So let's go to our save function, and let's do ev is what we called ours, and let's do prevent default, which is what they did. Okay, and let's go back to our page. And here we are, so let's go ahead and do another submit. And our page should actually stay here now. We might get another error, but our page should not go to that addresses URL where it was blanking everything out. Let's see what it does. All right, so now we're in that console log. I'm just going to run it by hitting this resume script execution. Okay, notice our page stayed, which is what we want. And then we got an error, which is also not what we want yet, but it's what we expect because we haven't told it to do anything yet. And you'll notice it's posting to example.com profile. And why is it doing that? Because that is the copy and paste thing that we grabbed. Okay, so now we're going to start having the errors tell us what to code next. So it's telling us to change this URL, and we have an addresses location. Now we don't actually have it on the server because we haven't started doing that yet, but let's see that that changes it. Okay, let's clear the form and add some data. It's nice that it remembers. Okay, we'll hit save. Okay, we get an error, but it's not that error anymore, so we did make it right, and now it's going to our addresses URL, which we don't have, and that's a 404, which is correct. So that's not what we want, but it is what we expect. Okay, so let's go ahead and see what got posted. Let's move this out of the way. And down at the bottom here, we'll see, okay, the username example is what got posted in our data, so we need to fix that. That's from our copy and paste. So that's the email we want. That's the value. Remember the name, which we don't really need as much anymore now that we're going to be not letting the form do its default action, but we're going to be getting values from the input elements themselves by ID. So we're going to go ahead and look up the ID on the controls and then get them by element and then get their values. So let's go ahead, and you see that the data is being posted. Let's fix this because we're going to add more than just one there. And we'll clean it up a little bit. And let's start with our email. What's the ID on email? Input email 4. Okay, I don't like that. So let's just go with plain email. I'll never remember the other thing. And then let's go ahead and we'll do a document, which is this HTML document, get element by ID, and then we tell it what ID we want, and it should give us that input element, or whatever element it is. In this case, it happens to be an input. So just put it in quotes, email, and that should give us an element, and then we say we want the value. And then let's go ahead and save that and refresh our page, and let's see what we get. We should just be able to fill in email here. Let's see. Okay, so we've got the 404, which is what we expect, and then let's go to the bottom, and there's our email. Okay, so now that we've got that one working, we can go and do the others with confidence that this is actually going to work. Okay, so let's go ahead and do the same thing for phone. And you'll see that there's a label, and we want to change that, and we want that to match. So for screen readers, or if there's an error, the label's there. You can click on the label, and usually it brings you to the input box, or in a screen reader, it'll tell you which field is in error. So then let's do address 1. We're going to do them all here. So we're going to change the label and change the ID to something we can remember. All right, so then only a couple more left here. So let's do city. Okay, and then state and zip are the last two. Okay, and name isn't as important here, but we're going to leave it because that's proper for actually sending a form if we were to ever send the form. So we'll just leave those there. That's fine. All right, so now let's go ahead and fill these in. We're going to call document get element by ID several times here. We're going to get a different element each time. So let's go ahead and let's just copy the whole line and paste it a bunch of times. And then we'll make the changes. Okay, next one's phone. And if you don't remember, just go ahead and go up there and check, but I think I remember these. I mean, it's an address and a phone and an email, so not too bad to remember. So address 1, and then we had an address 2. And then city. And we had state. Okay, and zip is the last one, and it looks like we have an extra one down below that we'll just remove. Just triple click on the line and then hit delete. And then let's get rid of the one with the comma at the end. It probably works fine with the comma, but we should remove it. I think some browsers have an issue with comma, but I don't know if they still do. They used to. Okay, let's go ahead and refresh the page and submit this, and let's see what gets sent. Hopefully it's everything this time. Okay. Yeah, we've got ASDF and everything. That's probably not a good thing because it looks like they all got sent, but we don't know if it's sending the same value. It could be doing phone for all of them that we know. So let's go ahead and go back and let's put values in. I'm going to put values that tell us what each one is so that we know that it's doing it right. So let's just do email on this one. We'll do phone, and then address 1. We'll just do what they are so that way we know exactly when we look that we're getting the value that we expect. Okay, and so 404 is right, and then we check address 1, address 2, city, state, zip, looks good. Okay, so we're sending data to the server now, so that's great, and we still need to fill in the server to get our data saved into our database on the server side. It's not going to really be a database, but it'll be, you know, full stack server actually persisting the address in memory. And that's it. Okay, that's the front end, and then we'll go to the back end on the next lesson. Thanks for watching. Hi, everybody. Okay, so here we are back with the lessons for this full stack exercise. So this is another part of the exercise. We left off where we built out our front end a little bit, and now we're back to the server side, which is where we should be for a server side course. Java backend, so we're going to go ahead and start filling that in. Where we left off was we have a 404 error when we submit our address, and we've got it sending the data, but now we need to do something with that data. So let's let the errors or the lack of functionality drive what we do next. And so with that in mind, we don't have something to receive this message. So there's the first thing that we need to do. So let's go ahead and go back to our code. Now here's our main function that starts up, and this is a Spring Boot main. Right, so just like we had our Hello World command line program, Spring Boot is using main to launch our Spring application, and in this case it's our demo application class, which was generated for us by Spring Initializer. All right, so now what we're going to do is add a controller. So Spring has a lot of great documentation on how to use it, and there's a concept of it loading. So it does a lot of things for you, which makes it easier. I think it's a good framework to learn from. I kind of like to do raw servlets, but in the interest of getting up and running quickly, and it's pretty straightforward, so not too confusing once you get it. You really only use a couple things in Spring Boot for the most part. So let's just learn those parts, okay? So what we need now is a controller. So a controller is something that's going to receive the message. So let's go ahead and we can go to a browser here and look at the documentation. So what you're going to do is do Spring Boot controller. And you'll see documentation on Spring on how to build these things. They've got really good tutorials. They've got a 15-minute tutorial here that you can go through on how to set things up. But basically what a controller is, and we're not going to do, this is a POM file here, so Maven POM file. We'll learn about that later in a little bit more advanced lesson. We're using it now when we run this thing from the command line. All right, so this is something you can go through. What we're going to do right now is just go through a controller itself. Now this is a REST controller, and they have actually just regular controllers. So let's go ahead and see what we can do with this. All right, so there's a couple things we can do. We can add the controller here to our application, and that would turn this application into a controller as well as the application, and then we would put our methods down here to receive the request. A small application like this is probably okay, but when you get into reuse and maintainability, you actually want to break things up, and you want to do things with a single purpose. So your class should have a single purpose, your function should have a single purpose, and so right now this thing has a single purpose, and that's to launch the application. So let's not break that rule right now, and let's just go ahead and make another controller. Now, or another class to hold our controller. Now we could make another package too, and I'm gonna. That's a really tough one because this is such a small program. It starts getting things more complicated the more layers you add. Something you do for a large application is not necessarily something you have to do for a small application. So let's keep it small for now, and then let's go ahead and break it up later. So let's go ahead and do a new file. And actually, that's now tempting me to put it in the main application, but let's not do that. All right, so what should this be called? Addresses is what we have, right? And let's just say addresses controller .java. Okay, and so this fills in for us. We've got a class, and that's what we want. We're going to use the at controller from Spring Boot right here. So that what that does is tell Spring that this is going to be a controller class. So we'll take in requests from HTTP. All right, let's see. So what do we want to do? We want to receive a message. So how do we receive? Now this has a lot of documentation. Does it have a post example in it? So I'm just going to type for the word post and search for it. Okay, that's telling us how to curl it. So let's do this. Spring Boot controller post. Post mapping example. That sounds really good. Okay, and then we've got a bunch of tutorials here. Let's go ahead and stick with spring.io and see what this one says. I don't think I've ever seen this one before. You don't usually look for these, but let's see. So this is an entity. Typically the entity is saying this is something I want to save in a database. And it's typically a noun. So in our case, it would be the address. Okay, and let's see here. Configuration class, we don't need that. So REST controller looks like we want to. Let's go ahead and use a REST controller here instead of a controller that we did. Followed their documentation here. And we've got a post mapping, and we'll make ours say addresses. So let's go ahead and use REST controller instead of controller. And if it pastes funny, you can just type it. I actually don't know if REST controller is a thing here. It is, okay. All right, so there we go. So now let's go ahead and see what they did here. So they have a post mapping, and then they've got a function body. So let's go ahead and do that. So we have a function, so it's going to be a public. Remember our lessons on functions. This is going to return a, what do we want to return right now? I don't even know. Let's return nothing for now. And we're going to say save address. Okay, and then we're going to do what they did here. They've got an at request body, and then they're taking in a plain old Java object, or in fact the entity that we saw up above. So let's go ahead and do that. Case matters, by the way. So request body, and we're going to take in an address, which will give us an error, meaning that it doesn't have it. So that's the class it does not have, which is good. That's what we want. We're going to let the errors and the stuff that's missing drive what we're doing next. All right. In fact, let's just go ahead and return our address too. Okay, so we're going to save it. And in this case, since it's a save, we're probably going to add an ID to it, and we'll send it back so that way the client now knows the new ID. Now you'll see here that this is in red, and if we try to compile it, it would say we couldn't compile it because we don't have an address. So I'm going to go ahead and hit Command dot here, or Control dot for you if you're on Windows. Let's see. So we've got import address. We don't want that. We have a class create address. That's probably not bad. Let's do that. All right. And we could put this in a entities package, but we're not going to do that right now. We're just going to keep it small, and if we end up breaking it up later, we will. All right, so address class. This is the thing that's going to be somewhat equivalent to what we have on the client side, which is the address that we're sending over. All right, let's leave that empty for now, and we'll let something drive us to fill it in. All right, so now we're not returning anything. So let's return address. Okay, we're missing something though. This is a function, but we don't have the post mapping to tell it to get here. So we've got post mapping slash addresses. So let's do that. Oops. At post mapping, and it had slash addresses. Now this addresses could be anywhere in a function or on a class. When we add more things, we're probably going to want to move this up to the class level and say this whole class handles addresses, right? So a single purpose. This is an addresses controller. And actually, it probably should just be address controller. But we'll leave it this way for now. And let's see what this does. And actually, I'm tempted to change that name. We'll change it when we get back. Let's see if this even works. All right, so let's restart our server. Control C that. Let's go back to our main application and run. All right, so now something should be receiving our request, so we should no longer be getting that post error. And let's see what happens. Back to our address book. Here we are. All right, so if I post this now, let's see what happens. Let's go ahead and close this so we can see what happens to the network. We got a 406 error. What is that error? 406. Cross origin. Why would I be getting a cross origin? We're coming from the same origin. .406. Okay, I don't know what 406 means, and I don't actually see the error. Let's look for it. All right, let's see what 406 means. Not acceptable client error. Response code indicates the server produced a response matching a list of. Oh, it can't produce a list. It can't produce a response from the list matching. All right, so why not? What do we have in our controller that's causing us a problem? Oh, maybe because it's an empty class? Could be. Let's try that. Let's have it capture an email. Let's make this private, and then let's go ahead and let it make a getter and setter. You gotta spell it right though. All right, create getter and setter. There's that. Okay, so now we've got a getter and setter. All right, let's see what happens now, because I'm a little confused. And this could happen to you too. Okay, and so I'm getting an error. I'm going to leave all these errors in here. So something about body needs to be completed. Lost one of those. All right, one more time. Let's shut the program down and restart it. Okay, let's see what happens now. Back to here and close that and submit. 200. So it's the fact that our class didn't have anything in it. All right, that's good to know, right? I usually like to let the program guide things, and I guess that did it, having it empty. So our response, okay, we got our email sent back to us. So it's working. All right, so let's fill in a little bit more. And we'll do it the same way we did it. So let's do private string phone. And even though phone's a bunch of numbers, we want to take it as a string because it could have formatting or any other kinds of things in it, so that's okay. All these will be strings. Okay, address 1, address 2, and I'm typing here, so you might hear clicking. Private string city, private string state. I am glad we changed those other names. These are something I can remember. Zip. Okay, and that should be it. So then I wonder if this thing can generate all. I'm sure it can. I know we can do it one at a time. So if I do command dot, I'm just doing command dot on each one of these. Okay, and it mixed them all together. So that wasn't as good as I wanted it to be. Let's see, let's move email address up to the top, and it looks like it did them all in reverse order. So that's kind of funny. All right, so that's all right. It doesn't matter what order they're in. It just would have been nice if I kept them in that order. So let's go ahead and run this now. Oh, what did that do? All right, hit the trash can. That'll kill that. And let's go back to here and restart it. No big debug mode this time. I don't think we need it. All right, when we get this echo back now, it should have all the fields that we have. Let's see. Okay, and now we've got all the fields. Okay, that's working. So now we just need to have it save, which would be nice. So here in our controller, we want to do something to have it save. Now, again, sticking to that single purpose thing, we should make an address service for Spring Boot. So the controller's purpose is to basically convert the post request into something that can be saved. And that's its single purpose. If it also then saved it into the database, that would give it two purposes, and that's not exactly correct. So the right thing to do would be to make an addresses service, but let's go ahead and change this to address service. I don't like the plural here, so I'm just gonna see how we can maybe right click and rename. Will that work? Refactor. Let's rename an option. Nope. What if we do it over here? Rename. Okay, I like address controller better. And let's say, go ahead and let it do it. Okay, so it changed it to address controller for us. Addresses is okay for plural here because it's going to, that's what the collection of things is the addresses, but this address controller is controlling an address, so let's do it that way. All right, so let's run and make sure our application still runs the way we expect. Okay, and don't need to refresh because nothing changed here. Go ahead and run and click on this, and looks like we've got what we wanted. Okay, so let's save it somewhere. All right, so back in our address controller, we need to do something like save it. So we're going to import a class, and so in Spring Boot, it's called auto wire. What that will do is it'll automatically wire it'll automatically add the class in here so that we can use it. So we're going to auto wire an address service. Okay, and in Java, uppercase or camel case, I don't know, I think every first letter of the word is uppercased, and then lowercase for the first, for the variable name, and then uppercase for the rest. So that way we know the difference between a class and a variable. All right, and this is telling us, of course, that this address service does not exist yet. All right, so let's let the error drive what we're doing. Do command dot, create class address service. I could have created it into a package, but let's go ahead and leave it here. All right, and now this is a service. Okay, Spring service, you can see that. Org Spring Framework stereotype, I think is what it says there. All right, so now this is a service, and it's an empty service right now because we're going to let the work drive what we're doing. So we'll go back to our controller, and now we've got an address service, and it's saying it's not used. We're going to use it right here. So address service, and we're going to call save, and we're going to pass it the address. Now this doesn't exist yet, so we should get an error. Okay, it's saying save doesn't exist. And what we want to do is let that go ahead and return back to us. So, and it's going to return an address back to us. So let's go ahead and just throw that right back to the client that made the request. All right, so then I'm going to put the cursor on that and hit Command dot. I'm going to create method save. And so that created it, and I'm going to jump into that with, I think it's function F12. And so I'm in there, and we're going to save our address here. Now, if we had a database, we'd be creating another layer, which is, I believe, repository. So there'd be a new class created that's repository, and we would go ahead and put everything in there. I don't think we need to do that at this time because address service's job is to save something into something, and we're not going to have a database, which would be a nice thing to have a repository in front of. We're actually going to do this in memory, and it's okay to have it here because we don't have a central database. We're going to do this in memory, and each service class can have its own instance. So remember what we did for maps back when we were creating, I think it was user logins. So we're going to use a map here. Let's go ahead and do private map, and we're going to have it mapped by the address's ID, which will be a string, and it's going to store the address. And that's going to be addresses. And we'll make it a new, let's make it a new map. Does it need to be sorted by anything? No. So let's just call it a hash map. Okay, and if we don't have it imported, we'll command dot, and that should import it. And command dot again. No code violations there, but there is one over here. And now it should be happy. All right, so addresses is not used, so let's use it. So here we're going to go ahead and do a put. Oops, addresses.put. This is from one of the Java Crash Course lessons, and you can refer back to that if you want to. One of the exercises we did. Okay, so now we're going to take address dot ID as our key, and I don't think we have an ID yet. And then address is what's going to get saved. And then we're going to go ahead and return the address. Okay, notice here it's complaining that we don't have an ID field. And that is correct, we don't. So let's go ahead and let that create an ID field for us. All right, and then I wanted to F12 into that. I hit F11 by accident. Okay, so ID is here, and that's public because we referred to it by its property value instead of by a function. So let's go ahead and do this because otherwise it would have created us a get ID. Which is what we want it to do. So let's go ahead and let it do that for us here. So create a getter and setter for ID, and it again mixed up the ID and the email. So let's go ahead and put this here just to keep the ID together and the emails together. Okay, so now we've got get ID, so let's hop back to our service and get IDs now. Oh, it changed it for us, that was nice. Okay, so now it changed it for us to get ID, and it's going to put this in here. Now, get ID is empty. It was new. It wasn't set by the user. The user doesn't know what the ID is. So we're going to go ahead and set it to a unique identifier. And so let's do this. In Java, there's a UUID, and that's a unique identifier. And we're just going to go ahead and let it give us a random one. And we're going to let that be a toString because we want to have to let it go ahead and have. We could do it by the UUID itself, and that should be fine. But let's go ahead and do it as a string, because that's what's going to get sent back and forth from the server. And we're going to assign it to a new local variable. And I don't like the name string. Let's call this ID. Okay, so that's going to make an ID here. But notice what's going to happen. As soon as it comes into this function, it's going to run this, and it's going to create a new ID. We might already have one. This is a save method, so it could be used again to save things. So an address could already have an ID. So what we want to do is use one of our conditional statements. And let's do if address.getID equals null, which means it doesn't have a value. Then we're going to assign it to that ID that we generate. So then we're going to do address.setID. And now when we put it in there, it's going to go ahead and send it to us. Now put, does that return anything? It returns the address. So it returns, associates the address, returns the previous value associated with the key. We don't want the previous value, so we're going to go ahead and not even capture that, and we're just going to go ahead and return this address, which will now have an ID on it. So let's go ahead and see what happens when we do this. So we're going to save it into here. So let's go back to our controller. We're going to return the address that this thing gives to us. So it should have an ID when we see it on the other side. Okay, we're sending it without an ID, and then hopefully we should see an ID when we get it back. Okay, so let's see what happens. So let's go back to the application itself. Let's close this, and then we'll run it. All right, let's see what happens. All right, when we save, there's our ID. So we've got a unique ID saved in there. So let's go ahead and do another one. Let's call this one email 2, just so we could see something's different. And let's call save again. And this UUID starts with C2F5. And this one starts with 45C7, and the email address is email2. So that's interesting. So now everything's saving to our fake database in memory, and it's coming back. So how do we prove that out? Let's make another controller method over here. So we've got a post mapping. Let's do a get mapping. So remember, the verbs for HTTP RESTful calls is get will get data, post will create data, update, put will update data, and delete will delete data. So we've got get, post, put, and delete. Those are the main ones we work with. So we're going to make a get mapping, and then later on when we want to do an update, we'll do a put mapping, and then when we want to delete, we'll do a delete mapping. All right, so let's go ahead and do a public. Let's return a list of all of our addresses. So a list of address, and you'll remember this from the crash course lessons that we did. Let's just say get addresses, or let's just call it something more generic. Let's just say get all. It doesn't matter what we call it on this end, because the mapping is what's actually sending it here. All right, and it's just get all. There's nothing to get to put in here as the list. All right, list is not known, so I'm going to hit command dot there, and that'll import it. All right, get all. So now we're going to ask our address service to get all. All right, it doesn't have that yet, and we're going to want to return whatever it gives us. So let's go ahead and put the cursor there, command dot, create that method, and let's F12 into it. All right, so it's empty, it's returning null. That's not what we want. We actually want it to return the list. So we're going to return a list of these addresses. So let's go addresses dot, and we're going to get the values collection here. And you'll notice that it's complaining, and it's a type mismatch because it doesn't match. The collection does not match the type of list. So let's do this. We're going to do new, and this is from our array lesson that we did in the crash course. So Arraylist of address, and we're going to let it take in those values right there. All right, it doesn't know what address array list is, so I'm going to command dot that and import it in. All right, now that get mapping should actually return this. So let's go ahead and restart the server. Back to the demo app. Okay, we're running. Let's see what happens. Okay, we've got addresses. It should be empty now because we've restarted the server. We're in memory, so as soon as we restart it, everything goes away in memory. So let's go ahead and clear this out, and let's go ahead and save one of these. Actually, let's see our empty list first. Okay, so we've got a get on addresses. Okay, ready? We've got that happening, and that is a 405 method not allowed, so it's not seeing our get. So back to our controller, because I didn't put the mapping, so that could happen to you too. And this is probably that case where we want to move it up to here and let that be the address. You can keep it down here and keep it that way for other things, but there's a way to refactor this to get the common thing up to this class. Let's leave it here for now, and we'll do that later. All right, so let's restart the server. All right, now we should be able to get a mapping. I like leaving the errors in because that way you see that even someone who's been doing it for many, many years has errors like that, and it's no big deal. It's nice to have the program actually tell you what's wrong, so you can just do it without having to remember all these details. All right, so that's an empty list, and that's what we expected. All right, so let's go ahead and add email. We'll add phone. And zip. All right, we'll save it. We've got one in there, so let's go ahead and add a second one in there. Let's do phone, email 2. How about add 2s to all these? Oh, how do I add that one to this? Let's do add this 2 here and just delete that one. That way it's different. All right, ready? Save. All right, that's good. What did we get back? Got a different ID, email 2, phone 2, address 2. Looks good. All right, so now let's go back to our addresses get. And we've got data. So it's kind of all jumbled together, but let's see if we highlight it. So there's one record, and this is called JSON format, JavaScript object notation. So here's our array start and our array end. Here's an object start, curly bracket, and an object end, and then a comma, and the next one starts. So the first one is, all right, and it's a hash map that we're storing it in. So we're getting them in the order that the map stores it in. So we don't really know what that order is going to be. So address 2 came out first in this one, and we might want to do some sorting on this. So we'll do that in one of the other parts. But for right now, we're actually getting data. So we're actually saving to a kind of a fake database right now. So let's go ahead and let's do kind of a different test here. Let's add some real data. Let's say Bob, and let's do 333 555 1212, and he lives, sure, 1234 Main Street sounds good. And he's in any town, and it's any state. Let's go ahead and make it a real state. Let's make it Alaska. And then we'll go ahead and give him a zip. I don't even know what the zip code in Alaska is. Let's just do that. All right, so we've got back Bob and his phone number, and then let's go ahead and see what we have. Bob should be in there now. Where's Bob? There's Bob. Okay, so it's got his unique ID, and there's his data. All right, so when we come back, we're going to go ahead and format this into our form so that we have the form here and then the list of addresses down here. All right, that's it for this one. See you in the next lesson. Hi, everybody. We're back with another part of the exercise, and in this part we're going to go back to the client side and fill in a table down here that will have the list of addresses we've added, and then we'll do another part after that that allows us to edit the addresses on the server side. So we'll go back to the server after we do this front end part. Okay, so I want a table that's going to be down here that gives us a list of what's been added. So let's go back to Bootstrap, and I'm just going to type in bootstrap table. And then getsbootstrap.com is what it is, and then table styles. So let's go here. And then they've got examples, just like we cut and paste that address. Let's go ahead and cut and paste table. And you can pick whatever you want down here. I usually just take the simple one, but they've got quite a few examples that look pretty good. Bordered example. So these are nice looking tables. I'm going to go ahead and pick the first one though. This one right here. So I'm just going to copy that code. And then I'm going to go back to our editor, and on the index page, I'm going to paste it in right underneath the form itself. And so the form is inside of a div. And that div is a container. So let's go ahead and put it here maybe. Alright, so let's put, I don't even know what it's going to paste, so let's paste it in and see what it does. Okay, so it's got a table. Let's run that to see what it looks like. And then we'll see what we have to modify. Okay, so I just refreshed the page, and that doesn't look too bad. Might want some space there, but that's fine. You got to change the column header, so let's go do that first. And so here's the headers right here. So basically a table is a grid-like layout inside of a web page, and it's got a header, and so t head is header, and that's for this row that goes across here. And then th is, so tr starts a row, and th is a table header itself. So these are the parts of that. So each one you'll see number first last handle. Number first last handle. So let's go ahead and change that. We want I guess we'll put email here. It's funny, it didn't add name to the other to the form, so probably should do that at some point, because it's funny how it's just email and phone and then address and not a name. Okay, so what do we have here? We have address 1, probably good enough. And let's start with that. And then we'll add their name in later on. All right, and so we don't need this one now. Here's another header, and that's the header going down the side here. And we don't need that, so we're just going to go ahead and remove that one. And remove it here. And remove it here. So we're still using some of their data. And we're going to get rid of that, but just to see what it looks like as we're doing it. So now we've got our email, phone, and address. And then we've got some information in here. So that's pretty much what we want for our table. And now we're going to clear it out. So here's, again, here's the table header up here. Here's a header row going across the top. You could set a header going down in a column. And here's the table body. So this is the part that's going to actually have our data in it. So tr starts another table row, and td table data. And so those are the each of these cells here that would have a line going down here and look like more like a cell, like on a spreadsheet, but that's what that looks like there. So let's go ahead and cut these out for now. So we've got rows and headers. So if we do this, now we're just going to have the header with nothing underneath it. All right, so now we're going to do some JavaScript to get that in there. So what we're going to do is get our list of things when our list of addresses added, when our form loads. Okay, so here we've got a script tag, and we've got a save function that goes to here, and then here's more JavaScript code that's adding the listener on the submit. We can add more code down here, and let's go ahead and have this get the addresses as a get method. And I think we could just do fetch and address, and it should just work by default. And if it doesn't, we'll go back to Mozilla and see what we're missing. So fetch, and we're going to add our details here. So what do we need it to do? I'm going to look it up on MDN because I don't remember. So MDN URL fetch get request. All right, let's see what that gets us. So here's the fetch API. And so we're back on this page again, and we're just going to see what get looks like. Okay, this is get right here. So it doesn't need the brackets. We're just going to get this response. So let's just copy that and use it. All right, here we're going to fetch. And I'm going to format. Formatting got funny there. Okay, there it is. All right, and we're going to actually just go to our addresses. And we're going to get this, and we're going to log that out to the console right now. And we've got nothing in there right now, so it should be empty, but let's see what it does. What does our console look like? I've hit escape. It's got the empty array, so it's empty. So let's fill in somebody here. Let's do Bob. Oh, nice, it remembered all the fields. So now if I save this, all right, so Bob's success. Now if I refresh this page, this array should now have a value in it. And it's got dots, so it definitely has something in there. Okay, and here is Bob. Okay, so now we've got Bob added there. So now let's get Bob added here. All right, so back on our page, we've got this data coming in here. So let's go ahead and have it do something with this. We should just be able to add a block statement here, and that should still work. Let's make sure. And it does. Okay. Otherwise, it would have shown us an error that it couldn't do something. So now we've got the data. So now what we want to do is, with this data, go through each item. And right now we've got one, but let's go ahead and pretend we're going to have more than one. So with this data, we're going to do a for loop. And you remember that from the loops lesson. Well, it's not int. This isn't. So for loops in JavaScript are very similar to for loops in Java. Extremely similar. The only difference is what the variables are. Java is very typed language, whereas JavaScript's a little bit looser. So here it's let, and it could be let any type. So I'm going to let this equal I, and then I'm going to do while data.length. Oh, you got to put I there. So while I is less than data.length. And then I++. That'll let us go through each one. And there's a for each statement in JavaScript, but I don't like using that because this is more clear and more easily debugged. So I prefer this structure. And this isn't a comma, it's supposed to be a semicolon. Okay, and so here I'm just going to go ahead and take in the variable, and I'm just going to call it address. And it's going to be data sub I. And I'm going to console that out. Okay, and I'm just incrementally filling this in as we go. So let's see what that looks like. Okay, it printed out the one address, no longer the array because I removed that. So we've got the one address. Now we just need to get that address to show up in here. All right, so I want to show up inside of here, so let's call this, give it an ID so we can access it. Let's call it address dash body. Let's do that. Okay, so ID address body, we're going to go ahead and insert table information here. So let's do this. So here we are down here, and we've got, we'll let that keep logging out. But let's go ahead and I'm going to make a string for now, and let's see what that turns out to be. So let's see, JavaScript can do string substitution. So let's see what that looks like. So JavaScript string substitution. It should tell us how to do that. So template literal strings. So that's what we're looking up around MDN again. So see this little, I guess it's called a tick mark. We can put an expression in here like this. So let's see how that works. So it's got variables up above. So let's just try that in the console again. All right, so let's do this. We've got address right here. So let's see what this looks like. And how did they do it? Did they set it equal to anything? I think you can set it equal to something. Let's try it. All right, so let's do let, and let's just call it output equals, and we're going to just do a simple one for now. Let's say email, and let's put $email like that. That's the format. And then let's see what that prints out. Let's see, console.log output. All right, so now we should get some output, which is an email, and then the address. Let's go back here. Okay, and it got us as an object because I didn't put this in there like that. Okay, so it's address.email. All right, let's see how that works out. Okay, now we got Bob's email, so that worked. Okay, so let's go ahead and make a template using something like this for our table. Now remember, and let's go ahead and just put it right here. A table starts with tr, right, and then it has a td, and then here we were going to put email. Oh, and I got to make sure I put address dot email, and then it had an ntd, and then we had 3 columns, right? So then we're going to do another td, and we're going to do address dot phone, and then ntd, and then we're going to start another td, and this will be address 1. So we're going to do $address 1, and then end the td, and then end the tr. Oops, that's td. Okay, so now we should be able to insert that inside. So let's call this template. Let's call it a constant. So constant means it doesn't change, and we'll just call it template equals. All right, so now we should be able to do this instead of having this literal here like that. We should be able to do with our template. Oh, I wonder how that's going to actually work. Seems like it needs to do this. Let's call this output again. And it's not a constant anymore because it's going to change in that loop. And let's see what that prints out. Okay, there's a tr, a td, and that looks all good. So now what we're going to do is we're going to keep appending that to, so let's make a variable for table data. And right now it's just going to equal an empty string because there's really nothing to it. And then we're going to append this td to it, or this table row to it. So let's do that. So each time we go through here, and remember from the Java lessons on assignment operators, JavaScript and Java are very similar. So what I'm going to do here is we've got that table data. So I'm going to do table data, and you'll remember this plus equals from the assignment operators. JavaScript has it too, and it does it for strings. I think Java can also do the same thing. And so now we're going to take table data plus output. And now output's going to print out. We don't need address. And then at the end of this, let's print out table data. Okay, let's refresh the page. Okay, there's our table data printed out. So now we want to document.get element by ID like we did before, and we're going to get address table. Is that what we called it? A class table, and it's called address body. Let's call it address table. Address body doesn't make sense to me. Okay, and let's call this address table. We already did. Okay, and then here we're going to set the inner HTML of that equal to our table data. Okay, and let's see what happens here. Hey, we got a record. All right, let's add another record. Okay, sure, we'll use Bob's and then we'll change it to something else. How about Roberta? And change the address a little bit. Lives on the same street in the same town. Let's save that. Okay, so we've got success. Our table didn't reload the data, so we'll figure that out in a minute. But let's just refresh our page. And now we've got 2. So we're almost there. Hey, let that plus sign get there. Okay, we don't have edit yet, so we can't change that. All right, so we've got our record showing up. So we're almost there as far as this part goes. Let's go ahead and have it load that record when it gets there. So what we want to do is when we get this, so right now we're putting out success when that happens, and that's not indented properly. Okay, the indentation is strange on this. Let's go ahead and see what's going on here. Oh, okay, it's because of this. Okay, so that looks right-ish. Okay, that closes that, so that should go like that. And then I typically just put them on the same line to start it off again. Yeah, indentation's important because it really makes it easier to see things. It looks like it's going to have to go like this for now. And I'll have to fix that indentation later. Okay, so that's a little bit better because then we can see how things go. This then actually goes with that right there. Okay, it's a little bit clearer. Okay, so now here we've got data and data success. Let's see what that actually prints out. We'll do Bob again, and this time we'll do Tom. Tom lives with Bob. All right, so it's success, and it's got that information. So we should be able to take this, and if we do the similar thing with the output, let's see, that's going to set inner HTML. What we should do differently then is actually have data returned to us from the server side that has all the rows. That's probably not the best idea, because what if we had 1,000,000 of them? Every time we add one, we're going to have to do 1,000,000 reads back in. So we can append a row to that table. Let's try that. And I'm just going to copy and paste this for now, and we can clean this up in a little bit. Okay, so let's do this. Okay, so we've got that output, and this is called address. Let's change that variable and see if that works for us. Okay, and then let's console log that. Did that actually get the right marks? Yeah, it did. Okay, so then I'm going to console log output. So every time we add a record, it's going to output right here. Okay, let's run that. I'm just going to refresh the page here. All right, so now we've got Tom, and let's do another person. How about, I don't know, Bill? Oh, we're doing lowercase. Let's do Bill. That if we save. Okay, so now that on line 93, console logged out our output. So let's see how we append to an HTML element. So mdn HTML append. Okay, they've got a better one. mdn JavaScript append HTML. So node append child. So how does that work? Or element append. Either one probably works fine. Append some text. So you think that'll work? It's one way to find out. Let's try it. All right, so now we want our document get element by ID, and we're going to get the address table. And we're going to append. And we should be able to append output to it. I think that works. I'm not sure. That's what it says. Oh wait, what's this P? Append some text. Well, let's see what it does, because I don't know what it's going to do. Oops, where's the browser? There it is. Right here, and let's do this. I'm running out of names. David. We got something. Ah, look at that. It put this as what we put in instead of the actual data. It's got it, but it put it in as data, probably because the append method is doing something that we don't want. So how about append HTML? So how do you make HTML out of something? Okay, let's do this. JavaScript append HTML to element. How about to table? Look at that. There's one right there. Okay. Stack Overflow is a good resource too. So what do they have here? So they're actually making elements in JavaScript. Okay, this will do... Oh, that's using jQuery, which is handy, but not what we're using. Okay. Not really finding what I want here. Let's do this. And I don't know if this will work. Enter HTML plus equals output. That'll be interesting if that works. And probably not the most optimal thing, but let's see what it does. We're learning, so let's just keep experimenting. Okay, so we didn't get the record. Oh, David showed up because it ended up on the server but didn't come here the way we want it. So Tom, how about Tim? All right, save. Hey, it worked. There's Tim. Let's do another one. How about John? And there's John. So there we are. We have a table on the client side to see our records go in. I just refresh the page and they're all still there. So that's working. And we'll later on, we'll go at the end of all these parts, we'll see how we can optimize things out. We're learning how to put this together. I haven't done this part before, so we're learning together, and then let's see what happens. All right, we'll see you in the next part. We're going to go back to the we're going to do a little bit more on this side to get it to where we can edit one of these, and then we'll be back on the server side doing an update of the data that we have on the server. Okay, see you in the next part. Hi everybody. Okay, where we left off was we were able to add records down here to this table, and now what we want to do is allow ourselves to be able to edit a record. So we want to be able to click on this email address here and have it populate the form. So we can change the information and then save it and have it change the information on the server side. So first thing we need to do here is add a link so that when we click on this, it actually does something. So let's go ahead and go to our template. And here we are back in our editor. So the template we have is here, and here's email address. So let's go ahead and add an anchor here. And we want it to actually anchor to something. So right here, what we want to do is addresses have an email, and they also have an ID. So we're going to put our address here, .id, and we need to put, this will send it to this URL. Let's see what that does. It's probably not what we want, but let's see what it does. All right, now we've got clickable links here. Let's go ahead and click on one of them. And you'll see now it went to an error page because it tried to go to this ID. That's not actually what we want. We don't want it to change the page. We just want to load that form up. So we need to put a hash in front of this like that so it doesn't change the page. So let's go ahead and add that here. So now if we refresh without this, we'll click on a record, and now we've got the page stayed, and now we've got the ID of the record we clicked on. So now we want to go ahead and get this called a hash change. Then you notice it changes as I click. So we want to know when that changes so we can populate this record. So let's go ahead and let's find out how we do that. So it's called window location is what this is. And I think it's window location hash and event. And we probably want to do JavaScript because there's other, like jQuery is very popular with that. So let's see. And here is MDN. And what we want is a window event listener. So let's go ahead and grab this is what we want. And we'll put it down at the bottom of our script. So window add event listener on hash change, we want a function. And it's going to take an event. And we put our function block here. And let's go ahead and console log this event and see what we're getting. All right, so now when we change the hash, if I click on one that changes it, we've got a hash change event, and we actually, looks like we get the new URL. So old and new URL is so what was there and what is here now. But I don't see the actual hash value itself unless we get it as part of the URL. So let's go ahead and do this. It's getting that as a string, so let's just go ahead and get it from the window object. So window.location.hash, I believe. Yep, let's console log that out. Okay, and see what we get. And there's the hash right there. All right, so now what we want to do is we want to take that ID and find the record here by that ID. Now in the previous part we were talking about how this is not the most optimal way to do this. We've got a string here and that's fine, but the way that we're just going through it and not capturing anything, so probably what we want to do is capture the records in a way that we can get to them by their ID. So let's do this. Let's put a variable up here. Let's call it let and addresses. So this will be similar to what we have on the server side. And this is a hash in JavaScript similar to a map that we have in Java. So this will make an addresses map that similar to what we have down there on the Java side. And then what we're going to do is populate addresses with the address ID and the address. So now what we'll get is when these records load, the addresses are going to get loaded by their ID so we can look them up. So let's go ahead and see how that works. I shouldn't actually change anything here. So click. It won't change anything until we actually try to get the record and see what we get. So now when we click on this hash change, let's see if we can get that record. So we've got this window location hash. Let's go ahead and save that to a variable. Let's call it hash. And it's going to be a constant because it's not going to change. And that's the hash. All right, and let's console log the hash. And let's also now console log the address that we get. All right, don't have one yet, so let's go ahead and set a variable, and that's not going to change. And we're going to get from our addresses collection that we just added up above by the hash ID. And we're console log out address. Let's see what happens. We got undefined, and that is because our hash has a hash in front of it. We want to get rid of that. So similar to Java, we have a substring method. So let's take our hash and let's substring it. just like we learned on the Java side. And we're going to take from the first character on. So the first character is 0, right? That's the one that the hash. So we're going to take from position 1 to the rest of the string. Let's go ahead and call that ID. And so now if we look up by ID and no longer hash, we should now have an address. And here we go. We've got an address that has Bob. So if we click on Tom, we should now have an address that has Tom. Yep, there it is. So now we got the address. So now what we're going to do is populate our form up here. Similar to what we did here, I'm just going to take and do the reverse. So here we're actually getting the values from the elements. Now we're going to go ahead and populate them. So I'm just going to copy and paste. Let's just put it right down here. We'll get rid of all those log statements later. And let's go ahead and get rid of some of this stuff because we don't need these labels. Those labels are for the JavaScript, which we're not using, or JSON that we're not using here. So I'm just using this to get those elements. I don't want to type it again. You could type it again. All right, so now we've got an address. So now I could just set this equal to address.email. And then do the same thing with all of these. Oops, got to remember put the equal sign. And this will be address 1. And this will be address 2. And, oh, forgot the equal sign again. Okay, and that's zip. So that should be the end of it. All right, so now what we're going to do is we're going to populate that form up above with these values that come in. And this should actually just work. So let's see what happens. So let's do, hey, look at that, it filled in. So now we could try and save it when we click here, and let's see what our record would do if we did hit save. Okay, it added Bob, and this is because our add template doesn't have the ID in it yet. It just added him. We wanted actually to change that. So what happened here, we hit the save button, and our save button actually works on the click and it's posting. We actually want it to do a put. So post is for create, put is for update. So we need to go back to our form submit. Where is that? Here's the save operation. Here's the data. And then here's our fetch. Notice this says post or put. So we need to make this change depending on what we're doing here. And we need to know when it's different. So what happens is a record that exists on this side, by the time it gets here, it has an address ID, right? So what we want to do, let's go ahead and add a hidden value to this form. So we can do an input, and we'll set it to type hidden. Now let's give it an ID too so we can get to it. So the ID, let's get it to equal to ID. So when we set it now, we're going to set this value in here to ID, so then we'll know if we actually have an ID set. And the only time it can actually get into the table is if it does have an ID. So, because it means it was loaded from the server. Well, unless we load it from our edit form, which is not doing it right. So we're not there yet, so we don't have to worry about it till we get there. So let's set this to address.id. So now if we send that, it's going to send our ID, but we need it to actually do it with a put. So notice it says post or put. Let's go ahead and make a method variable. And it's going to be a constant because it's not going to change within this call. And let's do ID. We need to know if there's an ID on the form. So let's go ahead and set an ID here. All right, so now if there's an ID, we can go ahead and do something with that. So let's do if data.id, and then this is called a ternary operation. So we're going to say if the data ID exists, we're going to say we want a put method. Otherwise, we want a post method. All right, so then that should give us what we want. And it's going to post the data, so let's see if it ends up being a put. All right, so we'll refresh our page, and we've got, this one has 2 records now. Let's do Tom. All right, and now if we post this with a change, let's go ahead and change this number to 1, 2, 2, 2, 3, 3, 3, 4, 4, 4, 4. All right, so if we do a save on this record, we get undefined, which we haven't changed that yet. And now we get a 405, which I think it's operation not allowed. And we have our put method, so that worked. It's sending our ID. Where's our ID? There it is right there. So now it's sending that to the server with the ID in it. So we should be able to get the put information down on the server side. So this is working kind of the way we want. We need to make this fill in when it's successful. So we're closer. Let's see. So we need to do a lookup on this to see why this is seemingly coming in here with a good address, even though the response is no good. So let's see what our, because our response definitely says 405. So let's see what's happening here. Let's see, did we get that post? We did. And do we have the 405? Yes, we do. So there's a status code 405, so we need to check that. So let's do URL fetch status code. And let's see how we're supposed to get that. Let's do MDN. All right, response status. Let's see what that looks like. Do they have the URL fetch example? So here's a fetch, then function response. That is different than how we're getting it. So let's see, go back to another example, this one here. Now let's find status code. Response.status. Do they have an example of how to do it? And they don't appear to. Okay. So let's see, how do we do that then? Guard, since headers can send requests, what does this do? Non-requests. So response, as you've seen above, response instances return and fetch. So if we're reading through this, response status is the value and their status text. Do we have an example here with it? And I don't see one. So keep searching. Okay, let's say how to get status. We'll look for any example right now. Let's see, maybe this one here. Lots of documentation, but you have to kind of sift through it sometimes. And it's not what I'm expecting. Here's a fetch example. So it's got a then function response. Okay, let's try that then. So we've got a then response. All right, so then let's say, I don't even know what to do here, really. Dot status, not equal to 200. Then what? I'm surprised it's actually not going into this error. Let's see. And let's add the status code to it. Just to see what it even does, because I don't really get what's going on here. All right, so let's go ahead and post a record. .405. Oh, good, it didn't actually do anything with our record, maybe because we broke it, but so we did something. Tell you what, I'm going to stop the video here and we'll pick this up on the next one. I'll do a little bit of research and I'll be able to explain this a little bit better. All right, see you in the next lesson, or the next part, or the next recording, which could be appended to this one. Okay, so we're back, and we were really close. What was here before was we had status not equal to 200, which was fine. So not really anything wrong with this, but it was more optimal to go ahead and put OK. More readable, actually. And then instead of console logging out, if we throw an error from here, it'll go ahead and stop doing this and throw it down to this thing, which actually just logs it out right now. And then the other thing that was missing, why it broke on the record, was that this return wasn't there. And so it just kind of stopped and didn't do anything because nothing returned. So really close to getting it right. Needed to add this here and just change that a little bit, and then needed to add the return. So now we're getting it to where we're not adding that other record. So if I go ahead and refresh here and then populate a record, make a change, and then hit save, it's getting the put 405, which is right. It's getting the error. It's printing error twice because I told it to with the label and the URL. And then it's not adding that crazy record here like we were getting before. So that's actually working and sending to our server side. So in the next part, we're going to go ahead and take this record and add it or modify it on the server side and then return it back and send it back into here. All right, so that's it for this part, and we'll see you in the next part. Thanks for watching. Hi, everybody. Okay, we're here for the next part. And where we left off is we have it so our address record can be edited by clicking down here below on a link. We changed it when it loads to have a link. This is an updated record here. We need to fix that, and we'll fix that in this part. So if I click up here and get a record loaded up there, let's go ahead and refresh here. Okay, there's nothing down there. That's why that wouldn't work. Let's go ahead and save a record. I've got a breakpoint there. We must have been debugging at some point. All right, so now we've got a phone number. I can refresh this and get it to load the records right. And then if I click it, and I should be able to change that phone number and hit save. And it'll be an error because it didn't actually do it because we need server-side content to change. But let's see what we have on our request. So we've got a 405, which is what we were getting last time. It's a put, that's correct. And it is sending the information to the server with the ID. Okay, so now what we need to do is go over to the server side and add the code that we need over there. So in this address controller, we've got a get mapping, a post mapping. Now remember, get is getting records, post is creating records, put is updating records. That's the one we want to add. And then delete is deleting records. So we want to add a put mapping because there's a get mapping, a post mapping, a put mapping, and eventually we'll have a delete mapping. All right, so okay, notice that we're doing the same thing over and over and over again. It's kind of rule of thumb for me is if I do something 3 times, the 3rd time it needs to change. If it's easy to do the 2nd time, I'll do it the 2nd time. But 3 is definitely something that needs to be different, at least in my book. So let's go ahead and change this. And let's remove that for now. Because I want to, when you refactor, you want it to be the way it was. Then you change it to make sure it's still working the way it was before you introduce new code. All right, so we remove those, but we still need them back. So you can actually put it up here on the controller as a request mapping. And so any request coming into this controller will have whatever address we tell it here, or addresses in this case. And then these will automatically have that in front of it. And then if we want to add to it, we can just go ahead and add whatever we want to here. So we could even make this all, all like that if we want to do addresses all. But we're just going to do addresses, get, post, put, and delete the straight verbs. If we wanted to add more functionality to this controller, we might need to change the URL a little bit, but for this case we don't need to. All right, so let's make sure this is working because we made a change here and we need to make sure it's working before we add any new code, because if we make changes to existing code and then add new code, we don't know what broke it. So let's go ahead and refresh and we should be empty. Let's create a record. Okay, and so that created the way we need to change the way that this reloads the record, but let's go ahead and reload it. Okay, that's working. And so we should be able to come up here and change it. And that's a 405, and that's correct. That's what we expect. All right, so now let's go ahead and go back to our controller. And now that this is working the way we think it should, let's go ahead and add our put mapping. Oops, post. Okay, and now we don't have to put the URL there. And let's do pretty much the same thing. That's the save address. And request body. And Spring will automatically convert what's coming in to the address for us. All right, and then return address service. And save is going to do the same thing no matter what. We could refactor it to do something different if we made this update. Let's go ahead and go in there. So function F12 for me. Here's the difference, and it's where this is doing the address. Now, we had a small problem that I fixed here. Something we did on the client side last time made it so this would come in as an empty record rather than a null record. So isEmpty will check for both of those things. And so this is where it's assigning the ID. What we could do is always have it assign the ID, and then save would be for saving only, and then update would be for updating only. Let's go ahead and do that. That makes sense to me. All right, so what we're going to do is have it set the ID record every time it comes in here. So anytime save is called, it's going to set that ID record. So save on an existing record is not something you want to do. So we could throw an error there and say that we don't want to destroy a record, but we don't need that variable anymore. So that should work. All right, and so that's a save. So again, we're just refactoring, and this is refactoring on the fly, which is kind of not a good idea. This is going to change to create. And now I don't know if the code works, and I just made changes. So let's do this again. So I just reversed out what we just did because I changed this to create. And this is going to be save. Let's go ahead and change this to create. Not that this matters, because post mapping is what happens here. It's going to call this function no matter what I call it. So that's going to work there. And let's restart this. So part of maintaining an application and adding to it is refactoring. And the refactoring is changing the code to have it make more sense as you add more code. So it's almost like a self-design. As you're incrementally improving the application, it is designing the way it should be designed naturally as you do the programming. So always refactor first to shape it into the way you want it to be shaped for the next functionality coming in, and your design will always follow suit. Sometimes if you don't, most of the time, if you don't do that and you keep adding code, your code gets more fragile and harder to maintain. So you want to keep refactoring, then add code, and then refactor, and then add code. So you keep following that pattern. Okay, so is this running? I don't even know what happened here. Let's go ahead and close this and then run it. I don't know if I started talking before I hit start, I think. I'm not sure. All right, so back to our record here. This should be empty. Create a new record because we just refactored. That's working. Refresh. That's working. And this is working. 405. Okay, now we're back to adding code. We've refactored, and now we add code. All right, so now it's a little bit cleaner, I think. Okay, put mapping and public address is what we're going to return. And this will be update address. And request body, and then it's going to look very much the same. It's really just a different name. And then the service has the different functionality. So in this one, we're going to return address service, a method that does not exist yet, and we'll just call it update, and we'll pass it the address. Okay, so now we have to create this, and I think we can do Alt Enter. Nope, that's a different IDE. Command dot. Okay, and this is create that method. Okay, and then I'll hop into it, and it is empty and just returns null. So now what I want to do is modify that record. So we've got an address that's coming in, and it should have an ID if it's this method's being called. And it's a string ID. Okay, and with that, I'm going to get addresses. Actually, I don't need to get it. I can just put it. So let's do a put on that ID and put this address in it, and then return the modified address. Okay, that should work. Let's stop our server and restart it. Okay, we should be empty. Add a record, save it, refresh to get the record to show the link right. We'll have to fix that in this part for sure now. All right, let's change the number. And if we hit save now, we get a 200 back. And we added the record to the bottom, which is, that's what we told it to do. We need to change that behavior, but it actually did do it with the record. So our server side's working. Now we need to fix our client side. And if I refresh that, you'll see that the record on the server is correct. It did get updated. So the client side is the one that's adding this extra record that doesn't need to. So that actually worked as far as the server is concerned. So now let's fix our client. And that is in our index.html. And so that is going to be in the part where we get this update. Where is this? So this is getting our addresses, and this is the one we want right. So we need to copy this href right here, because we need that to fix this part. When we do a post or put, we're getting our record back, and we're just putting the address without putting the anchor in. So let's go ahead and paste, and that'll give us the address ID there, and then we have to close the anchor. All right, so let's go ahead and refresh and see what that does. So we have to add a new record to see the functionality. So we're going to add Tom, we hit save, and now Tom has a link. And if we change to Bob, nothing worked. And if we change to Tom, nothing worked. All right, does Bob's address change? That one changes. That one changes. So it's changing the link, but nothing is happening with the record. All right, now we have to investigate and see what's going on. So in our hash change, something's happening. So let's use this inspect tool here to get this element and see what's in there. We've got a TD. Got an href with the ID record there, and it's changing this. So our hash change is not doing something we expect. So here's the hash change. Let's debug that and see what it's doing. So the way to debug it is we've got this open already. Let's click on sources, and then let's go to wherever that code is, which I don't remember where it is exactly. Looks like it's here. That's the one that does that. So its hash changes down here. Let's put a breakpoint right there. All right, so let's change the hash. And let's see what's happening. Let's open this a little bit wider. Oh, okay, it didn't help because that other thing opened up now. Okay, we could probably do it this way. Ah, there's an error. Undefined address. .id. So something is wrong with this. So address is saying that it's undefined. Okay, so let's see what happened. Back over here. So we've got an address. We've got address here. And it's saying ID is not defined. Is that true? Could be true. So whatever loaded the record. Oh, I know what it is. We're getting it from the hash, but we didn't add it to the record right. Okay, so here, when we do the, this one's doing the get all, we're actually populating this, map with the address, but we're not doing that when we get it after the post and put. So here's our post put method. We're getting the data here. We're putting the ID in here, but we're not actually populating or filling in the addresses with the update. So what we want now is we have the address, so we don't need this. So we're going to populate the addresses collection up above our map with the ID set to the address, so that way we're updating it when this comes back in. That should make this work. All right, let's try this again. Now, just so you understand what's going on, and I'll explain it again. Where is that addresses variable? Right here. So I'm going to move it up just because now it's being used by this other function also. Let's put it here. All right, and not that that matters, but it's for visibility. All right, so addresses is here. It's a map, and we're similar to what we're doing on the server side. We need to have the addresses in there. So when we come down here and get this address back, it's going to sometimes have a new ID or sometimes have the existing ID, and but possibly an updated record. So what we need to do is update our addresses map, and that's what this is going to do. And that's what was wrong with the code down below. All right, so we can refresh this page. Let's move this back over. Okay, and then we'll put a record in. Okay, and then we'll edit, which we don't need to because it'll just do the same thing. Let's add another record. So I'm going to refresh. Oh, I didn't actually create the record. Or did I? Okay, refresh. That's weird, right? It's not working. So these are nice errors to have because we're having problems sometimes and we need to work through them. So method type, why is it returning empty to us is the question. Is it returning empty to us? What is it returning to us? Could this be broken? So let's go ahead and see in this debugger what's happening. I don't see, oh, I do see an error. Addresses is not defined. Oh, okay, that's interesting. So remember when we moved this up to here? Probably moved it in the wrong place. Yes, we did. This is now scoped inside of something else, so we're actually broke the code, and that happens. So we actually need it to be up higher. Okay, that was inside of a save function. And we need it to be up higher. So now it's up here at the top level, so everything can see this now. So let's refresh. Okay, and these are all the records we added on the server. So let's go ahead and stop the server and restart it. That'll get us to blank. Okay, restart. And that should get us to blank, and then we'll add Bob. Okay, and then let's add another record. I'm just going to refresh to clear the form. And then we'll add Tom. Okay, this is working the way you expect. Okay, now let's switch to Bob. Okay, that's working. Let's switch to Tom. Okay, that's working. Now let's switch to Bob and change his phone number. And we hit save. Okay, this we haven't fixed yet. And let's see if we refresh. Okay, we've got that now. So that is working, and we can still click on that one and click on this one. And notice it's got the updated phone number. Okay, so now we need to fix the part that's loading the record. So when we do the post or put, we need to not append the record, but we need to update the ID, the record that's coming in with this ID. So we're getting an address, and we need to find a record. So let's do this. Here's a TR right here, and that's the start of each record. So what we're going to do is we're going to put an ID there. So ID, and it's going to equal to the address dot ID, similar to what we have for the link. All right, so that's going to give us that attribute. So now we can uniquely identify the table row. We need to add the same code to the thing that's doing this. And this is probably another point where we would refactor this template out, but let's not do that yet. We can do that a little bit later. .id here. Okay, so now we should have address ID. And if we inspect using our element tool, we've got the ID on the TR, which is what we want. Now we should be able to find the element by ID when this comes in. So when this record comes into here on a post or put, we're going to get down here and we're going to see the address, we're going to update it, and then here we're going to do this with records. So what we want to do is, let's do a find first. So we're going to document.getElementById, and we're going to use address.id. And that's not going to change in this context, so we'll just make that a const, and we'll call it element. All right, so we're either going to get one or we're not going to get one. If it doesn't exist, it should not return us an element. If it does exist, it's a record that we're going to update. So what we're going to do here is if element, meaning if the element is found at all, we're going to do an update. Otherwise, so else, just like the Java if else, we're going to do that. And actually, we might be doing that no matter what, but it's an update on what we're doing. So we have to do this template part no matter what, and that is not different. So let's do this here. The part that is different is what we're updating. We're either appending it to the table, and this one is if the element exists, so it's the element does not exist here, or we're setting the that's going to be tricky because this template might need to change. So we are going to change the template. So I'm going to take this down here and you'll see why in a minute. So this one is the table itself and we're going to append to it. So we need to put the TR. The one up above here, the element does exist, and that is going to be our TR. And so we want this template to be a little bit different. We're going to change and remove this because this already exists. It's already there. We don't need this part, and we don't need that part. And then what we're going to do is take our element and set its inner HTML equal to our output. So did you see how that worked? This is the TR that needs to be added because it doesn't exist. This is an update to the TR that already exists, so we don't need to put it back in there. So that's why our template did have to change. And scope-wise, this variable is defined within this function block or code block, and then this one's defined in this code block. So even though the name's the same, it's okay because they can't see each other. All right, let's see how that works. All right, so I'm going to refresh. We've got Bob. Let's change his phone number to a 4 this time. And we hit save, and it should update this record. Hey, it worked. All right, and then we should be able to update Tom's record, and let's just make it more obvious. And ready, here we go, save. And there it updated Tom's records. Okay, so now we've got update on the server working, we've got update on the client working, and the next step will probably be delete a record, which means we'll add a delete button, and then any kind of refactoring we have to do at the start of that. I could probably see some optimizations that need to be made, and we'll see how that goes in the next part. Okay, thanks for watching. See you in the next part. Hi, everybody. Okay, so we're back with what could be the last part. Well, this actually probably won't be the last part. We'll have one more, at least one more. But what we're going to do in this one is add delete. So we have get, we have post, we have put, and now we're going to add delete to round out the API. So that means we can get records, we can create records, we can update records, and now we need to be able to delete records. So we're going to go ahead and add the delete button right next to this on the client side, and then we'll add the server side REST controller to handle that, and that'll be delete, and then we'll have to remove it from here. So we're going to bounce back and forth between the client and the server. So what we have now is we can click on records, and they'll appear up in here. So then we just need a delete button right there. So let's go ahead and go into our client-side code, and that is index.html, which we happen to be on. And let's go ahead and find the button. So we've got a button here, and that is our submit button. So we actually just need a regular type button, not a submit button. And then we're just going to call this one delete. And Now these are classes here, and we'll learn more about this in the front end courses, but this is a Bootstrap button primary, so they have different colors of things, and I don't remember which one's which, but I think danger is one, and that should be red. All right, so here's another Bootstrap thing. They have everything layout is broken into columns. So 12 is the full width, so call 12, it means it takes up 12. So this would mean that it's going to take up 12 for this button and take up 12 for this button. Let's go ahead and split that. And actually, I don't know if I want to split that. Probably what I want to do is let's just do this. And I don't know what this is going to do, but let's see what happens. So if we put this on another line inside of this column, let's see what it looks like. Refresh the page. Okay, that's what I wanted. All right, it's got a save and a delete button. So if we click the delete button, nothing happens right now. So we need to add a listener to the delete button. So we probably have one on our form for submit, right? Let's go ahead and add an event listener on that delete button. So I kind of know how to do it because we have this here. And it's going to be similar. We're going to get the button and we're going to add an event listener on click most likely. But let's pretend we don't know anything right now, or at least not enough to know how to do it. And let's do MDN, Mozilla Developer Network. And we want add event listener button click. Okay, so it's event target, add event listener, type, and listener. So we could use the syntax. I'm sure they have examples down here. Mozilla Developer Network. Documentation is really good. So they got null no with options. Here's some examples here. And then here's a good example there. They've got their modify text button here. For reuse, that's good, but we only need this. So we're going to get an element. Let's just copy this because that looks good. You really shouldn't copy, though. So I'm not going to copy because I need to start kind of doing it like you guys do. I've been doing this for a while, so copying is, I don't know, not really supposed to be doing it anyway. So let's go ahead and just try and do it. All right, so we need to get the element, so let's do that. We're just going to add it right here. So const, because it doesn't change. And let's call it delete. Delete's probably not a good word here. Probably a keyword. All right, so delete button. And then we're going to do document.getElementById. And we're going to get delete. So I'll have to add delete to the button as an ID, which I have not done. So let's go ahead and do it here, right at the front. ID equals delete. All right, now I can get delete. Where's that? There it is. Okay, and then next thing I want to do is similar to what's up here. I'm going to do delete button. Dot add event listener, and the ID is helping as well. We wanted click is what it was, and then it was a function. It takes an event, and then I can't remember what the third parameter was. I never really used it. False. I don't know what that means. Let's see what it means up here. They mentioned it up at the top. Options. Use capture. What is use capture? So optional capture is a Boolean indicating that events of this type will be dispatched to the registered listener before dispatched to any event target beneath. It's fine to leave it blank because that'll just end up being false by default. All right. So then here we're just going to console log out that it's doing it for right now. I just try to get to something quick to verify that it's wired up right before I get too far. All right, so back to the address book, which is here, and refresh and delete. Okay, we've got the delete action working. All right, next thing to do is send a delete request to the server. And it's probably a fetch thing. Let's see how we do that. So again, and I probably have one over here, but let's pretend it's a fresh search. I'm going to start having a billion tabs open. Okay, so mdn url fetch delete. How about example? delete HTTP. All right, let's try this one because it actually has the word URL fetch in it. And let's search for the word delete. Okay, those are methods. And there's a header. Okay, doesn't really tell us much, but it's giving enough information here. We just want to fetch with this method. All right, so we can do that. We have enough code over on our side to do it. So it looks like we just put a delete here. And, well, let's see what happens. Okay. Let's see if we have enough to go on. All right, so we've got in here, we're going to do fetch. And we're going to call addresses. And let's put the ID right here as a path parameter. Okay, so whatever address we're doing is the one that we want right there. So let's get our ID. And how did we do that before? Did we do it up here somewhere? Okay, document element ID. That sounds great. Let's do that. Okay, so we've got value, semicolon, and it's a constant because it's not going to change. And we can paste it right here. Or not paste, but append it right there. So fetch is going to fetch this address with this ID, and we're going to fill in the body, and our method, which is here, is going to be delete. That should actually be enough, but we want to get some other things here. So we've got a response. I don't know if we're going to return anything, but maybe we should. All right, so we've got a fetch method delete. This isn't a good one to look at, or maybe it is, but let's look at a more complete one that we have up here. This one's got the method, the headers. They don't have a body. We don't have a body, so we just need to close that right there. So we need to close this. We don't need the comma. And then we can add the response. So we have dot then, and then we do response. And that goes to response JSON. Will we return JSON? I don't know. Well, let's assume that we do for now. And then we probably just want the response code, really. Let's see what we have here. Let's just do this one. I don't think we need to do any more than that. So here's that. And let's correct the indentation. Wonder why that went funny. Okay, that ends there. This is complaining about something. That's there. This. Something's complaining. All right, so we've got that fetch being closed there. All right, that's better. So we need to put the comma here. So it's the URL, then here's the body that goes in, and we can confirm that looking at our working one. There's a comma, there's the body. So that's what was wrong with this one. And now we've got a response coming in as OK. If it's not OK, we're going to throw another exception, and then we want to catch an error. And I'm taking this from our own working example. So I'm OK copying and pasting that one. But again, while you're learning, don't copy paste. Okay, it's complaining because there needs to be a curly brace that matches that one. Okay, I expect an error because we don't have a server for this delete button. But let's see what happens. And it's actually a good thing if we get an error because it means it's wired up right. All right, so let's add Tom over there. How about Tim? All right, ready? Let's clear this by clicking the clear console, and we'll hit delete. All right, we got an error, which is good. 404, not found. Okay, so now we can go to our server side and add our controller method. So back on the server, we go into our addresses controller, or address controller, and now we're going to add delete mapping. So let's go ahead and do @delete mapping, and public. We'll return back the address we got, and let's do delete address. And we don't have a request body at this time. This time we're going to have a path param, and that's going to be the ID we want to delete. So that's a string, and it's ID. All right, so what does path param actually mean? And it's complaining, so I hit, is it command dot in this one? No. I'm confusing my IDEs, so Alt Enter, that's IntelliJ. Command dot is this one. So it doesn't know what path param is. Either that or there's no path parameters defined here. So we've got addresses up here already. So we should just be able to do this in quotes and then ID like that. And path param probably needs that. And then this is complaining because it doesn't return, must return a method. All right, so then what we're going to do is let's get it from our addresses collection. Oh, from our address service. And do we have a get? We don't yet. All right, so we're going to add that. All right, so we don't have an address yet. Let's make this. So if I do command dot here, create method, and then I should function F12 in. Okay, so now let's get an address by returning addresses. Wait, we're on Java, not JavaScript, so I want to do a get here, ID. All right, so that'll get us our address. And so then when we go back to our controller, it's complaining because we're not returning anything. So now we can return this address. And really, I could shorten this because if I'm not going to use the variable, I don't really need it. So a cleaner, more maintainable thing to do is to just do that. Okay, so now it's going to return the address. But actually, I did need that because I am going to delete this address. I only need it to return it. So then here I'm going to do addresses. Oh, it's address service. And I'm going to add the delete method, ID. Okay, and then we're going to command dot to create the delete method, and then function F12 to hop into it. And then here we're going to do addresses dot remove ID. All right, that should get rid of it. All right, so now let's go back to the controller. And we've got delete, and we're returning the address. Now, delete probably returns what we want. Let's see. If I do remove, what does it do? I'm going to F12 into the code. It's going to return something. It returns the previous value associated with it. So it would give us what was there. And that's probably not a bad thing. So if we come back here, we could actually clean up some of our code, as in we don't need to make this get call. And we can just return this. And why does return void? Because we didn't allow delete to actually return anything. So let's hop into that with F12, and let's do a return. And we're going to return the address. All right, now it should be happy. So we need to restart the server. All right, let's see what happens. Okay, well, here we are on the server side. I'm going to refresh, which we restarted, so we're empty. So let's go ahead and add a few records. Let's add Tom. And let's go ahead and add Tim, and we'll delete him. There he is. All right, so we're going to save that. So let's go ahead and select a couple records, and we have Tim, and let's hit the delete button and see what happens. All right, we got an expected end of JSON input. What actually happened? I don't know. I don't see an error here. Let's refresh this page. Okay, Tim is still in there, so my guess is it didn't delete. So here is where it would have come in. So let's do a breakpoint, and let's restart our server with debug, because I am not sure what's going on. So let's do debug. All right, and we've got a breakpoint over there. So now we need to refresh because the records are all gone because we restarted. And let's do Bob. Clear the form, and let's do Tim, and we'll just delete Tim straight away. Select Bob, select Tim, and delete. All right, here we are. We have not an ID. So this path param, I might not have done this right. That's very possible. So let's see. How do we do this? Let's do spring boot path param. Path param versus path variable. Might have something wrong there. All right, let's do this. Request mapping. Let's do this. Spring boot delete mapping, and we want path variable. Maybe it's supposed to be the path variable that I used. Let's see, delete mapping. Okay, so we have a delete mapping with an ID. We've got our resources pulled up. Stack Overflow is usually a good source. So for delete by ID, mapping is fine using a path variable. So, oh, okay, that looks right to me though. All right, delete mapping resources. So value equals name. That's interesting. I don't know if I like this answer for being clear. For delete by name, you can take the name as a query parameter. Well, let's try it and see what happens. Oh, I don't see that much difference in this because I think the default is actually the name. So let's go ahead and put value equals. I don't think that's going to matter though. But let's try it. All right, so we're going to go ahead and let this run through since we made the change. And we'll stop the server. Okay, and let's restart it in debug mode. All right, and let's try and delete that record again. I don't think that makes a difference, but maybe it does. All right, Bob's there. Let's go ahead and clear the form and add Tim. Select Bob, select Tim, and delete. Still have null on there, so that didn't make a difference. So something's not quite right here. So we're posting to addresses, delete. All right, so let's go back to Google and try and find a better answer. Let's use this one. This is a tutorial. So they're telling us how to do it. It's got the Maven dependency, so they're setting up a full example for us. So we just have to go ahead and find where they're doing what we want to do. And they've got delete mapping, value equals posts, ID, path variable. So I think path variable is the problem. Let's try it. And do they have, so they've got that going. Okay, so value is this value of the mapping. We've got our addresses up there, so we should just be able to do /ID here. And then let's see if our variable gets filled in. So my guess is we don't have to do this value because I don't ever remember doing that before, unless there's other things with it. So that should just pass that into here, and that should work. Or maybe it's here. Let's see what happens. Because they're not doing a path variable with the name here. Let's do what they're doing. So I think it's going to use this ID and capture it here. So let's try it. There's a lot of magic that Spring Boot does for you automatically. All right, so restart the server. And really, we're just looking for the ID to be filled in. Could not open application. Okay, and here we go. All right, so restarted, so we need to add some records. Okay, let's delete Tom. Yeah, there's a lot going on here. Sometimes the IDE gets confused when there's too much going on. I must have too many processes running. See if we could stop them all. All right, looks like everything stopped now. Let's see. Debug. Okay, we'll try that again. Refresh. Save. Clear. Save. All right, so now we'll select Tom and try and delete. Hey, there it is. Okay, so path variable is what we want. It's going to take the variable that we have here. There's our ID. That should delete it from there, and we're going to go ahead and just let that run through. And we did not get an error here. If I refresh, Tom should be gone. And he is. So now we need to go ahead and do something with the record we get back. All right, so now we'll go back to our client side, and we can leave this thing running. And what we want is our index page. And then we've got delete, we've got our response coming in here, return response JSON. Okay, let's do this with the data. Let's do a then, and data goes to this function block. All right, so then what is going to be in our function block? I am not sure. We've got address, so let's go ahead and call this address instead of data. Okay, so now we've got the address, so we can get the address ID, and we're going to want to remove that row. So we're going to do document, because we want the row that belongs to. So get element ID by ID, and we're going to get the address ID, because remember, that's what it's called on our table row template. And I think it's .remove, but I am not sure, so let's go to MDN, and let's say MDN element remove. And it looks like it's just element.remove. We can read the documentation, but that kind of looks like it. There it is, element, get by ID, remove. Okay, and that's what we have. So that should actually remove it now. So let's go ahead and refresh, and we should still have Bob because we didn't restart the server. Let's add Tim. All right, so now if we delete, it should delete from the server and delete from here. Okay, ready? Here we go. And we got an error instead. I can't say that's not expected. 405 error, what does that mean? Operation not permitted? I can't remember what that is. 405. Method not allowed. So it didn't allow the delete method. I thought we've already been using the delete method. We didn't change anything. Let's restart the server. That's weird. Why would it do that? Okay, here we go. We'll just run it this time. Okay, back to here. Refill in some records. All right, so let's see if we get a delete on this. Okay, that worked. It's just something goofy with the server for whatever reason, just needed to restart it. All right, so let's go ahead and create another record. Actually, if we created Tom again, he still filled in. Let's clear the form on delete. After this delete button, let's clear the form. So that way that's not still in there. Does that make sense? Because if we delete, the record's gone, but this thing's still here. So if we save, we get it back. Nice feature, but probably not what we want. So after the delete, we want to clear the form. So let's see how you clear a form in JavaScript. So let's do mdn clear form JavaScript. Form element reset. So we're going to get the form element and then call a reset. So let's find something that gets our form, although we could probably figure it out. Okay, we already have it. It's right here. So we could just do form on this. So after that's removed, we're going to do form.reset. I wonder why it wasn't helping with that. All right, here we go. All right, so Bob's there. Let's add Tom. All right, and then let's delete Tom. I see what's going on. That ID isn't filled in when the record's coming in, so it doesn't know what the ID is. So that's what's going on. So if we refresh this, now it'll work, just because the ID is now filled in. So if we delete, it's gone and it cleared the form. So let's go ahead and explain that a little bit better. So in here, when we do our post or put, we're not filling in the ID, which I thought we were. So let's see that, because that seems to be what's going on. So let's see what happens. So let's go ahead and add Tom back. And we're going to hit save. And if we go to Bob, let's delete Bob. Okay, that deleted him fine. All right, now let's delete Tom. And I expect this to error. Nope, it worked fine. All right, try again. Let's add Bob. Let's clear form. Let's add Tim this time. What happened to our record? Oh, it must have been in edit mode. Let's refresh, see what we have. Okay, so let's try this again. So we've got Bob, save. We've got Tim. Okay, make sure the ID is changing up above. All right, let's delete. Okay, trying to track down this bug. And delete, that works. Save. And delete. Okay, it's working fine now. Tim, save. Clear form. Bob, save. Hey, clear form. It edited this record. Did you notice that? All right, let's try this again. Tom, we're trying to duplicate the issue that we're seeing. All right, so that's a record, and this is here. So if I refresh and then add another record, okay, it adds that. So let's do clear form here, and let's put in Tim, and let's save. Does it change Bob or does it add? Okay, it added, so it's working fine. And if we click delete, that's when we get the error. So we just added the record, and on delete, it couldn't find something. All right, so let's see what. So we're still trying to duplicate the problem. All right, so let's refresh, and let's select Bob and delete. Okay, that worked. All right, let's do David. Save, and he's still in there. So how about delete? Okay, that worked. All right, how about? Oh, I think I know what it is. If we change records. Save. delete. Okay, I think I know what it is. Let's go here. We'll add Bob. Okay, he's there. We're going to go to Tim, or Tom. We're going to go to Bob, and if we delete, it should break. Nope, it works. All right, we've got an intermittent problem. We're at past 30 minutes, so let's go ahead and stop this video, and we'll get back into debugging this problem, and that might be the last video that we do in this series. Okay, that's it for delete, and we've got a full REST API. We have a client-side issue that we're going to resolve in the next part. Thanks for watching. Hey everybody. Okay, we're back, and we had a problem with delete before. Sorry if you heard that sound. I was adjusting the microphone. We had a problem with delete before, and it wasn't knowing what the ID was. And we had problems duplicating it, but it looks like the problem was the ID record's not getting set here, this hidden field. So let's go ahead and create a scenario. We'll hit save. And then let's go ahead. Oh, I added this clear button. Should that still be there? Yeah, I guess so. Doesn't do anything yet, though. Okay, so we'll wire up that clear button, too, while we're here. So if I add another record, let's go Tom, save. And if I delete, nothing happens. Save. Tom happens. Delete. Nothing happens. Save. So you can see here that it doesn't know what the ID is, because that's what's happening, even if I hit save. So we've got multiple problems all stemming from the same thing. Delete doesn't work, which delete isn't doing anything right now. It's not even clicking the button. So let's see, does it delete now? Now it does. Delete must have a catch on it. So let's go ahead and see what we have here. And the delete button. See here, the delete button's got this return. I don't remember if it was there before or not. I might have added that while I was debugging to see what was wrong. So if we didn't have that, which I don't think we did, this is getting the ID value, and then it was going immediately here and putting nothing, which would then result in the error that we were getting on delete. So checking the ID first. So we're going to put an if statement. If not ID means if it's false, if it's falsy basically. It doesn't exist, it's false or whatever, return, because then we don't have anything good. So that's actually what was the problem. Now, the ID should be filled in when you click on that record. It should be there when you add that record. If the form's blank, it shouldn't be there, which it wouldn't be. So that's part of it. You could probably hit delete when there was nothing there, like when we very first came into the form. So having that check is good. Now, we need to have that ID filled in. So one of the problems is, from that, we have this post or put, and when we come in here to actually add the record to the table, we're not setting it anywhere. We've got the address ID, but we're not actually putting it on that hidden element. So what we need to do, it's this one getting, get element by ID, address ID. So this one's getting the row. So what we want to do is use something to document.get element by ID, and we want to get that ID field that we have in that form. And I'll show you which one it is. It's this one right here, this hidden input, because we're not setting it. So when it comes in to delete, or when we go to edit a record, it doesn't know. Well, editing a record actually does populate it, but after a save, actually it was a save of a created new one, a newly created one. This value wasn't set, so when we hit delete, it was removing it. So what we needed to do was in here. Where'd that go? We needed to get the element by ID, and then we needed to set its value equal to the address dot ID. All right, now that'll make that work. So if I refresh the page now, and let's go ahead and remove that if statement just for now, so we can actually see the effects of this. So we're going to refresh. So if I hit delete now, we get that error. Right, so we put the if check in, that delete wouldn't be a bad thing. So let's go ahead and select Tom, and we hit delete. Let's clear these errors so we can see. We hit delete, and it works fine. If we add a record, and we save, and then we delete, it deletes the saved record because we put that ID in. Now that would have been another issue, that it wouldn't have been able to delete because that ID field wasn't set. So that takes care of that. Now we have a clear button. Say somebody's editing and they don't want to edit anymore. So you should be able to press this clear button and it clears out the form. Now that was easy enough to do. Let's see, it's just setting the button to be a reset is enough to actually make it do that form thing. Now, the problem with this is it will probably not clear out that hidden field. So document.getElement by ID, and let's see if that ID field still has a value. It does. So let's go ahead and be explicit about this. There's that value. So even though there's not a record selected, it still had that old value. So what we want to do now is add an event listener on this reset. So where our other code is for the form, somewhere down here, we've got an add listener for submit. Let's go ahead and do a form.add event listener for reset. And we just put it in line. We don't have to have a save, or like we do for the save function. We just put it right here. Let's go. All right, and then what we're going to do is document.getElement by ID. That ID field, you gotta spell it right. And we're going to set the value equal to nothing. Now that'll clear that out. Okay, ready? Let's go ahead and do this. Refresh the page. We'll add a new record. Tom, we save. All right, so now our ID is probably set. All right, and then we're going to do a reset. And it's empty. So now it's not there anymore. So if it goes into that delete thing, we still have that error, so now we're going to go ahead and put that delete check back and say if not ID return, which will immediately just say, it'll come here and say, I got nothing to do, and just send it back. And then we'll refresh. Okay, let's go ahead and add another record. Let's make it Tim in this one. All right, we'll save. Tim's added. If I hit delete, it deletes it immediately because now it has the ID set. And if I hit delete now, it won't do anything. Clear, delete, save. Save is still doing it, so now we have to check the save part. This is all part of finalizing what you've done. We've made it, we've got a full API, but we are testing it to see how the users are interacting with it, and fixing anything that could be messed up with it. So on this check, the save check's actually kind of difficult because if it has an ID, then it's okay. But we don't want to send anything blank. So you notice we had a blank record. So we sent a bunch of blanks down there. So we probably want to do some validation on this save. So we've got all this data. What we can do is, let's just do a check on some key fields here. So let's say if ID is not really the one we want to set because that's going to determine if we're going to do a post or a put. So that's not the one. But we can check email. So if not email, so that could mean that is blank. Or let's say not address one. So that this is kind of like making them required. So we're saying, let's not do the address. Let's just say somebody wants to be able to save the email. If they want to, they have to save an email, period. That's what they want. That's what the minimum thing we want to have them save. So then if there isn't an email address, let's just do a simple alert. And let's just say email required. And then we'll return. That's a simple check. And we're using an old style alert box, but that's fine. And then if we refresh, we're still going to have that blank record until we restart the server because it got there. So if we try and hit save now, we get the save button and we got another blank record. So let's see what's going on here in our debugger. The script is here. So on save, we have, there's all the elements. Let's do it. Oh wait, we need to be in sources. Okay, now we need some room. Okay, we need the save operation. Let's get a little bit more visibility. Can't go too far, otherwise that other thing will pop out. Okay, so save button, save button. Here it is. So let's see what happens when we get here. So we've got a blank email. Save. Oh, email is set to the document element value. That is weird. Oh, right, because it's in a data object, so we have to do data.email. Let's do that. See, email is actually getting the ID, getting the element by ID, because that actually by default, when you add an ID to an element, it automatically gets added to the window namespace, so to speak. And if you do an email here, it's actually set in Windows, so it's actually pulling the element because we have the ID on it. What we need to do is pull data, which is this name, dot email. That will get us the email that's here. Otherwise, we're getting the email element. So now let's go ahead and do that again. Let's let that run through. We'll have another blank record, and that's okay. So now we're going to try and hit save. We've got 2 blank records. All right, let's hit save, and we shouldn't have another blank record. So now it's going to say email is blank. So now we should get into that alert. Email required. We say OK, and then we return without saving another record. So it didn't add another one. So that's fixing that. I don't know that there's actually any more issues now. Let's go ahead and restart the server to get rid of those blank and test it out one more time. Oop, wrong way. This one. All right, so we'll stop it here. We'll go to the application and restart it. Okay, let's refresh, and all the records are gone. Let's get some space so we can see. We don't actually need this open anymore. Let's get rid of the breakpoint too. All right, so let's add a record. Okay, email required, so we can't just save right off the bat. That's good. We save Bob. We'll clear the form. Let's save Tom. Let's delete Tom. Let's add Tim. Let's delete Tim. Okay. Looks like it's all working. So now we've got an API, a RESTful API that does post, put, get, and delete. So a full REST API as far as CRUD's concerned. And then we have the UI that matches. And that's it. So that concludes this exercise and this part. And the Java crash course. So look for other courses that we have. The next one we're doing is probably on the front end. And thanks for watching.